Good morning again, ladies and gentlemen, and welcome to EASA workshop on U-Space from the concept to implementation. It is a great pleasure for me to welcome this workshop on behalf of EASA and our Executive Director, Patrick Guy, who unfortunately is not able to welcome you, but pass me warm regards. So, colleagues, we are here. We are here where we wanted to be, actually. So today is, in my opinion, a very good day for the U-Space community. We are not anymore developing concepts. We are not developing papers, white papers. We are now implementing. So we have come from a long way since the previous commissioner introduced the U-Space concept. Actually gave a name that identify how UTM will be developed, will be designed and implemented in Europe. And we are here now after 2016 when this was all started. So long way. We have gone from blueprints, we have gone from Chorus concept, we have gone from many CESAR projects, network of U-Space stakeholders, demonstrators. We have gone a long way. We have a draft opinion. We have an opinion. We have a regulation. We have a draft AMCs and guidance material. We have the AMCs and guidance material published, and now we are all working very hard to implement. The applicability day is already there, was the 23rd of January, no, 25th of January, 2023. And as far as we know, we are all very busy developing systems, procuring systems, developing procedures, implementing procedures, doing applications. And here we are, is where we wanted to be. Actually, we did this because you asked. So the European industry on U-Space asked us to create a framework that will enable actually a drone service market, that will enable BVLOS operations and complex operations in urban environments, around airports, because you told us that it was very difficult to get authorizations to fly there. So here we are. So we are doing this actually for the European industry so that we can enable safe, and efficient, and secure drones operations. We don't have answers to all questions. We may not have closed all the gaps on the AMCs and guidance material. And this is why we are having this workshop. So this workshop is for us and for all experts that has worked with us. It's not only us as staff. So we have here representative and work package leaders such as Antoine, Alberto, Basilis, Elina. So they will be Jonas and Kai and also Andrew. So they will be presenting you their work packets, their respective AMCs and guidance material, and where we are today. We will be closing those gaps that you believe they are there, but we need your feedback, and we will highlight where we need your feedback as we present. So in the morning, I'm gonna actually opening the workshop. This is all for the opening, but I'm going to provide you a little bit of background on EASA. I think you all around the table now who we are, but we have about 800 people, plus here 150, 160, 800 people online, and here sitting 150, so we are nearly 1,000 people connected. We have people all around the world, so I will try to present what is the European Union Aviation Safety Agency for those colleagues who doesn't know who we are. So we are an agency of the European Union. We were established by the European Parliament and the Council. Our main principal place of business is Cologne. so headquarters, but we have office in Brussels, and we have also office in one representative office in Washington, in Canada, in Singapore. We used to have one in Beijing, but after COVID, we are now starting to take it back. And we have now one also in Panama. We have also a project office all across the globe. And through the project office, we actually announced that we will have this workshop. So you have colleagues connected from China, Middle East, and Africa. And I think also from Latin America, but I am not sure. So they will be all connected. So you will see for some people it's quite late or quite early in the morning. And you see the interest that there is in the European framework, in what we are doing, and how we are implementing. About EASA, we are 800 aviation experts and administrators. So we have pilots, we have a lot of aerospace engineers, and we have also traffic controllers and administrators in general. So EASA member states are a little bit more than the European Union member states. So we are 31 EASA member states. For those 4 member states that they are not part of the European Union, they implement the EASA system through votes in the individual legislative process. Important for those who are present in Cologne is the evacuation. Sorry, I need to be a bit picky on this. Is last conference, it was, or the previous one, we have an evacuation, and they insist that we need to be very clear how it is. So we are in the Airbus room. If you hear an alarm, follow us, but if it's become a bit messy because everybody's trying to evacuate the building, so just go outside in the front door where you came from and follow the green path. Actually, yeah, Alberto, maybe you can, so the green path. So, and actually the point where we will be safe in accordance with the experts on evacuation is in the parking place. Hopefully we don't have an explosion of the building, but you never know. If you are very angry, hopefully you don't have sentence bombs or something like that. But yeah, in the case of evacuation, please go as far as possible. Don't take time to take your belongings because it can be a fire or anything, and then we can be in the middle of the evacuation, and apart of putting ourselves in danger, we can put others in danger. So just as an aircraft evaluation, leave everything, leave the building. We will come back anyway. A little bit of house rules. As in any conference, please keep the mobile in silent mode for respect to the speakers and others who wants perhaps to listen as well. So we are in the Airbus, so we don't have, we are not in the middle of the EASA's office, but if you see the other colleagues are in other meeting rooms, so it's always, yeah, don't disrupt. I don't think you will be doing anything like that. We offer coffee, and we will be offering lunch. But if you don't like what we are offering, or you have any other special wishes, we have the bistro. Unfortunately, only accept bank card payments, and yeah, so no cash. So it's a non-smoking zone. If you want to smoke, you need to leave the building outside and come back. And so it's only allowed in the front of the building. So one important thing, don't open the IT floor tanks. So this type of things is not possible. And don't use the wall plugs. Actually, I learned this morning, this could prevent evacuation. We take it very serious, sorry, the evacuation in case of emergency, so they can fail people out. So don't try to use the wall plug, sorry for that. Luggage is not permitted in the middle of the room. And the reception has a room where you can put your big luggage And our colleague, actually, Laura Anaco, sit there. So she will be helping with all these topics. So she's helping us with all these topics in case you have doubts where to find things. Restroom rooms are indicated in yellow. So they are when you go out of the Airbus room. So first to the left, or go to through a little door there, close to the Boeing room, past the canteen, there another set of restrooms. Now, the drones team. So we have thought it's good for you to know who we are and where we are coming from. You, in the area of U.S. space, you mainly have been working with Ken Engelstad, who was the previous U.S. space project manager. And now you know for sure Stéphane Boubeau, who is the present U.S. space project manager. These are the people you have been working with in the past, actually 3 years or more. So today, Stefan is in all the subjects and is the main counterpart for you. So he is your focal point. You know me, Maria Olga Ruiz, EASA Drones Program Manager, actually since the very beginning of U.S. space. So I am reporting directly to the Executive Director in all topics of drones, urban and mobility, U.S. space, and I am more in charge to set the strategy direction of EASA in those areas. And I work in tandem with our colleague Sasha Schott, who is the drone section manager. So where all the project managers are belonging. So you see all of them there. So we have Alberto, who is, I think the title is not anymore up to date. You are not anymore junior professional. You are now officially a drone project manager for various topics. And then we have Thomas Oster. We don't have in the picture, but we have also Marco, who is working on the certification. So if you have issues with DVDR, so don't hesitate to contact Marco. So we have here, let's say, the colleagues who are in the drone section, but we have many other colleagues in EASA who are working in certification, which are your counterparts for the aspects of design verification or research or e-conspicuity. Is also Vladimir Foltin. I don't know if he's here, but he's also missing there. Then we have, Natalie de Rubo, Mr. Sora, we used to call him, but he is the drone project manager for the open and specific category. Giuseppe Scanapieco, Mr. UIM, who is the project manager for IAM and UIS certified category. Laurie, you know her, she's there, and she is the drone project management assistant, and she helps on every topic from technical to support. So I will say very good commoding. Justin Chirea, who is drone project manager, is new in EASA, and he is more working on standardization inspections and is a previous inspector. So this is the main drone team. Sasha, I don't know if you are around the table, just stand up. No, he promised he will be here. But again, so the drone section manager and responsible for the people and for the implementation of the drone program. Workshop agenda. So we have very two packed days with a lot of presentations and a lot of detailed material. And as I said before, we don't pretend to have all answers to all your questions. We will try to answer as we can. We don't have all the AMCs and guidance material, but we have what we believe a good set to start with that will be improved, that will be complemented and complete. And Stefan will guide you through the items that will be coming in the next couple of years as he will be presenting. So we have today more concentrated on what is the US space, main principles, so the basic, so the very basic stuff. And then we will go through roles and responsibilities in the U-Space. Aerospace, we realize it's necessary to clarify what are the roles and responsibilities of the different actors as it is foreseen in the regulation. So starting from member states, competent authority, coordination, then aerospace risk assessment, and then from the different providers, common information service, whether centralized or distributed, and then from the ATM, ATS providers, USSPs, UAS operators, manned aircraft, and joint responsibilities in area of quality of services. Day 2, we will go one by one service. So we will go into the details of what is inside the EMCs and guidance material for one by one service. And Stefan will guide us through expected evolutions. And in the afternoon of tomorrow, we will go through the certification framework, the certification process, and how we are at the moment thinking in the USSP single seat certification task force on how this certification could look like, what is expected, and what could be included. And we will close the workshop. So we will have a slide presentation, and we'll try to have 10-15 minutes for question and answers. For all people inside and people online, please use the Slido. We will not be able to monitor the WebEx, so the chat WebEx or the question and answer aspect of the WebEx. So here is the Slido QR code and passcode. I give you a few seconds to take note. For those colleagues which are in the room, and provided we have sufficient time, so if we don't have enough questions, you will have the privileges to also take the mic and express yourself. When you do so, please introduce yourself, name and company or administration, and put your question. So this is for the opening and basically the main administrative part of the workshop. And now we have the first block of the workshop, which is what is U-Space and what are the main building blocks and the main principles. And for this block, we have two presenters, so myself and Stefan Boubot, who will take the slides, the more detailed slides. So I think I have said already in my introduction, but it's good to come up to present the path that we have all gone through, and that it has been a long path, that it has actually shaped the shape and the way we are today. So we started with the Warsaw Declaration, in which it was already requested that at very high levels, so Director Generals of Civil Aviation Authority, DG, Commissioner, they all urge that in order to enable a true drone service market, we need to work on enabling then the drone safe integration in the aerospace. And that was basically one of the main conclusions of this Warsaw High-Level Drones Declaration, who was on the 24th of November 2026. And the name U-Space, actually, it was given by the previous commissioner. And why we didn't give the same name than the rest of the world, called UTM, we gave U-Space. And it was simply to have a more trademark for Europe. One could say there are different aspects, but it depends again on the implementation. The implementation could be exactly the same than any other UTMs. But U-Space, it was the space for you, for the UISs. Of course, we are not segregating the aerospace, but it was something that, if I understood well, the previous commissioner, they wanted to have a U for your aerospace and a space for that is sort of characterized for UIS operators. So it's the aerospace for you, although it's not only for you, but it's an aerospace where you will have sort of privileges to operate. So that was the main concept. And then very quickly, okay, don't know. Something we need to worry about? No? Okay.
No.
Okay. So then we have very quickly after the Warsaw Declaration, we have Cesar joint undertaken, started working. I don't know who of you, I think many of you were in these famous three working groups that is starting working on the different aspects of the ATM master plan development for UISs. And there was, as an output of these working groups, there was the so-called U-Space blueprint, when the different phases of U-Space development were included, so the famous 4 phases, with a different set of services. And this was also the beginning of a lot of research activities. So there was launched a lot of research activities in different phases of from exploratory to more high level of TRLs. But they were the launch of many research activities for which many of you have been participated and you continue to participate. That was, the publication was in June 2017, so 5 years ago. Then we have the launch of the U-Space network of demonstrators, which you know Munish Kurama. So he is the main focal point from Eurocontrol, but it's a joint adventure so between Eurocontrol, EASA, and Cesar joint undertaking, but it's mainly managed by Eurocontrol in the sense of secretariat support and active management, and is obviously established by the European Commission. So that was established again by the previous commissioner on the 19th of October 2018. The launch was in Antwerp, in the port. We were, I think, many of us there already. And since then, it has changed name. It's not anymore demonstrators, and it's adapting obviously to the reality. It's now implementing, and it's called Network of U-Space Stakeholders. So another piece of work. Then we started the regulatory developments. We started actually with a very small task force led by co-led by the European Commission and EASA, and with participation of member states. And actually, I didn't have here, but also we have, I think we have Eurocontrol as well. And what did produce? We produced an opinion, who was sent to the European Commission in March 2020. So when the COVID started, so we don't know if this was casualty or, but yes, it was when the COVID started. Then during COVID, it was all the legislative process that led to the adoption of the regulation that we have now on the table. That was in April 2021, so nearly 1 year. So pretty fast, all these regulatory developments, as you can see. Usually we take 3 years from the MPA to 3-4 years to opinion. But in this case, the MPA was replaced by a focus consultation in May 2019, and many of you were also sitting around the table. And we have then issued the opinion directly. And after that, we set up an expert group because it was one of the let's say, one of the requests of the member states when approving the regulation is that we need to have a comprehensive set of AMCs and guidance material to support the implementation, since the regulation was very high level. And this is what Ken and now Stefan has spent the last year actually working hard with the expert group and the group leaders to develop the comprehensive set of AMCs and guidance material that we are discussing today. The regulation entered into force on the 25th of January this year, but in November last year to end of October last year, we have the Drone Strategy 2.0. So that is leads the green and smart mobility strategy. And in the drone strategy already set very high strategic objectives on the implementation of US space aerospace for the next 5 to 10 years, which again put pressure to us all here around sitting around the table and those online to do the work. So there are objectives there. They have been agreed by all the European drones leaders and DGs, and we need to deliver now. So we need to implement and deliver. Right. Here, thank you. From here, I don't know why I wasn't here. Okay. After this history background, we are now going little by little into the more technical details. And I will start with the first, and then immediately we'll give the floor to Stefan, who will follow all these details. So why US space? What is the problem we are trying to solve with all this work? So that is the question many ask. So where was the problem before? And why we need to implement US space at all? So as we said, it was already considered that US space is needed to enable more BVLOS flights until we don't have concepts for separation, until we don't have a fuel ATM or whatever we're gonna call UTM, US space flash, for enable true integration between unmanned and manned traffic in the same aerospace. And we are able to have the so-called detect and avoid system. Not saying is the only thing that will enable true integration, but it's of course a very important enable. Until we don't have that, BVLOS flight has been taking place in various locations across the EU, but the authorizations were very difficult. Actually, in particular, not only the ground risk and the SOAR application, but the air risk was, depending on the areas, were very difficult, leading to temporary restrictions or temporary segregation of aerospace, ad hoc creations of NOTAMs, confusions for manned traffic, the hands operators complaints. So it has been possible, but it has not been very easy, not clear, not harmonized. So UIS SORA, so for those who are operating in the open category, they need to use the specific operational risk assessment to obtain an authorization, has obviously an air risk part mitigation, which at the moment only include manned to unmanned traffic air risk mitigation, but doesn't include ways on how to mitigate unmanned to unmanned traffic, and whatever the risk associated to that possible collision, obviously. This is to be considered that as soon as there are no passengers on board, obviously we are talking about different safety levels. So in addition, and this is also a very peculiar aspect of the drone operators' operations, because they are low level, but also because of the easy accessibility to this type of aircraft and this type of operations, we need to consider other risks that we were not very much used to. Okay, environment is becoming in the whole aviation sectors, environment sustainability a huge risk to consider. But now security and privacy. And this is also an aspect that is very close to the development of US space. And as I said, we cannot continue establishing temporary aerospace restrictions which start confusing people. So what we want to achieve is actually the right-hand side picture in which we have US space and we have clear rules for the UAS operators, for the manned traffic, for the ATS providers. This is what we want to achieve. And at least in the first phases of US space implementation, we have an harmony cohabitation. It's still not integration, but it's getting there. What we don't want is to have in these two, which is only one operator with one manned traffic, or areas where manned traffic is not allowed because UAS operators are operating. This we don't want. So we want this picture. And this is where we are trying to head. Stefan, please, the floor is yours.
Thank you, Maria. So thank you, Maria, for the introduction. It's already set up the scene for the follow-up, and we are going to the details of USpace. And thanks to all for coming today to Cologne and for those who attend remotely. I'm very proud to present what is USpace today with you. As explained by Maria, we have today a wide audience with different backgrounds from ANSP, competent authorities, member states, operators, etc. And we wanted somehow to repeat maybe things that you know, but for the sake of common understanding, we wanted to represent some details and the principles which underline USpace and safety in USpace. So I will start by the regulatory framework that has been set up along the past years, as explained by Maria, and I will present the principles. So what about the regulatory framework? We have three main blocks. We are composed by three different sets of regulations. The one in the center is the most important for USpace. So what we call the 664 for USpace, because it set up the complete framework and all the details, starting from the role of the member state down to what is the certification, what are the roles of various actors, and the detail of the services. So that is really the centerpiece and the masterpiece of USpace, the 664, when you will have all the details of what needs to be provided and the various roles and responsibilities. So for sure, that's a regulation. This is some of high level. And as explained by Maria, we will have ANSI GMGM, which completes the understanding and the how-to, what needs to be achieved, how it has been achieved. And we are also integrating in this regulatory framework the impact on the rest of the world and the rest of the airspace, starting from what needs to be done from the air traffic management. For instance, there is not that much to exchange, but there is a new kind of interaction between USpace and the conventional air traffic management or air traffic control. So those provisions and what needs to be done by a traffic controller is detailed on the 665, which is dedicated to the update of the regulation for the ATM ANS. So it completes somehow what you know maybe already for the 373, with a focus adjustment for USpace. On the other part of the airspace users, we need to have some new kind of information to be provided by the manned aircraft. And we are changing the rules of the air, or adjusting the rules of the air for the purpose of USpace with regard to the manned aircraft. And this is what we call e-conspicuity for potential manned aircraft which may transit over or inside the USpace airspace, and they have new obligations. Those new obligations are very basic. They must be visible to the operators in order to ensure safety. So I will explain how. So, but just to tell that we have three blocks. Again, the one on USpace, the one on ATM, and the one on manned aircraft. Just an overview of what has been done today on this regulatory framework. As I said, the regulation set up really the background and the foundation of what needs to be addressed in the U-Space airspace. The regulation has been published in 2021, but the regulation itself does not provide all the details. So for that, MCGM have to be created to support the implementation of the regulation. The MCGM have been published, the NPA has been published in December 2021 with comments that we received last year. We received almost more than 2,600 comments, mainly focused on the 664, which is the centerpiece of the regulatory framework, so no surprise about it, and from a huge diversity of stakeholders, starting from, for sure, the authorities, but various associations, industrial associations, USSPs, etc., etc. So it has been a huge work last year to integrate the comments and to adjust the MCGM, targeting and successfully targeting a release of the final set of MCGM December 2022. So the regulation has entered into force with the associated set of MCGM. We know that there are some areas that need to be completed, adjusted, certainly, but we believe that what is there today is already a big enabler compared to the situation of some years ago in order to start the implementation. And we are already envisaging some changes, either to adjust the content or to complete, because we know that some areas we had no time to make it complete. So there are areas which need to be completely worked in the coming months or years. So what is U-Space? As said by Maria, U-Space is an enabler to foster or to trigger much more dense drones operation. So it's not a new kind of class of airspace. It's a piece of volume of airspace which will be designated, so dedicated to host drones operations. That will be a new kind of geozone, which will be designated by member states. So they have to decide where to designate this piece of airspace. Based on a risk assessment, as said by Maria, considering a new type of risk, for sure safety, it's not new per se, but security, environment, and privacy, which then complete totally the set of attributes or risks that are considered in SORA. And for what? What is the goal of that? To enable fair and efficient sharing of U-Space airspace. So today, on a daily basis, we have drones operation, but as said by Maria, quite often it's through danger area zone, an OTAM, which prevents the access to the other potential U-Space users. So it's not fair. And if we want to enable mixity, diversity of operation in the same volume, we need to have another tool. The goal is to enable dense drones operation. So it's not one operation in isolation, but something much more dynamic in terms of access to enable complex and long US operations, so specifically or particularly BVLOS operations, which today are quite difficult to be authorized. To enable operations in urban environment, that's really a key role of U-Space, and not forgetting safety. So that's clear, it's right in this bowl, because it's fine to foster the market, it's fine to host drone operations, but we must keep the same level of safety that we have today in the airspace. So between, for sure, for the drones operations themselves, but we also with regard to the other airspace users, so the manned aircraft. And that will be for sure a tool to ensure the safety of the operations of the drone inside the airspace. All those principles rely on digitalization and a lot of information exchange. So we have very, very little human involvement in the processings and the follow-up of the operations. We are looking for almost a full automation of the decision-making. For instance, how to give a flight authorization to a drone. There is no human. It should be totally automated in order to ease and to accelerate the access to the airspace. We will rely then for that on sources and input from various stakeholders, the drone itself, through the remote network ID, for instance, giving the information about the drone itself, but the traffic information coming from the ATM world, and as I said, the man aircraft, in order to provide all this information to the operators. And the key aspects and the novelty of USpace is that we are establishing and providing a new set of services. So 4 are mandatory and 2 are optionals. US flight authorization will somehow allow to give a flight plan or give an authorization flight plan to the drones operator to ensure decompletion of the drones operation inside the airspace. Geo-awareness will indicate where to fly, where not to fly in case of temporary restriction. Network identification will allow the operator to see and to make the drone visible and to see where are the other drones flying in the airspace. Traffic information is a bit similar to network identification, but from the manned traffic, especially the inconspicuous aircraft or the traffic that you have in the airspace, but through the ATM services, with information, local information and dedicated information to help the operators to perform properly and safely their mission, and conformance monitoring, which is a service mirroring US flight authorization, which will raise an alert if the operators is pushed out or leave the authorized volume. So that's as for the principles of the USpace. What about the model and the architecture? So we have a brand new type of organization with new actors and new organizations supporting the implementation of USpace. When something, a new type of service and a new type of organization somehow is the Common Information Service. So this service does not have an active or operation role in your space, but is meant to deliver and to provide the rest of the processes, the necessary information to support the USpace implementation. So some actors will be the competent authorities, maybe ITSP, USSP. So they will provide, for instance, the geozones, the definition of the geozone to the other users that I will explain. So necessary information coming most of the time from state information or ATM services. Antoine and some other colleagues will present you the variety of or the difference between different models that we have. We may have a centralized and decentralized models. Just to hint a bit of teasing that in a centralized model, we will have a new organization, which will be the single common information service provider, which will be a kind of data broker, which delivers the service with one interface to the other stakeholders. So all this information will be gathered through the SIS and provided to the USSP to let them perform their missions and then to provide the services to the operators. We have a new entity, USpace Service Providers, which will provide the services that were in the previous slide. So the 6 services, potentially, to the operators. And in terms of operators, we try to address different kind of operations, for sure, VLOS operations and basic operations, but we are also trying to address and to cope with very sophisticated operations with a lot of autonomy, where it's automatically almost totally hands-off in terms of operations. So we have two new entities, the single SIS and USSPs, which will be certified entities. So the USSP, again, will be the direct interfaces with the operators and will deliver the necessary information to support the safety of the operations. The certification will be granted based on the satisfaction or demonstration of the USpace performance requirement or safety criteria that will be presented later on. And as you can imagine, with almost totally automated autonomous systems, the software and cybersecurity aspect will be prevalent in the compliance demonstration, and will put a lot of emphasis in the safety and quality of those systems. So I would like to present you what are the principles which ensure safety in the USpace space. Very first thing for the maybe ATM community listening to us, we have 3 mitigation layers. The first one is strategic, is the USpace designation itself. So where to put the boundaries of the airspace to space to minimize or mitigate the risk. So kind of ceiling, limits, vertical, horizontal limits, etc., operational constraints, in order to mitigate the potential risk that have been introduced in establishing a use per se space. So pre-tactical, prior flight, we have the geo-awareness and the flight authorization to make sure that first, the drone flies or will fly in an authorized part of the airspace and is deconflicted from the other users, so the other drones. And tactical mitigations along the operations with a continuous flow information transmitted to the operators. So traffic information, where are the other traffics, conformance monitoring in case the drones or UA leaves the authorized volume, and geo-awareness, because suddenly one piece of the airspace may be deactivated or closed. So it's important for the operators to know that he must step out or let's not get in a potential piece of airspace which where it's not allowed to be. So all this information will be continuously provided to the operators. In terms of priority rules, there are some adjustments, maybe with the rule that we have today. Starting from the right, let's say in basic way, man operations have always the priority above the or over the drones operations. So man has priority about the drone. And the special operations have the priority over the rest. So the special operations could be either man operations, so helicopters for the police or fire brigade, etc., or drones operations. And for this particularity of special operations, drone special operations over the rest, we have some provisions in the Article 10 for the flight authorization, where it's clear that a drone has a priority on the rest for the drone. And GeoUAS operators have actually the ultimate responsibility in order to ensure the anti-collision, because this is what we want to avoid, a collision between drones or a collision with a manned aircraft. So they will be provided to, with all the necessary information to maintain their permanent situational awareness, to make sure that they are able to follow and properly conduct their flight, knowing all the context with regard to presence of not of traffic. So that's really the key item. The US operators will remain responsible for the safety of the operations, for sure relying on the safety and quality of the service provided to them. What about the dynamic separation or spacing between the various airspace users? So we have two different cases, control aircraft and uncontrolled aircraft. So it could be control airspace or uncontrolled airspace, but the distinction is important because in Class Eco, we have both. So I have been asked to speak about control aircraft and uncontrolled aircraft. So what about control aircraft? The control aircraft are managed by an air traffic controller, which is in charge to ensure separations and safety of the flight for the manned aircraft. In the U-Space framework, the air traffic controller have no idea of what's going on in U-Space. They know there is a box, a volume where drones operation may happen, but there is no visibility of what's going on dynamically. If a manned aircraft needs to transit, whatever the reason, they need to transit inside the U-Space airspace, they will have a mechanism called dynamic airspace reconfiguration. So they will have the authority to partially or totally deactivate the U-Space airspace. That will lead to the acknowledgement, the information will be provided to the operators of the drones, which will have to leave the U-Space airspace, so they can vacate to another part of the airspace or to land. And an acknowledgement will be provided to the air traffic controller. So my colleagues will present the details of that later on. In uncontrolled airspace, sorry, because there is a matter in the animation. In uncontrolled airspace, we don't have this controlled traffic or control aircraft. So the manned aircraft will have to be inconspicuous, so visible to the operators, and that will be the operators' responsibility to perform maneuver to perform a maneuver to avoid the manned traffic. And the main traffic, so I have not said that, but the main traffic do not have the operation, so this is the sole responsibility of the US operators to perform this maneuver. So what about the process of airspace designation? So my colleagues will present a bit more details about what needs to be done, but I want to provide an overview of what needs to be achieved. The very first thing for a member state will be to decide where, clearly. So the full airspace will not become a space airspace. It's a tool, as we said, a specific tool, but maybe there is no reason to set up the full airspace at USpace. This is a question I had in the passing. Then the full airspace should be USpace. No, the member state will have to decide where, based on various inputs. So it could be a national decision in order to foster economic development or technology development. But quite likely, the industry and the USSP and operators will be an asset in the discussion to say, we want to make business or to make market or to enable operation in that city, that area, etc., etc. And we try also trigger the need for the establishment of USpace airspace. When this location will be decided, we'll have two main things to do is to identify the impact in terms of safety, the new type of risks that are being introduced. So first to identify the new hazards and to perform a risk analysis in order to evaluate the mitigations that need to be introduced to mitigate or reduce the risk that has been introduced by the new space and the operations. So once again, in terms of risk, we are dealing with the conventional risk with regard to air risk, and in new space, the risk related to ground risk in case of mid-air collision. So what could be the side effects of a mid-air collision? The ground risk will be still part of the operator's duty in terms for their SORA, but we are also considering the new type of risk, so security, privacy, and the environment. Based on the analysis, we will have three main sets of items that will be derived from this previous analysis. The setup, the design of the space, and operational constraints, the performance requirements of the services, for instance, the latency, the type of information to be provided, and the US performance requirement. I come to that in a minute. And once again, that's the responsibility of the member state to establish all those activities. It will be concluded by a public hearing in order to involve the citizen in the discussion, because we will come back to that in a minute, but the public acceptance is absolutely a key item in the whole process. It's a new type of service, but it's also a new type of concern for the public, and to make sure that USpace and the services associated will be accepted. Particular care has to be pushed in discussion and involvement of the citizens. All those activities will be performed in constant liaison with the various space actors. That's a recommendation that will come also later on the discussion, but it's a constant discussion with all the stakeholders. It's a new item, it's a new type of processes, it's a new type of services. So it's very important that the designation process and all the activities are not made in isolation, but represent or involve all the actors. What about the USpace constraint and performance requirements? So as I said, the first block is USpace design. So for instance, the limit and the ceiling of the airspace. So we have a recommendation, for instance, to limit the ceiling at 500 feet to ensure separation, strategic separation with man aircraft. The airspace structure, some limitations in terms of weather. If there are some stringent or strong wind conditions, for instance, the operation will be limited. The maximum capacity of US, what is the density of operations accepted, and the spacing, so what is the minimum distance between man aircraft and drones operation. So there are subsets, but you can have idea of what should be provided in terms of operational design or USpace design and constraints. Constraints also, for instance, do not fly over a school during the week or a stadium the weekend. So this kind of things. The USpace service design, so here we are touching the system providing the services to the operators. So we need various parameters to be specified to the USSPs. So at which distance they need to acquire the traffic information. What about the spacing or the margins around the flight volume of operational volume, a trajectory of an aircraft, what is a good time to provide information to the operator, so what is the maximum latency accepted. So very technical and detailed constraint that needs to be put on the specification of the services themselves. Plus operational constraints in order to ensure the fairness of the access to the airspace. For instance, what is the maximum time before to book flight authorization? We don't want to have a key player booking 90% of the flight authorization 1 year ahead, for instance. So USSPs may have some rules in order to prevent that kind of thing, to ensure fairness and efficiency of the access. And the USS themselves, which are technical parameters or attribute to the US themselves, climb descent rate. So for instance, in case of DAR, if the the US has to quickly leave an area or to land, the descent rate will be certainly something very important to discuss. Noise level for public acceptance, connectivity, etc., etc. So the parameters which are strictly related to the drones themselves. So USpace is or does not. It's not an equivalent to the 373, so the conventional ATM ANS, even if the spirit is similar. But it's not a copy-paste of the 373, it's a brand new set of requirements and AMC-GM. It's not yet an integrated system between man and unmanned aircraft, so we are still a level of separation. For instance, time separation. When you have a drone, you don't have a manned aircraft. If you have an aircraft, you don't have a drone. A control airspace, we don't have a UTM controller or dynamic coordination between the actors, so it's not a control unmanned airspace. We do not provide traffic information to manned aircraft, because otherwise we may fall under the 373, for instance. We don't support IFR drones operation, and we don't support the so-called air taxi at this stage, because we don't have the sufficient feedback, maturity, or demonstration that we can host humans in those operations. However, what is it? It's a safe and automated access to the airspace. It's a deconflicted US operations. So we ensure that the drones will certainly not collide or pair the use of services. It's supported by certified and oversight service providers, so the Common Information Service Provider and USSPs. It's coordinated airspace. Anyway, through this process of designation, the discussion that we may have between the ATM and the various actors, it's coordinated. So we are offering some tools and means in order to manage, for instance, state operations. As I said, through geo-awareness, for instance, to set up a temporary restriction. To ensure safety continuum with manned aviation, we don't want to degrade the safety for manned aircraft. We enable, that's an enabler, we'll come back to that, for USpace operators. So indeed, that's a constraint, but also an enabler to get an easier access to the airspace, and a catalyst for the drone market, because overall, if we have more operations, we have a higher level of access, we hope that the new type of service will emerge and to support the drone market. That's it for the principles. I hope it's been a nice reminder, and I would like to pass the ball to Maria about some activities that we are currently performing.
Thank you very much, Stefan, for having guided us on a quick overview of the main principles of USpace and main building blocks. I forgot to mention before that we have Alberto with us, who is our slide manager today. And again, please don't hesitate to put your comments on Slido. We will come back to it in a second. So, task force on USSPs and single seat certification. So this was an initiative by EASA Management Board that was last year actually in the Management Board in June. So the member states and the EASA Executive Director decided that in order to start from the very beginning, from once in history, a certification process that we are starting at the moment. At the same time, EASA and the member states in parallel from different providers. So it was decided that it will be good to sit together around the table and to discuss what will be the best practice, what we will be asking those service providers, how to certify them, application forms, procedures, and to try to harmonize and create a level playing field from the very beginning between EASA and between all competent authorities across the EU. So that was the objective of this task force. So as I said, it's the initiative of EASA Management Board, and it was created by the Member States Advisory Board of EASA, so where all Member States are represented. The composition at the moment is 19 civil aviation authorities or future competent authorities or already designated competent authorities by 19 member states, and is open to all EASA member states. So at the moment is chaired by the agency, but we work really in a very practical and informal way. So we have been working since August last year. It was our kickoff meeting, and we wanted to present to you several results today that will be presented along the day and tomorrow. We have divided the work in 3 work packages. So the first work package is harmonization on air risk assessment and definition of performance requirements. This work package is led by Elina Milere from Eurocontrol, and we all contribute. Then we have the second work package, which is basically guidelines on how to implement the Common Information Service and interface procedures for interface and interaction between the actors, led by Antoine Martin. And the work package 3, single SIS and USSP certification and continuous oversight, led by Stefan, also with Antoine. So, and we are at the moment working in the finalizing the main output of the task force, which is gonna be clarification, recommendations, white papers, frequently asked questions, certification material with application form, and checklist, and also a change of best practice. The task force is only composed by member states of competent authorities. There is no industry. It's a forum in which we discuss openly how we certify all the providers. For the competent authorities, those providers who have their principal place of business in their member state. And for EASA, those competent authorities who have the principal place of business outside the EU, but want to provide services in US space established in the European Union. And we have not finalized all set of material, which, by the way, those who can be published will be published in a dedicated web page in our website. We will provide the link soon, and we will share this in LinkedIn, Twitter, and so on when it's ready. So far, it's not ready. But we aim to have things ready by the end of this year. This task force is very important because we are all working at the moment in various phases in Europe. So some member states are a little bit more advanced in the designation and in the certification process. Others are because probably they don't have the need or they don't have a request from industry. They're a little bit less advanced, but we are all starting doing something. In EASA, basically, we are working on putting our certification procedures in our quality system, and we are developing them. So Stefan is pretty busy working on certification handbooks and certification procedures with the support of Alberto, myself, and other colleagues from the ETM department that you will see tomorrow as well. So this is about the task force, and again, we will present to the industry the deliverables when we have them ready, and we will publish them in our website. And in the future, these deliverables may lead to announcements of the AMCs and guidance material, but at the moment it's no AMCs, it's no guidance material, is for the authorities and the industry to look on what is expected is best practice. One of at the moment, we have two clear deliverables. One is the application form. It will be presented by Stefan tomorrow. And the second deliverable was we have created in EASA a leaflet for an A4, very easy to understand for the U.S.-based community, what is U.S.-based, and the set of services. So we wanted to have a representation in one A4 that can be provided as a safety promotion material across the EU, and it looks exactly the same, but it's translated in different languages. And here you can see the English version in between, and we have at the moment, so we have the Spanish version, so the AESA, we have, I think, the Italian, the French, the Swedish, and in Bulgaria. Yes. So we have the same leaflet in different languages, and we expect that the leaflet is translated in all languages and is available in all websites of all national competent authorities. So this is all safety support, implementation task of the member states, and yeah, so we are very happy that everybody is having the same view and understanding of US space. So that is all for this first block of the workshop. And please, Alberto, you guide us through the slide. Yeah.
Okay, so if you want, I just read through the questions. Okay, so I start with the first one. So the first one is, what is EASA's opinion on a centralized model where a single SIS provider also offers a set of services outside your space, being considered by different countries?
So if you can wait 1 hour, you will have some recommendations. Antoine from DGAC will present our consideration on centralized versus decentralized model. Yes.
Okay, so then the second one is, should SIS and USSP systems be certified as ATM systems? And what is an interpretation of satisfaction of use-based performance requirements?
Yeah. So the answer is in a similar fashion, but not as an ATM system. Tomorrow afternoon, we'll have 2 hours of 3 hours of discussion on the certification, and we'll explain what means satisfaction of use-based performance requirement. So it's something similar, but adjusted and tailored to the new type of environment and to new type of organizations.
Okay, then since USSPs are not obliged to offer their services within the whole use-based airspace, how can SCA, while designing use-based airspace, ensure that there will be no black spots where all drone operators will be grounded by lack of available USSP?
So if this scenario may happen indeed due to lack of infrastructure, this kind of thing, that needs to be considered through the airspace risk assessment. And when the use-based airspace is designated to identify those potential and to may have some operational constraint. So far, I don't know if it's that realistic. It will really depend, especially on uncontrolled airspace, about the capacity to get the inconspicuous information. Otherwise, I don't see that as a constraint.
Okay. Then, after a dynamic airspace reconfiguration, the ASIK in response to the ATC is only the area cleared, or ATS user should also receive the individual ASIK of drone operation affected to know that they received the instruction?
Yeah. So indeed, that's something which we also presented, and I may not have been clear. There is an arrangement to the air traffic control who has decided to close the airspace, which will be the presence or the non-presence of drones. Make sure that the sky is clear of US and that the manned aircraft can transit safely inside this volume of airspace. So the acknowledgement is simply drones or drone.
Stefan, a bit
yeah.
Height. Yeah.
Okay. Okay. I try to be loud or louder. Let's take
Okay.
two more, maybe.
So the
Yes.
next one is about this use space introduction. What are we going to do with C0 A1 operation versus BVLOS under USSP? Is it really safe to allow this C0 A1 operation in use space that can reach 120 meters high and could collide with BVLOS flights?
Here, I cannot answer because I am not a specialist of those information, so it could be discussed with Natalie, for instance, for the SOAR. Yeah, please, Maria.
I can give an answer. I mean, this was a very, so this is the operations in the open category that there was found a compromise based on the existing requirements for the open category for this type of operators that they could actually, well, they have a requirement if they see any other aerospace users, they need to get away. This is was considered during the development process as a safe enough. Nothing, and we always said, nothing prevent that through a geozone to already require these operators to comply with the US space. So if it is considered during the assessment that the drones operators in the open category, and this was what we say the compromise, because if you ask my personal opinion during the whole process, it was that they need to comply as well. But obviously, this category of operators is the low risk of the open category, and it was found that it's difficult to implement. Also, the systems is difficult. So most likely they are hobbies. So okay, if nevertheless is allowed for this operator to operate in that aerospace, and there are a lot of BVLOS flights together with man traffic, so it's a risky environment, and it's still allowed, as I said, these operators to operate. It could be in a geozone required that these operators adhere to the US Space Service. So this is a privilege that is granted through the geozones to the member states to do. So it's again a risk assessment, it's a risk-based approach, and we need to implement it like that. I want just to clarify the previous comment of SCs providing services outside US Space Aerospace. SCs is not an operational stakeholder. So if an entity provides service, is a service provider. So so we need to clarify this. It will be clarified, but there is no such a notion of a SIS providing US space services. This is not existing. Huh? So if provide US space services, a US space service provider is not a SIS. So it's to clarify this. Yeah. Okay, so we go to the next block. And for the next block, we will be starting working on roles and responsibilities, and we will start with Stéphane Boubeau.
So thank you again. For the question, just to say that we have tried to manage some pieces for Q&A. It will go through along the discussion, and we'll have other moments where we can still continue to answer to your questions. I also take the opportunity to say that you see that we have various topics to discuss. And unfortunately, when I try to make the agenda, I thought that it will be extremely dense already, and we may not have the capability to go to the details of each of the topics. So good news, bad news, good news. The good news is that we have a lot of material that will be presented all along the days. And I saw some other questions about the CIS, about manned aircraft, etc., for its conspicuity. The answers will come along the discussion. So we have a very, very wide set of information, slides to be presented by all the presenters. I think it will be very interesting for you. The bad news is that we will not be able to answer to all your questions and to go in depth to this topic. And the final good news is that I can already say that we are planning some webinars in September, or starting from September, in order to go a bit forward or a bit deeper in the detailed questions that you may have about centralized versus decentralized architecture, single CISP versus USSP, etc., etc. So all the key items, we are planning to have a subsequent sequence of discussion with you. And I take the opportunity to say to you, to the industry in particular, that the first webinar will be certainly dedicated to get your feedback, because I kept receiving feedback. We have letters from some organization that's extremely fruitful, interesting, and will be useful for the future. So maybe the first one will be dedicated to get your feedback. We are now delivering some messages. Maybe the next one will be for you to pass some information and concerns, etc. So that's something we have in mind. We will try to organize something starting from September with a list of items. So don't be that much frustrated if we are not able to answer to your questions, because we'll have another opportunity to continue. For the next slot, so starting from now until the end of the day, we wanted to highlight and to explain what are the various roles and responsibilities. So the idea is not to go to assisted reading of the MCGM, but to provide the key messages and the key information to help you to understand what is behind the text of the MCGM. And to go back to the text of the MCGM with that understanding in mind, maybe clarify your reading, or maybe to raise other questions. But at least we want to communicate of what we believe the interpretation of the text, if it needs to clarify. And I wanted to organize a bit the discussion about the various roles and responsibilities that you have in the USS space. Because we have plenty of stakeholders actually and actors. So the first USpace stakeholders are the European Commission or the European institution, which, said by Maria, has pushed for the development of USpace. And answering to a query, a request from the industry. And we have the member states, which are keeping a central role in all the discussion through the definition of the text and the regulation itself, but through the implementation. They are the key players in the establishment and implementation of the USpace regulatory framework and implementation. Something which is maybe new in the process, and that will be highlighted again by my colleagues, is the role and the various kind of authorities in this process of implementation. So, contrary to maybe the conventional airspace management, which is made at national level, the proximity of the operation to the citizen, to the urban environment, etc., at low level in the various entities or places over Europe, fosters the need to have a closer relationship with, for instance, the regional and local authorities, for instance, the municipalities. If you want to trigger or to foster the operations over a capital of Europe, for sure you need to be in close relationship with the local authorities, which may not be that clear in the past for the other processes. So the authorities, whatever they are, local from national, all the state authorities for law enforcement, emergency services, and definitely the ATM, because we have a close interaction with the ATM, needs to be part of those discussions. We need for sure the support of the competent authorities. So competent authorities are the state organization which support, for instance, all the activities, concretely speaking, are making the job for the implementation of USpace, and in particular, for instance, the certification of the various entities, the oversight, the occurrence reporting. We have you, the industry, which are actually we are designing and making all those activities for you in order to support your operation. So the key stakeholders from the industry are the operators and the service providers. So it could be the USSPs, but as hint already, as a single CISP, or the CISP generally speaking. And last but not least, so I come back to that, because that's a key item which is systematically enforced by the European institution. We must involve the European citizens in all the discussion we have. It's not a matter of USpace, it's a generic concern, how to get adherence of the public to the new type of services. Because without adherence of the public, no market. That's clear. if you have defiance of the various actors and the public, the market will not be there. So to foster the market and to get adherence, we need to consider this factor of social acceptance by the public. And as you can see on the slide, so this is an extract of a survey made by EASA 1 or 2 years ago. What are the key items to consider when we are approaching the public? Generally speaking, we have the nuisance, so noise or visual nuisance, because they don't want to be disturbed. Imagine that you are in a residential area, you don't want to be disturbed by 10, 100 flies or drones surrounding your house. And we have safety. And safety is absolutely a must to ensure to the various actors, so not only the social acceptance, but all the actors generally speaking, we must keep the same level of safety as today. And last but not least, the one I wanted to present, privacy. This is somehow maybe new in type of aviation systems to get or to consider privacy of the public. When you are in an Airbus, for sure, the privacy aspects are somehow remote. When a drone is flying very close to, again, a residential area or a school or etc., privacy starts to be really an item where people are expressing concerns. What about safety roles and responsibility? So the same thematic, more or less, but as I say, the key item or the key personnel to support safety are the operators. They will have to properly plan their flight. They will have to properly define the mitigations. They will have to properly conduct the flight in respecting the instruction of the air traffic control and the flight authorization, for instance, and any dynamic change in the airspace. So ultimately, the safety relies on the operators. But not only. We don't have a single actor ensuring safety and being responsible for safety. As you have understood from the framework, we have plenty of organizations who will contribute to the safety of the U-Space airspace, starting from the member state and the competent authorities, where to design safely a U-Space airspace, how to define the proper mitigation and operational constraints, how to certify a U-Space service provider, make sure that the service will achieve a certain level of quality and integrity. Make sure that the ATM ANS will be properly delivering the information, with, for instance, will be properly trained to trigger a dynamic airspace reconfiguration and to maintain spacing or separation with MAN-aircraft. MAN-aircraft, they will have to be equipped with the conspicuous device and CIS and single CISP and USSP, so all the service providers will have to properly done their job. So there is not a single responsibility. Quite often I've been asked who is responsible. All the entities providing or contributing to the framework on their field of responsibility. If a drone collides with a MAN aircraft because the operator did not respect the DAR, that will be the responsibility of the operator. If the DAR had not been provided properly by the air traffic control, for sure the responsibility will be on the air traffic control. If the MAN aircraft is not properly equipped of the conspicuous device, for sure that will be the responsibility of an aircraft. So there is no single answer, but what I wanted to say is that all the stakeholders are taking part in safety. What about the plan of the next slot and discussion? We'll start with something, an overview of the MS member state competent authority, EASA industry responsibility, with all the stakeholders, with a value focus on the coordination mechanism, the air risk correction, airspace risk assessment, there is a mistake on the slide, sorry, common information service, etc., all along the day. What time is it? 10:30. I would like to present you then the responsibilities of the member state. The very first thing to say in terms of regulatory framework, the member states do not have to change or to transpose the content of the U-Space regulatory framework in the non-regulation. What you have in the implementing rule of the regulatory framework should be the same for each of the member states. However, the member states have to instantiate, to implement the U-Space framework into their own system, and for instance, to designate which will be the relevant authorities or entity to support the implementation, for instance, the relevant competent authority. So this is what's going on today in plenty of member states. We know what is the regulation. However, each member state are trying to implement or to translate into their own system this framework. Something that we must not, sorry, there is kind of echo. It's better with the echo. Okay, 10. Sorry. So the member states are sovereign to manage the access to the airspace. So we must not forget that the member states are fully sovereign to manage the airspace. So they are fully sovereign to designate, to decide where, to decide how, and to provide conditions and limitation for that geospatial space. The member state will also regulate the funding cost and prices. So don't come back to EASA about what is the price, what will be the funding scheme, etc. That's the responsibility of the member state to regulate funding cost and prices of the services. Ultimately, if there is a strong difficulty faced by the industry with regard to member states, the European Commission, for instance, in monitoring the rules and market regulation, may play a role. But basically speaking, if you have questions about funding costs and prices, that's the role of member states. As EASA, we are not managing this part. That's the sovereignty of the member state. In terms of concrete action of the member state into the geospatial space, member states designate the geospatial space, as we say. They will perform an airspace risk assessment to support the designation that will be explained later on. They will ensure that the common information will be provided with a sufficient level of data quality, latency, and protection for security. They will ensure the operational the delivery of the operational information, for instance, where is located. So all the information, for instance, that man aviation needs to know as the operators. And to maintain a registration mechanism to let the operator be registered properly. The member state will be responsible to decide what is the most effective architecture, centralized versus decentralized in their own system. So they have the freedom to decide what is good for them. And the member state may require specific technical or operational constraints. So, for instance, to limit the noise level, to pay attention about cybersecurity, because they may have national cybersecurity laws, and also to maybe decide some constraint about flight authorization. So, for instance, the maximum time before to book flight authorization or this kind of thing to make sure that the access to the airspace is fair and efficient. The second key player in this discussion, just following the member state at a lower level, are the competent authorities. So I don't come back to the details. You can look on the articles 17 and 18 of the 664. You will have a list of things that are the responsibility of the competent authority, but the key aspects are the following. The coordination mechanism and the nomination of a use space coordinator that will be presented later on by Vassili. As I said, the certification of the organization to ensure that the operational performance, to assess the operational performance of the geospatial space, make sure that the activities are going well, and I should have said, I should compete with the safety of the operations. And for that, they will have to determine what are the data that need to be recorded in order to ensure that proper monitoring. And they will have to monitor the safety events and to maintain safety of the operations. So, for instance, to take decision of the operational constraint, whatever, to maintain safety. If, for instance, you have regular safety events. And the competent authorities are also required or asked to coordinate it between them, so at European level, maybe through the task force that we have today, for instance, to harmonize the safety levels and to ensure level playing field between countries, and to support the certification, onboarding process, that will come back later on, and oversight USP. So we may need to have some liaisons, constant liaison between authorities over Europe for that. What is the role of EASA? So first disclaimer, EASA, we are not working in isolation. We work with all the stakeholders. So when I say here EASA does, for sure, it's always in coordination and a constant liaison with all the other stakeholders. The very first thing that we do is to answer to the mandate given by the European institution. So, for instance, to support the regulatory framework. We are developing the MCGM. We are involved in various research projects which help us to set up the framework, complete the MCGM, and to anticipate the evolution. We are collaborating with the European civil or non-civil authorities, ICAO as well. We are providing support to the member state when needed to, so we may have some workshop, etc. The same spirit is to ensure harmonization and proper understanding of the regulatory framework over Europe. We are fostering harmonization over Europe, so it's why we have this task force, for instance, currently ongoing. And we ensure standardization, which is a mandatory role of EASA in order to make sure that each country inside Europe have the same framework, follow the same procedures, and are all complying with the regulation and their obligations. We are involved also in the standard organization development, so we are part of EuroCAE, we are part of this USCG, for instance, in order to follow what's going on in terms of standardization, technical standardization. We're in charge to establish the occurrence reporting scheme, and we are working on new obligations to report occurrences for U-Space, and we are also monitoring the safety event. And last but not least, but this is something which takes a lot of time for us, we are also a competent authorities. So we are certifying and making the oversight of new SSPs. And currently, we are making 2 certifications of USSP. So we'll come back to that tomorrow. So we have also an operational role, like any other organization or competent authorities in each member state. Something about the industry, You are first responsible to ensure the safe provision of the services. You are in charge to manage, assess, and report your occurrences. So if, for instance, USSPs have a systematic matter in terms of safety, must be reported to us. You are for sure actively contributing to the development of the USS framework. And you are in charge to develop the technical standards. So something I really want to emphasize here, as EASA, we are in charge of the harmonization. You are in charge of the standardization. That makes a big difference. We are keeping continuous feedback. We don't have the standard for syncing, or this standard may not be adequate, for sure. Please go back to your various standardization bodies and make it better. Because at our position, we cannot create the standard for you. That's really your duty, and we are really insisting on that. If you want better standards, if there are some lacks, please go back to your various bodies and provide to us, and we will do our due diligence to evaluate and to instantiate. So you are responsible to complement the U-Space technical framework. We know that we have some gaps. We know this is not complete. We know that we may have alternatives, but without a clear, concrete, and validated proposal, there is nothing we can change. So that's really a strong message that we are passing for you. You may not be happy, you may find some lag, but please provide us the technical information that we can use later on in the MCGM. And something I would like to highlight, it's about alternative, for instance, is to propose a concerted alternative. Because yes, we may have standards, and we may have 10 standards. So it will not help us if it's not concerted over Europe. So please try as much as possible to define standards, but make sure that they are consistent and compatible from each other, because otherwise we will not be ensured to be able simply to ensure interoperability of the system. We may have something which will work for a system, a given system, centralized or decentralized, for a given country, a given INSP, but it will not be interoperable. So that will totally defeat this harmonization and standardization objective. And I stop there for that part.
Thank you very much, Stefan. So clear message to everybody. And I would like to now open a coffee break. Let's have now a coffee break so you can reflect on everything. Please keep the questions in Slido. I have seen there are still 11 questions open. And we will address after the next 2 sessions. We will have half an hour of question and answer sessions. And now invite Vasilis and Elina to come here during the coffee break, so to set the the next part of this block. So coffee break, 15 minutes. So ladies and gentlemen, take again your seat. Those online, we reconvene now with the next part of the second block of the workshop. And I would like to ask Vasilis, Dr. Vasilis Agoridas, to guide us through the coordination mechanism. Vasilis, the floor is yours.
Okay. Thank you, Maria. Thank you, everyone, for giving me the opportunity to share with you the principles and mindset, in fact, that is underlying the coordination mechanism, which is the Article 18F. It's 2-3 lines on the actual regulation. It's 10 pages on the guidance material AMCs. So the idea here is to share again, based on what I assume you have read on the actual GM, and share the main principles, the main steps, but most importantly, I think it's the first opportunity to exchange and to ensure that at the end of this session, we're going to have a common understanding and sharing on what is the mindset, what is behind that. So the coordination mechanism, it is not a typical aviation procedural topic. So this is where we start to deviate from what perhaps you have known based on your experience as dealing with the ATM topic. As already highlighted by Stefan and Maria, for example, why we establish U-Space, one of the reasons is to manage the complex operations, especially when we go to urban areas. This means already by mentioning that, there are some new type of interfaces. Stefan mentioned the importance of engaging with the citizens. Why? Because ultimately, we have to see U-Space as a type of a new public infrastructure. Now, because this is not just up to the sky, but it is so low level that in many cases, local authorities consider this as an expansion of the public space, it is, I would say, normal to think, or this is how we have to see it, that as it is a type of public infrastructure, similar national laws that apply when you do a public infrastructure like an airport, railway, new highway, rails, roads, cars, in the same mindset, we have to consult with the wider society. This is the core behind the coordination mechanism. The coordination mechanism, it is not just something we leave at the end when we can do some checks. As we will see in the slides, is one of the key elements, not just to gain social acceptance, but to nurture it. And this means it will take time. And you need to start from the very beginning. It is not a survey. It is not just a questionnaire. I think this is something important to understand. It's a new type of processes. But let's go in more detail. One of the first thing here to consider is that it is a high-level framework, and it is to coordinate and align in the different phases of the life cycle of U-Space. And we have defined at this high level the different phases, and we will see later on. So it is about the engagement of these very different stakeholders that in many cases are totally new stakeholders that also in many cases they are not even aware about drones and what is behind the drones. So for example, when we talk about U-Space services, in many cases people understand this about the commercial services, where this is a very specific term within the ATM UTM community. And what we mean is these are the U-Space services for the operators, for example. These are where even the language could be misinterpreted by the different actors. This is one challenge that the aviation community will have to don't make assumptions about the communication, the words used. The idea here is not only to involve the non-aviation stakeholders, but also what it is one of the key elements of the coordination to further boost or even establish this engagement at different levels of governance, the multi-level governance. So here we have the challenge. First of all, go at different layers of governance from national, regional, local, and then at each layer, go multi-sectoral, transdisciplinary. So you can start understanding the complexity that we may have in terms of engagement of very different communities. Why all of this is necessary? Perhaps this is a new task for aviation. However, this is business as usual when you go to the ground, whether it is ground mobility systems or development of new systems, or as we said, any type of public infrastructure. And as now aviation goes to the lower level, it will have to be also, or it will be also subject not only to aviation rules and policies and mindsets, but also to the ones that are coming from the ground. This is inevitable. So the coordination mechanism is by its nature evidence-driven and consultation-driven. And it's not a mechanism to make decisions. It is to deliver recommendations to the competent authorities, to the member states, so they make the decisions, but in an informed manner. This is based on the principles of evidence-based policy making. You see here that we have also new processes and new tasks. That in majority, these are not aviation procedural tasks or processes. So we need a new type of skill set, either the competent authorities or the nominated agencies or actors that will have to perform these new tasks and processes need to have. And there is even a new role, the role of the U-Space coordinator. Already Stefan gave an initial frame about what this might be, but we will discuss. Let's go first to the life cycle phases we said. The first phase is the plan phase. This is where we will have a trigger for a U-Space, and this is something to be defined nationally. What it triggers a U-Space, how do you do the screening, whether when you have a request you go for a U-Space or not. This is something to be decided and set up at the national level. The moment there is this trigger to establish a U-Space, then what is needed is how do we engage with this mechanism? The first task is to nominate a U-Space coordinator. This graphic is already in the GM, and it is described there about how it works. So when we engage the coordination mechanism, in fact, what is the purpose of the coordination mechanism is to coordinate between these different authorities for the three main tasks: the airspace designation, the constraints and performance requirements, and the U-Space services. These are the three main tasks as are outlined in the Article 18F. This is something that is typically a non-technical process from the perspective of the coordination mechanism, because here is about gathering the input from the political and social actors. So the socio-political input to this new type of infrastructure that we're going to develop in a certain area. However, it's not purely political and social process, because within that, there is also the U-Space risk assessment, and Elena will talk about that. The risk assessment, the ARA, the airspace risk assessment, it is a technical process, a standalone process. However, even ARA has some social aspects within it. So it's I would say, more socio-technical process. For that reason, there are very strong interfaces and links with the wider coordination. So although we may like to separate things, here there are very strong links between the ARA and the coordination mechanism. And in fact, we can even consider conceptually that there is this wider coordination say, socio-political that is required, ARA is a very important input to this discussion, to this process. But ARA itself is managed with its own approach, but is a key input to that. So when we identify stakeholders that we need to involve in the wider coordination that are non-aviation, for example, many of them will be involved in the ARA, but many of them will be involved in the wider coordination. So this is why we need to coordinate early when it's about the stakeholders' identification and how we approach them. Because imagine that if you don't align the activities of ARA with the wider coordination, what you will have is that ARA teams will contact some stakeholders, then coordination teams will contact the same stakeholders again, and everybody will be confused. That's why this coordination has to include at the very beginning also the approach about the ARA. The second phase of the life cycle of the use space is the actual execution, is where we fly, when we have the actual operations. There is not much you see in this graph about the actual use space coordinator, although there are some things that I will explain later on. But here, what is the main issue? The main issue here is how do we manage this airspace when there are incidents, things that have not been planned. Sometimes we have planned events, so we can really plan and we can start to have different reconfigurations in a very planned manner. But in some other cases, we have emergencies. And you can imagine when you go in a very urban environment, many things may happen. So we need to have a system in place that can very quickly manage this situation, whatever it is. And this is where mainly, when we talk in terms of operational airspace, this is managed by the established, I would say, approach that described overall in the more technical aspects of the use space by the security and safety authorities. We will see in the next slide what is the role of the use space coordinator here. And there is the third part, which is a review. This is perhaps something more new. This is something totally driven by the use space coordinator. And the idea there is, how can we improve the actual use space? How can we improve based on the operational data we have, technical and also sociopolitical? And how can we respond to the needs of the society as gathered based on the evidence of the existing operations? So here again, we need this type of input that, as you will see, it is gathered already as part of the execution phase. And we need to go through a process of revalidating quickly, is the ARA we have in place valid? Are there any major changes or something that actually makes it not to be valid? And what are the lessons learned based on what we hear, what we see? And based on that, we should collectively be able to say, keep use space as it is, or in fact, it's so good, let's make it even bigger, because really there is a demand from the society for that. Or perhaps there are some nuisances or some issues that the society can say, we're not very happy with that. We perhaps want some even smaller use space airspaces. This will be part of this process to identify, and depending on the output of that, this may trigger back again a reassessment of the situation. In all of this, use space coordinator has a role. And what is about is to collect all of these different viewpoints from aviation or non-aviation stakeholders to support the ARA, for example, through the stakeholder identification and the different interfaces that exist as part of this wider public hearing and the ARA. It is not just one point when the ARA with the public hearings interact. We have created with Elena a graph that she will share with you later on, where you can see some basic high-level interfaces that we'll see. And of course, it is not just one hearing. There are many different types of hearings. And the actual use space coordinator, it is not just only one. In the GM, it is described as multi-level governance from national, regional, local. So we may have use space coordinators at all of these levels that they have to be also coordinated. We can give an example of that later on if you want. So here the use space coordinator has a central role to collect this various information, to support the ARA, and at the end to provide the recommendations. And it is these recommendations that are required to the member states to make the decision at the plan, which is the green or red light, as we say. It's a red light does not mean just stop. It means something is missing. Something we need to make it better before going live. And you can say, yes, but all of this creates extra time, extra resources. Do we really need it? Is this an obstacle? I would say that in any good design, you need to define your requirements well. If you don't do and you make shortcuts, it's inevitable you will have to pay more money and more time at the later stages. This is one of the typical reasons why projects fail, is because you fail to define your requirements and address them at the very beginning. And what we try to do here with the coordination mechanism is to ensure that requirements that are not so obvious are identified and addressed early. This is only for the benefit of the operators, of the citizens, of everybody. So let's have a deeper dive now on each of these phases. So the plan phase. This is another diagram that tries to depict what are the interfaces. So we have the competent authority, which is responsible for establishing this coordination mechanism. This does not mean that the competent authority is the one to carry out the coordination. So a coordinator, a use space coordinator, has to be nominated here that will drive this type of process of coordination. And this coordinator, the main skill should have is how do we manage public hearings? How do we engage different communities? This is the main skill of the use space coordinator, is not the knowledge of aviation, ATM, aerospace, use space rules. It's an advantage if you can have that, but this is not the main skill. So the use space coordinator, as we mentioned before, it can be at different levels. So the local, regional, and national, which means a type of national coordination to align that what is happening in one region, it is harmonized with another region, and what is happening with one region between different municipalities is harmonized at this regional level, then between regions, then at the national level, and hopefully if we do that European-wise, it will be harmonized across Europe. The second part is about this execution phase. Here the role of the use space coordinator, it is to collect data during operations. And the use space coordinator cannot do this alone. This is where we need to make use of existing digital infrastructure or not of cities. It's how typically citizens put observations about what is happening in my city. This is also where we can make good use of the actual citizens to be the sources of data of different incidents they may happen, to signal this very quickly to the authorities or to the managers of the use space in case we have from a fire somewhere or even a terrorist attack or whatever. The citizens, the people who live in a city, they move in a city, are the best to provide very quickly this information. And we need to have a type of infrastructure in place where these signals can be perhaps an additional signal towards the authorities in order to be able to react. At the same time, this type of infrastructure, it is recorded in a type of repository about what is happening with the USpace, but the citizens should have also the opportunity to give feedback to what they experience, even if it is not an emergency incident, as part of the business as usual. They should be able to give this type of feedback. This is critical, and this is the main role here of the coordinator, is not how we manage if there are incidents, because this type of data and information, it is used later on in the review phase. When we said about the lessons learned, this is one of the main inputs we are going to have there. Some of this could be part of the technical review. Some of this will be about the more coordination socio-political type of review. And here you see it's a type of similar approach to what we have seen on the plan. It is, I would say, lighter because it's part of the review. Now, some of the key concepts here is that during the plan phase, you need to ensure that you plan about what we have seen for the execute phase, which is have also a digital infrastructure to capture the data from the citizens, and also to make an agreement how often are you going to do this review process. And this is up to each member state to decide and a competent authority. For example, one may say at the very beginning, let's do these reviews every 6 months, or every year, or every 2 years, or as we learn more, we can make this as a regular process. So, for example, every 2 years. However, this can be also triggered because of unforeseen incidents during the execute phase, that at any point it could be triggered because of a significant event, a review process. So I will try to summarize now and conclude my presentation by giving you some examples. One example where there
excuse me, Vassili, we have 5 minutes just
Okay.
to keep the time in mind.
Okay,
Yes, thank you.
So the Birdie project, which is a CESAR JU implementation project, as part of its phase 1, which is in the area of port of Advert Bridge, is trying to define a new space. And as part of that, there is consideration of how do we perform, of course, as part of the AMC, GM, the ARA, and the coordination mechanism. And although it's acknowledged that all of this material is concrete and there are a lot of material, it is confusing when we go to execute. For example, if you see pages 135 and 140, one says coordination mechanism comes first, and its hearing process is used as an input. Page 140 says ARA comes before the hearing process. So sentences like that are confusing. First, we have to acknowledge that it is true that these details are not so clear. However, both sentences are true because the two processes are very interactive, as you will see in the graph by Elena later on. In Belgium, there is already a legislation that defines the roles and the responsibility of the competent authority, topics about ARA and the coordination mechanism. It is true that, at least from the first reading and how the Birdie project also is trying to implement that, it seems to be more ARA-centric. However, this is not the case, as we have discussed, and there is a need to have these early alignments between the overall coordination. At the moment, the approach of Birdie is to start around the ARA, but very quickly engage with the wider coordination. The different phases of Birdie will improve this type of coordination and the interfaces and relationships. This is only the first step, but it's already acknowledged the importance of the coordination, this early alignment between stakeholders. When we look at our colleagues from Netherlands, there is a lot of ongoing work in order to create a transparent and well-structured process, especially when you see track 3 of the work. It is focusing on the creation of a participation manual. One of the observations here would be that we say external stakeholders, where if we consider use space that it takes place within an urban environment, who is external? It is external to aviation, but is not external to the use space per se. Okay, so sometimes we have to be, I think, careful with the words we use, because it's not just the aviation community here alone. And also the engagement of these stakeholders perhaps have to happen at an early phase in order to avoid some surprises. In Bulgaria, there is the concept of what is the role of the use space coordinator. Is going to duplicate or replace some of the other authorities? These are normal, regular questions that are coming, I think, from any member state. I think the answer here is obvious, that it is about managing the interfaces between the different existing entities. It is not about substituting any. And even here you see there is a national system for use space coordination. And already in Bulgaria, we have the first designation of a use space coordinator body, and even the first hearing in the town of Rakovsky. Of course, as I mentioned to you, there is not one way to do it. It is not just one hearing. It can be multiple hearings at different phases of the wider process. But this is a good start of how we can do things. And this is how I will complete my presentation. I hope it gave you a bit more of a background on what is the mindset and approach. Of course, we're available to support you at any point in order to see how you implement this in your member state. Thank you, Stefan. Maria?
Yes, thanks a lot, Vasily. Really appreciated. That was a very good presentation about the role of the coordinators. So meanwhile, we have, and I hope that the audience would have kept the roles and this central piece and central role in all the use space implementation. We have one question, which I found very interesting, that you may answer to it in a brief manner, because we are starting to overlap a bit with the slot of Elina, but it's interesting for you to have a look and maybe to provide a preliminary answer.
So maybe I'll just share it for everyone.
Okay.
The first one in
So about the use space coordinator, referring to the national one, could be an entity formed by CAA, NCA, national NSP, or should be a single entity. And to provide an example, maybe the national CSP or department of the CNA. Okay. The first reaction is what I mentioned. The entity who is doing the use space coordinator is not necessarily an aviation entity, because the key skill here is managing consultations, engaging stakeholders. If you know about airspace, it helps. But here, the real challenge is to bring large information from many diverse different communities. Now, if a national entity, a member state wants to form a new entity to do that, why not? The other thing to consider is there is not just one single entity that is a use space coordinator. It is not like as we have been used to have an ANSP, for example, for the whole country, or one CSP. We have the multi-level governance, which means, yes, perhaps we can have a national high-level use space coordinator, but what is the role of that? Is to align with the other use space coordinators that can be at a regional level or even at a more municipal level. Because depending when we say a city or a town, the actual sizes of cities and towns are not the same. If you see, for example, the city of Paris, or if you see the city of Toulouse, or if you see Rome, or if you see Napoli, or if you see North Hessen region, they are very different sizes with different types of populations. So we need for this, depending on these areas, we may need local use space coordinators at the city level. If you have a huge region and you have two different municipalities far away that they want to have their own use spaces, then the region which is responsible for the overall planning of mobility needs to ensure that these two different municipalities and the small use spaces they have are aligned, harmonized in their own region. That's why then we need this regional use space coordinator. And then when you go at a national level, how do you align that in your country, the different regions do similar things? Because you live in the same country. So it is very important to understand this need of having the very different layers involved and engaged. Because if you want to engage with citizens, as highlighted by Stefan as a key point, this can happen better by people who are in the local environment. They know who are the local key stakeholders that they have to for sure invite. And they know also what is the local culture and what it works better in order to engage these people. So
thank you.
There is not one single answer to that.
Absolutely. There is a lot of flexibility in the system. What I want to mention from a regulator perspective is that per the Article 18 of the regulation, this coordinator should be nominated and then work in close relationship with the competent authorities anyway. He must not be independent from the competent authority because he has a clear role regulated by the use space regulatory framework. So flexibility, yes, but scrutiny and control by the competent authority is required.
It could be even another competent authority from the country. It could be from, I don't know, the Ministry of Environment or another one that they are more familiar with this, or civil protection, or it depends on the country.
Thank you very much, Vasilis.
Thank you.
So we go to the next part of this block. Anyway, we will have a question and answer. So we have 20 minutes question and answer. And also if those of you who wants to take also the mic, we have an opportunity there. I must apologize to Vasilis because I didn't properly introduce you because you have two job titles. So you are working actually officially for Airbus, but in this work, we took your second hat, which is more leading the UAC2 initiative. So, and you have been pivotal in our communication to the cities and citizens. So thank you very much, Vasilis. And now we go to the second part of this block, which is the aerospace risk assessment. And for that, we have the two great experts as well. So Elina Milere, who is the project manager for US Space in Eurocontrol in the UIS division. And we have David Martin Marrero, who is an UIS US Space safety specialist, also in the same division that Elina. So the floor is yours. Thank you very much.
Thank you, Maria. It's great to see so many people, if I can be honest. Can someone tell me how many we have online? Probably many.
No, because if I touch it, we got it. So, but I registered, there were 800.
Okay, great. So I'm sure we have about 400 now online as well. Anyway, I will start off because we're quite, I think, a little bit behind time. So I will keep up a good pace. Before I start, I would like to ask how many of you are aware of an airspace risk assessment, let's say having read the AMCGM or any other document. Could you please raise your hand? Excellent. 90%, at least the ones that are here. I'm sorry for those that are online. Okay, so that gives us, David and I, a little bit of understanding of what kind of crowd we have. Great. Which means we also expect some really good, complicated, challenging questions from you. So I will explain, 2 years ago approximately, we had a small group that was developing AIM-CGM. So it was a very, very challenging task at the time. Airspace Risk Assessment, Article 3.1. The AIM-CGM to those, it was extremely challenging, especially because we had no operational data. We had not much knowledge, no risk modeling on, let's say, specific to use space. Still don't, but we're working. It's work in progress. We had representatives from European Defence Agency, French administration, FOCA, Switzerland administration, and Eurocontrol. So today, David and I, we will focus on explaining to you in a very short notice what is airspace risk assessment about. You will find some things that are overlapping with what Stefan said, and that's fine. We will do our best here to present it from our perspective and our experience. You may or may not know that Eurocontrol has been very involved with many different things, including development of airspace risk assessment method and guidance. So this has been published recently and available publicly. So I will start with also talking about the reasons, because essentially that is the GM1 of the AMCGM that we have been working on. And normally when we support in Eurocontrol member states, and that's what we do occasionally, we have up to 10 member states that we have been supporting on and off, depending on their needs. So basically, I will go quickly through the reasons. You can see the first one is ensure safety continuum, and this is also something that Stefan already mentioned. It is very important for the member states to have the effective, let's say, interface between unmanned traffic and manned traffic. Increase drone capacity of the airspace. So this is something that you might say, oh, but there's not such high density of drones at the moment, but perhaps in 3-4 years there are, or there will be, and therefore many member states are very interested to have that as the main key enabler for U-Space. And of course, BVLOS flights. That is one of the key one, of course. Enabling a new fair open market. So this is an interesting one. And obviously the main key moment, what also Maria at the very beginning mentioned, that there was a push from the industry. But we have to remember that it's not only about the push from the industry, but it is also from us facilitating the new users, the new interest, especially since, as you know, ATM is well established and so on. We need to help enable the new market. So many member states are very interested in this having and being their main reason for that. Encourage sustainability. That's also a very, very popular one at the moment. Ensuring better surveillance. And of course, U-Space is all about cooperative flights, but we also have a lot of non-cooperative flights, which can cause certain level of risk. So this is also something we're looking at. Ensure a better understanding of privacy concerns, and of course, achieving social acceptance. Here you see a slide that is, I have decided to start with AMC, so acceptable means of compliance, and we only have one AMC. So David will dive deeper into this, but just in a nutshell, this is the so-called assessment phase. So I'm going a bit backwards. The next slide will be describing the other phases. So you can see on the left-hand side, within the beige square, that the beige, let's say, squares, that is the AMC. So those are the minimum, let's say, things that need to be covered in or during the airspace risk assessment, and that is hazard identification, risk analysis, risk mitigation, and with that, of course, you have the air and ground risk, not just for safety, but also security, privacy, and environment. And derived from airspace risk assessment, you have the U-Space airspace design, performance requirements, and constraints. Reassessment, also Vasilis mentioned, this is something that at the moment we have just a very small section, and it will have to be in the future elaborated further. There's certainly links also with the coordination mechanism as to having regular checks. But it definitely needs to be elaborated, because for now we only have, like, if in case of a major change, then you have a reassessment, things like that. And on the upper side, you see, of course, the coordination mechanism. We have a very strong link. Vasilis also mentioned that. We have extremely strong link, and I will talk a bit about that in the next slide. You can see the airspace risk assessment box, ARA, is outside of this because we have more phases than this. So essentially, we decided in our small group 2 years back, approximately, that we would go ahead with 3 phases. There could be more phasing, for example, on the validation. That's something very important that in Eurocontrol we are already looking at, validation, simulation, etc. But for the preparation phase, extremely important to have the planning done. I've heard from member states that, oh, let's maybe go directly to the assessment phase and done. But you know, the preparation is extremely important, also identified by Vasilis, because we're working with non-aviation entities, and this is very new to us. Okay, so obviously in the preparation phase, you were to set the scope, set the geographical limits and adjacent airspace, identify involved stakeholders, and then you move on to the reference scenario. You understand the current airspace, so that is today, what's happening in the airspace today. You have the technical coordination with stakeholders, you collect data necessary in that volume that you're assessing. And when I say technical coordination, it means interviews, questionnaires, whatever the means. But this is not necessarily the same as all throughout the political hearing process. I will explain that in a bit. And of course, provide the basis for evaluating change. And then we dive into the assessment phase. And of course, that is to ensure the future airspace is safe for drones, manned aircraft, people on ground, etc. And of course, not forgetting the security, privacy, and environment. And for the assessment phase, we will talk into depth. As I said, David will cover that. So this is a diagram that you need to keep in mind. You need to dream about this diagram. It's a very important one. Okay, it's not maybe I don't know, it depends on your level of knowledge, but it is very important because it clarifies all the main processes associated with ARA, around ARA, but also coordination mechanism. So you can see in the middle you have ARA, airspace risk assessment, with all the phasing. On the upper side, you have the coordination mechanism. You have a trigger in red. So it all starts with the trigger. And on the bottom, you have use-based CONOPS. And you could ask, oh, but where's this coming from? This is an extremely important concept of operations, on how the operations are going to take place and operate in the coming week, day. Extremely important to not ignore this. We do not have much material on use-based CONOPS at the moment. Therefore, Eurocontrol is soon to provide guidance material and provide it to all the stakeholders that are interested. And then you can see in the very center, you can see a lot of arrows. There's a lot of action. Why is that? So that is because we have the consultation 1. It could be consultation 2, 3, 4. It doesn't matter. Each member state will decide. But in our opinion, there is not enough, let's say, currently the way the AMCGM is, perhaps there's not enough encouragement of informing the hearing process and providing knowledge on the CONOPS in the volume where you plan to designate use space. So we encourage that the CONOPS is refined. Perhaps they have more information that they can give, political, whatever, technical. Therefore, after that's done, you have the assessment phase. And after the assessment phase, ideally, we do not need to refine or redesign the airspace or make major changes, because that can be very costly and very time-consuming for the member states to redo the assessment phase over and over again, because someone may have forgotten to add something or mention. And we, of course, don't want any social acceptance blocks. Yes, so at the end, we have also a process on the USP-CISP certification on the bottom in light blue, means and processes. And then we have the onboarding. And as you can see, the arrow, the yellow arrow from ARA is diving into that process. And then you have the local performance requirements set, which then you go into the onboarding. And above all of that, parallel to all of that, you have the coordination mechanism, probably the public consultation taking place, and then you have recommendations and use-based airspace decision and use-based airspace deployment. And that's it from my side. Thank you very much.
Thank you very much, Elina. So.
Thank you, Elina. That was a very good presentation, I think. So not only because she's my colleague, but I enjoy seeing that. So I hope I can keep the same level that she had in my part. Also to thank, like she did, to the people that work in our working group. More specifically, I can maybe give names. Antoine Martin, it was Nathalie Hassebot from the European Defense Agency, and the colleagues from FOCA, as Elina mentioned, it was Andrea Perca and Santiago Yusia. And not only the work is not limited to these people, like we have numerous discussions with Stefan, with Maria, with Alberto, to develop all the material that we have come up in the ANCEM, and also with member states. Like we, at the same time we were developing the regulation, we were working with Estonia, with Israel, with Belgium, with the Spain authorities. So all this work really helped us to develop and to clear our mind of what it should be, the elements that we should include here. So going to the assessment phase, that is one of the phases that Elena mentioned. During the ARA process, there is a very specific part. I'm a safety expert, so I focus on the safety of this assessment phase. So we have a clear objective, that is the U-Space designation. And for this designation, the safety is key. We would like to first maintain the level of safety that we have attained over the years for manned aviation. So we would like to protect or ensure that we don't have collisions between the drones and the manned aviation. And also we want to protect at the same time the people on the ground. So if we are like separating the drones and the manned, we don't want to fly it over populated areas that can endanger people as well. So again, it's very important, and we want to highlight the safety assessment importance and the key process of determining hazards in the airspace to know what are the dangers, what are the risks, analyzing those risks, and after that analysis, to find the appropriate mitigations for this. So the main step of the process are the hazard identification, the risk analysis, and the mitigation planning. And the end result is that we will be able to designate our piece of U.S.-based airspace in the area where we want to designate it, and the level of risk is tolerable and acceptable in this airspace, U.S.-based. So key aspects of the safety assessment. What we want then is to in-depth assess encounters with manned aviation. We want to know the consequences and the likelihood that this could happen. Then regarding collisions between drones itself, we also want to explore the consequences of these mid-air collisions. So for example, two drones that don't have people on board, are they really creating a danger? Probably in the air, no, but in the ground, yes. So this is more related to a ground risk. And then if we move to urban air mobility where there are people on board, then we are also creating a risk in the air. For the ground part, we have the need of mapping the information related to population density and obstacles. This is not an intention to replace the SORA. The SORA, as Stefan mentioned before, will still be in place. So the operators will manage the risk of their operation, and they will have to submit. Maybe with the U.S.-based, it can be in a different way through the U.S.-based service providers that maybe could make this process faster, we expect. But we need still to perform the assessment phase to have this mapping of information related to the population density. The next element is the traffic density. So we want to know the number of drones that in this airspace can be handled by the U.S.-based services. We want to know also what is the ratio maybe between a manned aircraft that we can have with inconspicuity with drones. So if we have 300 or 500 drones in a piece of airspace, what happens if we put a manned aircraft in there? We need to reduce the number of drones in a factor of 100, 200. So these are elements that we need to assess in terms of traffic density. And then the effect of other sources of information like meteorological. What is the effect of the winds in the flight? What are possible electromagnetic interference that can interfere with the flights, and so on. So the purpose of the safety assessment is to describe safety activities to be conducted during the life cycle of the functional system, and I will dig a little bit deeper in what we mean by the functional system, to identify the main safety issues associated with the airspace, and to prepare is a preparatory process to address safety concerns early on. And this is because, as also Maria was presenting this morning, later on we will have the phase of certifying the U.S.-based service providers, and they will need to take on board the requirements that we will output in this assessment phase, so they can be certified in accordance to what is required to them. So regarding functional system, this is definition that we have for the description of the functional system. It's a combination of procedures, human resources, and equipment, including hardware and software, organized to perform a function within the context of U.S.-based. So there are three main elements to this functional system, that are the procedures, the human resources, and the equipment. And these are all the elements that we need to assess when we want to designate use space and during our assessment phase, not only for safety, but for all the areas. So we have the procedures that are governing the operations and interaction within the use space environment. We have the human resources that are professionals performing or managing and operating the use space system, and the equipment that are physical tools, devices, technology, infrastructure utilized for the use space system. Some elements related to the safety assessment. This is the order of these elements. So before we start performing the assessment, we need to have a CONOPS. A CONOPS is a description of the key properties of the operational environment and operational activities relevant to the aerospace. So with this CONOPS, we already have an idea of what is going to happen in that piece of aerospace. Because if we don't have this clear idea, it's difficult to assess anything. So the more mature and refined is this CONOPS, the better. But there are some elements that are going to be actually derived from the assessment that are more specific requirements to elements in the CONOPS. And then we have the phases, specific phases of the safety assessment part that are identification of hazards, identifying potential risk, and then defining the safety criteria. This is a very important part. We have received many questions about this part because it's basically setting the benchmark to ensure that the acceptable level of safety is ensured in this piece of aerospace. Then the next phase is defining the aerospace safety specification. So the safety specification means the actions and procedures that need to happen at operational level to satisfy the level of risk that we have defined with the safety criteria. The next step will be deriving safety requirements to the functional system. So it's going a step further from the safety specification. You take that safety specification that is more at operational level, and now you go to the functional system, you look at the components, the architecture, the procedures, and you set more specific requirements to make happen the operational procedures that you wanted to have in the safety specification before. And finally, when you have the requirements, you can allocate them to the stakeholders. It could be that some requirements are going to the USSPs, it could be to the single Cs, it could be to some UAS operators, or it could be even external to some ATM ANS provider that we have in the surrounding aerospace of US space. So you have to see who are responsible to take those requirements, to fulfill those requirements. Regarding the hazard identification, here I would like to highlight the link between US space and ATM ANS systems. So we are flying in the end in the same aerospace. So there is a clear link between Regulation 373. Also, Stefan mentioned before this link during the morning session. And for example, one of the elements that we have inherited from this other regulation is the definition of a hazard. So a hazard refers to any condition, event, or circumstance that could cause harm. And this is maintained in the 664 and the NCGM regulation. And there are more elements. And there are one more that we will see later on. So regarding the hazards, we have adopted what we call a broader safety approach. So we have defined two kinds of hazards. We have hazards that are what we call inherent to aviation. These are what the functional system wants to mitigate. And we have system-generated hazards. So once we have a functional system defined, how our system could fail. And these are other sorts of hazards that we could have. Regarding the hazards inherent to aviation, and these are hazards that are existing there in the operational environment before any kind of the confliction. So it means if we have a drone or a plane flying in the piece of aerospace, it could fall. So it could cause harm to people on the ground. So this is already a hazard, and we don't need the confliction to have that kind of hazard. If we have two drones and they collide, and we don't have any kind of the confliction, also, so collision between two drones or between drone and manned aviation, it's another kind of hazard inherent to aviation. Then these kind of hazards are basically the basis for define our safety criteria. So we can determine with these kind of hazards to limit those kind of hazards, and that way we define safety criteria. For example, if we don't want two drones to collide, we can say the probability of two drones colliding in the air has to be certain probability. So already we are defining like that safety criteria. And they involve the potential collisions either in the air and on the ground, like I said. Then related to the other kind of hazards, we have provided examples in the text of on the ANCGM. All this actual information that I'm giving here is nothing that you are not going to find in the text. You are going to find it here more user-friendly and like more visual, but it's anything different. So I think it's a better way to understand. And mainly I'm covering in Article 3 from GM4 to GM7 and a little bit of the GMs also before 1, 2, and 3. So we have provided, like I say, in those GM4 to GM7, some examples of system-generated hazards. And the first one that we have here is that an unmanned aircraft, it will be an airspace infringement. So what happened, what are the consequences of an unmanned aircraft exceeding the US space airspace volume? This is something that we have to take into account. Something is failing if a drone is getting outside of the US space volume. Another could be that the US space service is failing or is not being provided as should be specified. So for example, taking into account the flight authorization service, could be that it fails to ensure free flight intersection between two UAS. Tomorrow there will be a session specifically about flight authorization, that is Article 10, and my colleague Andrew Haley will dig much more into all the details for the flight authorization service. Related to all these system-generated hazards, we need to provide certain elements in the assessment. So the elements are the immediate operational effects, mitigation measures, a possible severity classification scheme, and the airspace specification for these system-generated hazards. Then moving to the acceptable level of safety criteria and airspace specification, we have determined that the member states are the one that has to be responsible for determining or setting the acceptable level of safety, considering inputs could be either from UAS operators, for USSPs, and other entities that they think are the appropriate ones. And the reason for this is that we noticed that if we take into account different states, the perception of safety might vary a little bit from state to state. So that's the reason why the member states had to decide by themselves. It doesn't mean that there will be like some homogeneity in deciding these safety criteria, but in the beginning it's better because also the way the cities are constructed varies from state to state. Regarding the definition of safety criteria, it's based also on Regulation 373 from 2017, but in this case is more adapted or tailored to the specific risk of unmanned aircraft in US space, or to Regulation 664. And the safety criteria cover all identified risks and need to be verifiable. Regarding the definition and measuring of safety, so it's again related with the safety criteria and the acceptable level of safety. It has to be defined in terms of probability and consequence of accidents between aircraft and UAS, and expressed in terms of explicit level of safety risk or related measures. Moving to the airspace safety specification, we have this has to describe what needs to happen at operational level to satisfy the safety criteria. It's emphasizing what we mentioned in the previous slide. And then there are elements that we can adjust at the level of the safety specification. And these elements could be either the traffic type, the aircraft or system performances. Stefan also was mentioning about the performances this morning. The equipment that is utilized, the procedures, the capacity, and population density. So in the moment that we can put more specification, operational specification, is when we define this safety specification in the process of the assessment phase. And then another element that you will find in the text is related to safety levels, units of measure, and safety requirements. So we want to maintain, and we want to emphasize that we want to maintain the safety levels that has been achieved during all the years from manned aviation. So we do not want to endanger manned aircraft. Then the difference, the key difference here is that the apportionment of the risk might be different. So what we notice is for example, with manned aviation, the collision between two aircraft, it's a very rare, very remote event. While if we are flying drones in an area where there are no population around, like maybe the apportionment of like the barriers to protect that two drones are colliding might be lower than for manned aviation, of course. Then related to the unit of measurement, we highlighted that we have to pay attention on when we use certain units. So for example, are we going to define safety criteria in terms of flight hours? This is meaning if we are having operations, for example, in the en route phases, or we can talk also per operation if we are making approaches to vertiports or in other cases. Then we have the safety requirements. So this acceptable level of safety is materialized through the US Space Aerospace safety requirements and the allocation of the safety requirements on the functional system components to satisfy the specification. So it's always, you go backwards and you have to, in the next step, you have to satisfy what you defined in the previous step. So is for meeting the safety specification, ensuring that the functional system operates as specified. And what we want to meet is the safety specification at operational level. Another element is about completeness and correctness. So we want to provide evidence, or we want that during this assessment phase, evidence is provided that when we are like defining all requirements, we are covering the level of safety in the safety criteria and the hazards. We are not forgetting any hazard that we define at the very beginning of our process. So these two elements are important. Doing a review of all the process at the end when we have our requirements to check completeness and correctness, and presenting evidence. So at the end, when we have done all the process, it's important to report, to document all the safety assurance activities. And with this, we reach the challenges and ongoing development in the US space safety. So some of the challenges is the limited experience. So we have never designated a US space aerospace for the moment. So there are states that are quite advanced, and we are very happy, and we have seen this evolution. So it's good. But this limited experience presents certain challenges, and I think we will have to be conservative, putting some assumptions, and there is some uncertainty, specifically with respect to the acceptable level of risk. So this can be refined in future cycles. Regarding quantitative figures, so we have now simplified assumptions and approximations to establish quantitative figures, but in the next in the following times, with more operational experience, we think we can put more accurate numerical examples, and that way we will improve the acceptable level of safety. So we are all the time basically working in producing new material and to improve the existing material that we have. So Elina and our team, we are developing, for example, a guidance for performing an airspace risk assessment that it has been published by Eurocontrol, and we will keep improving and presenting like more volumes of this document in order like to enhance and to support the EASA in this task. And finally, is this ongoing task force that we are participating. Also, Stefan mentioned this morning the task force for certifying the US space service providers. So we are also part of this working group. And what we want to ensure here is that the safety part coming from the ARA, from the airspace risk assessment, it's seamless with the safety requirements that will be put on the US space service providers and the single seats. So there is a logical flow between one and the other. So this is important, and that's why we would like to contribute with them. And that's all from my side.
Thank you very much, David and Elina, for this very interesting presentation and slides. So I suggest now we have, as promised, 30 minutes question and answer. So I suggest we start with the Slido. So with the last questions, which are addressing this block, then we can go and take questions which were since the first block of the workshop. And then we will go with a mic for those of you who are here, if you want to express yourself so in the room. So let's start, Alberto. Please.
Yeah, so I try to mark the ones related to the last panel before. So the first one is regarding the ESRM methodology. Does ESRM methodology as preparatory, reference scenario, and assessment phase, or as the ESRM methodology is only involved in assessment phase?
Yes, I will. Yeah. So the ESRM is only a safety methodology. I had to clarify. It's not for the ARA. It's not for the 4 phases for the 4 parts that we have in the assessment phase. I remind that in the assessment phase we have safety, security, privacy, and environmental part. So ESRM only covers safety. So that is one thing like to remark first. Second is that it's only in the assessment phase. It only covers the assessment phase. For the other phases, we have provided the guidance. That is the other document that Elena has been leading this team for guidance and can you remind me the title? Guidance and methodology for performing an airspace risk assessment. So that document, there is a document that you can download in the Eurocontrol website. It's covering all the 3 phases, while the ESRM is covering the safety part within the assessment phase.
Thank you very much. I think there are other questions on
Yes.
Coming.
The next one is regarding the acceptable level of safety. If it could it be considered the actual rate of traffic incidents in cities in order to benchmark if drone incidents are over or under those?
Regarding the acceptable level of safety, it's defined through the safety criteria in the assessment phase. So we think it has not been only the risk of collisions between drones and aircraft. You have to cover all the kind of risk. So you have to focus in the air risk. So what happened in the earth, what happened in the ground, what you want like to protect. You want to protect only people in the ground. You want to protect cars, railways, some certain infrastructures. So you have to be complete in terms of defining the acceptable level of risk and the safety criteria.
If I may, I will complement a bit here. So the acceptable level of safety obviously is the first criteria to consider is that we don't want to increase the risk that we have today. So we want to keep the same level of safety as we want today. So this will be the first criteria in the aerospace by putting more drones. So we don't want to penalize that. Now, how? So whether it is similar to cars, motors, and this is a complex assessment. So we have trying to do this assessment for urban mobility. So passenger carrying VTOLs. Here we don't have the passengers on board, so it's at this point in time. So it's a risk to third parties, and so careful assessment we need to be done. But I think the first criteria that we need to consider all is that we don't want to penalize the safety that levels that we have in the aerospace of today. So we need to keep them. Now, how this will derive in a US-based systems is I would say, is the question we need to be able to resolve with more experience. No, well.
Thank you. And the next one is regarding the timeline for the ARA life cycle from the trigger to the U-Space airspace deployment.
Yes, thank you for that question. I think it's a good one. For the moment, we have not finalized a single airspace risk assessment, and that is the truth. So we cannot for sure say, we can only assume that it can take up to, from a few months up to 1 year. But keep in mind, and I saw there was another good question somewhere there, lower, that is linked to this perhaps on ARA. It started with ARA. Maybe you can find it. Basically, what I want to say that in the future, perhaps there could be some kind of categorization. There could also be scenarios, for example, in uncontrolled, controlled, and therefore optimization of an airspace risk assessment to some level. So that could maybe optimize the whole thing and make it more efficient, less costly. But for that, you need time and experience.
On the last point of Elina about standard scenarios for use space implementation, that's something we are looking for, but today we are lacking data. So the real benefits will be to have a predefined set of scenarios with harmonized performance requirements, for instance. So instead of having to undertake a complete analysis on a case-by-case basis, to have something harmonized and consistent that will help the member state to designate, that will help the USSPs and all the stakeholders to know what are the performance requirements, that will help the certifications. But today we are waiting for a bit more material and to see, what we could define later on the concrete and real cases. Yeah, today we don't. So that will be a long-term activities for the coming years.
The next one is to what extent and when will the Eurocontrol ARA guidelines document will be endorsed by EASA, for example, as AMCs?
So, I mean, in the documents at the moment there, so what we have at the moment in the AMCs and guidance material is very much aligned with that document. And we will need to, obviously, in the next revision of the AMCs and guidance material, make a references to the further, so to the existing guidance and further guidance. Obviously, we need to keep the both concepts very aligned, but we are doing references to Eurocontrol documentation already to the SWIM yellow profile specification, and we will do the same here. Yeah.
Yeah, maybe what I will say regarding the ARA guidance is that we have. It's not that it has to be like maybe endorsed by EASA. It's that we have done the backwards exercise of taking what it was in the ANCEM and trying to produce something that is an acceptable mean of compliance. So that was the purpose. So this is the exercise for the member states.
Thank you. The next one is regarding UAS exiting use space, and as it is considered an hazard, how is an operation to be conducted with happens in both use space and non-use space? For example, long-range operation intersecting more use spaces.
Yes. So when you assess the risk in use space, so for example, this is a system-generated hazard. So you put requirements. You put requirements on the either on the US-based service providers, either in the ATM ANS system. So those requirements will ensure that whatever number of US-based that you are crossing, you are compliant with those requirements. So maybe you need to require everyone to be conspicuous there, or to be monitored, or something that it will ensure that the danger is low enough that you are meeting your safety criteria.
If I may complement here a bit, so if a UAS operator will cross a US-based aerospace and continue be below, so you are in the specific category 2 and non-US-based aerospace, the application of SORA and risk will kick off. So when you are in US-based aerospace, we have a guidance, but obviously it will be the outcome of the aerospace risk assessment, what is the residual arc. But we have said in the guidance is, and this will be explained by Stefan later on, we suggest based on the assessment is RB. So, and then there is the requirements that the operators need to do for compliance with RB to obtain the operational authorization. If you are flying then after, so the BBLOS will cross that US-based aerospace and you continue BBLOS in outside US-based aerospace, the assessment we need to consider actually the more stringent environment, which is going to be the ARC in outside US-based aerospace, and you will need to mitigate the risk for that. So the assessment we need to be include both aspects, so that you are flying inside US-based aerospace for one part of your BBLOS flight outside. You will need to make the calculation, what is your residual arc, and you will need to have the mitigation measures approved by the competent authority with whatever restrictions or coordination mechanisms depending on the aerospace. Would you agree with that? So I think this is the way of doing, because obviously you're not going to stop your BBLOS flight at the age, but maybe there is not a need to put a USpace aerospace only for a BVLOS flight. So that's the approach, and this will be a little bit explained by you today or tomorrow. Not today. Today. Yes. Where's Stefan?
Thanks. So maybe we take another one related to these topics and then we start following the order. And this is related to public hearing. How is public hearing expected to be part of the USpace airspace designation process? If every single application to set up a USpace airspace for a BVLOS operation needs to be approved by multiple layers, authorities, and then public hearing, it could take a very long time to set up.
I don't think that the coordination mechanism and the public needs to approve every single operation. You define the framework of the USpace. And then as part of that, there is the set of rules that when it becomes operational is approved a single operation or not. When you do in the plan phase, you agree the rules of engagement. So the public hearing says, yes, this type of airspace is an acceptable airspace volume where we can have different types of commercial services. What the USpace regulation is not addressing is to regulate the actual commercial services, right? This is something that it could be, however, be triggered during a public hearing, because people want to know, okay, you have this space, but what you are going to do. This is not something directly addressed by the USpace regulation, but it is something that may be triggered through the public hearings. And this is where it goes to other type of regulation, like market regulation or local preferences that can go to what we said during the presentation. Other public law and policies are engaged. And then this is why we need to have this type of hearings that can go beyond the USpace per se, so people can sort of are happy with the type of operations we would like to carry out. But it's not the idea that for each single application or commercial service we have these hearings. Now, if people don't like it, they have the opportunity through the repository we mentioned during the execution phase to file complaints or other observations. Not only complaints, it could be good things about the actual USpace, the benefits they may have. So we can, during the review phase, adjust accordingly. And adjust is not always something negative or restrictive. It could be to enlarge or to maintain.
Thank you, Vasilis. I think you had a great answer. And if I can just complement that, I think this is a question that demonstrates greatly, perhaps limited knowledge on or importance of CONOPS. So I think that's the key here, because it's not that after having done airspace risk assessment, it's only for, and having gone through the hearing process, it's for one operation. The concept of operations, you can have a variety of different operations. Thank you.
And I would also complete, because here there is a misunderstanding about this process. So the idea is to consider all those items and constraints through the designation process, but when it's done, the idea is to foster a kind of systematization of the access to the airspace. So we not relegate that thing. We want to make the thing easier for the operator. The type of operation have been analyzed, undertaken through the designation process. Everything is there to set up the USpace airspace designation. And after that, BVLOS will be BVLOS, and on a daily basis, you can request a BVLOS flight without any additional things, except to, from an operator perspective, to take the remaining part on the SORA. But really, the idea is to enable a systematic airspace access to the airspace, and not to undertake a lengthy operations approval on a case-by-case basis.
Thanks. So now we start following the order based on the preferences of the questions. And the next one is, will USpace impose transformations on drones in terms of hardware? As an example, will 5G modules be mandatory for communication?
So you will have tomorrow a presentation from our colleagues from FOCA on the Article 8 about network information service. So the idea is no, that's free. you may need to have some devices to transmit the information if it's not built in already. But to impose transformation, the answer is no. We take what we have today in terms of technology and capabilities. The interface needs to be standardized and make sure that you are transmitting the good parameters, but except that there is no enforcement of transformation. We have already some communication over mobile telephony, GNSS, LTE. 5G will be a mean, but still 4G or 5G could work. We have anyway some works performed by one of my colleagues, Thomas Oster, in order to look forward, maybe for more convergence about the surveillance means with the support of Eurocontrol, but it's not a short-term activity. The things will come in the future to have something more consistent and homogeneous. So today, use space, no, we keep what we have today in terms of network and ID and no change.
Yeah. So I concur with Stefan, like there won't be imposed transformation to the kind of drones that are produced by manufacturers. What will happen in the ARA process, for example, is that like certain kind of drones will be more likely to fly in certain areas. Or for example, like we don't want a 300 kilo drone probably on top of people. So that will impose that the market will adapt to lighter drones in this sense. So it could happen similarly with certain technologies, but it won't be an imposed. Like still, drones flying with 5G will be able like to fly in certain areas, maybe in geospace, maybe in geozones. So there will be a market for everyone, I would say.
There are no complementation. We'll go to the next one. So the authorization service does not include the coordination with other third parties, for example, ATC in controlled airspace. However, this will be key to facilitate drone operation. Is there something planned as a future version of the regulation?
So the answer is no. We will not include this, otherwise we don't need US space. So if the flight authorization inside US space will need to be coordinated with the traffic controller dynamically, then we don't need US space. Actually, we need US space to keep a traffic controller workload as they are today. They are responsible for providing services to man traffic. And if there is a US space aerospace, it's precisely to facilitate that the UAS operators are managed by the US space service providers and the US space systems. Is we need to coordinate the flight authorization with their traffic controller, the added value of US space is 0. So we still keep increasing traffic controller workload by putting drone operations in the US space aerospace. What there is, obviously, is the application of the dynamic aerospace reconfiguration by the traffic controllers. And we need to see, obviously, this is the next session, the next block. So keep with us after lunchtime. We will go in deep dive on the dynamic aerospace reconfiguration and the role of the traffic controller there. Whether there is an interface between the ATSPs and the USSPs, and through the provision of traffic information back and forth. But dynamic interaction or dynamic action of any traffic controller for the flight authorization is not in the spirit of the regulation, and it won't be in the spirit of the next amendments of the regulation, because as I said, if we start doing this, we just don't need US space. Then the traffic controllers will manage the drones, and this was not in the spirit of the regulation.
Good. So the next one asks, why is the USSP CISP certification linked to the output of a specific ARA if a certified USSP or CISP is for every U-space volume along the EU?
Alors, Daniel. The first answer is a bit basic, sorry for that, but because this is a regulation, and this is 15.1a, which requires USSP to demonstrate their capability to provide the service according to the output of the ARA. So this is how is shaped the regulation. However, indeed, and the validity of the certificate is given once for all. So you have been given a certificate and you can move from one use space to the others with that certificate. However, it creates a gap between the certified provision of the services and the one that you need to target for a given use per space with potential differences in terms of performance requirement. So this is a gap that we need to address. And tomorrow I will make a presentation at the very end of the presentation certification about the onboarding process, because indeed the capability to provide the service, even if it's certified, may not fit a targeted use per space. And here we have a delta to address. And we are working with the member state to identify in a lean process to allow to close the loop on capability versus expected performances. Yeah. But that's a very good question. Indeed, that's something which is certainly specific to the use space scheme in terms of certification, and that we need to address. Yeah.
Maybe, as we promised, we will have now the mic for those of you who are here. Who wants to make a question? Okay, so 3 colleagues.
Hello, everybody. David Guerin from the World Bank and the African Drone Forum. Thanks, David and Eleanor, for the presentation. The World Bank has 100 projects in over 60 countries involving drones. Recently, in Malawi, there's been a large number of drones, medical supply delivery in uncontrolled airspace. And in Maldives, there's a request for the Ministry of Health for deliveries using drones. The Maldives is peculiar because it has over 60 float planes operating to 100 pontoons, variously distributed in uncontrolled airspace again. I ran a session on the ARA, the excellent document, as you've publicized. Thank you very much. And there's a lot of interest in these countries. I note you mentioned Israel before. I'm just wondering how I go down a path on behalf of the World Bank of establishing a relationship with Eurocontrol and support in these sort of ARAs being employed in remote locations, not inside Europe. Thank you very much.
Thank you. I think we're certainly happy to hear that the document has been useful, not just in Europe, but outside as well. And regards to linking ourselves, Eurocontrol, with someone pan-European or even further, I think we need to then have a discussion separately for that to see what can be done. Thank you very much.
Gerd Wölbeking, Deutscher Modellfliegerverband. We don't see how model aircraft operations are part of the use space. Model aircraft are not drones. Also, EASA regards them as UAS.
Thank you very much.
I can provide a straight answer. Complete. It's because I missed it in the presentation. So during the break, I have been made aware that I forgot 2 things in the stakeholders list: the man aviation, generally speaking, and the model. So yes, you are part of the framework. You should be part of also the consultations when the airspace is established, because you may have consequences in your airfield for recreational purpose or this kind of thing. And we have some provisions and considerations, regulation with regard to model aircraft, as in the MCGM. So in the checklist that need to be performed by member state, when they need to tick the stakeholders to be invited or to consider, model aircraft are part of the stakeholders. So I simply forgot to put it in my slide, but yes, you are part of it. Then the question is, to which extent you will be able to continue operations as today. There are also some considerations, and the recommendation is to say to the member state that if you have already an airfield where you are operating, no additional burdens on the existing activities. So that's the recommendation that you have today in the MCGM.
Hi, Libby Bahat from Israeli Civil Aviation Authority. I'd like to know your opinion about nominating the coordinator for the U-Space, and pretty in a similar way, the airspace risk assessment. The link between these two is, I believe, the energy, the main energy that is behind it will be the first entity that asks for this use space. Again, I'm a regulator. Eurocontrol has been very instrumental, Alina, Pete, in assisting us in completing the airspace risk assessment. But regulators, I think, don't have the sufficient manpower, energy to be involved in both in evaluating, I don't know, 10 new use spaces and doing for each and every one of them, again, being the coordinator for every use space, and in the same way, being in charge of organizing the airspace risk assessment. So I think the main power between it is the first entity that asks for this use space, which is normally the first USSP that needs it. It could be a municipality with a USSP. The regulator, I think, the National Supervisory Authority, of course, should authorize it, should validate it, but it's I think in the beginning and in the writing phase, it should be in the background, not in the front. That's
If I may help here with an answer, first of all, it is clearly stated in the guidance material that, and what also Stefan and Maria presented, that the role of the member state and the competent authority there is to run the air risk assessment, the ARA. But when it goes to the U-Space coordinator, they are not responsible to do that. In fact, they are not even encouraged to do that. They are only responsible to establish a coordination mechanism and to nominate a U-Space coordinator or different types of U-Space coordinators depending on this multi-level governance we go. So they should not do this actual detailed work of coordination with the guys. So if, say, you want to establish a U-Space within a municipality, not in a region level, in a municipality level, you should nominate a U-Space coordinator for that level. It could be, for example, the actual municipality there, and they will run the tasks of the U-Space. The point is, do they have the skills? Because not all municipalities will be even willing to do. So someone else has to be doing that, and that will be where some discussions have to happen even at the regional level in order to find who will be this nominated entity. So I think it's very important not to confuse that the U-Space coordinator is doing the ARA. These are two different activities. Of course, the ARA is needed as part of this coordination, but I think our colleagues from Eurocontrol highlighted the specificities of ARA.
There is a little bit, and we need to go back to the previous question on the model aircraft. So the regulation already, so the first article applicability says that the regulation is not applicable to model aircraft which have received an authorization in accordance with the 947, 945 regulation. So that's to be clarified. And then obviously there are specificities which we need to be considered in the U-Space aerospace risk assessment. So I think, Olivier, last question, and then we break for lunch.
Okay.
Okay. Well.
Does it work? Yes. Thank you very much. Thank you. This is a very interesting discussion. Vadim Kramar from VTT Technical Research Center of Finland. So we work a lot with different stakeholders, and I try to compile a joint question that we hear from them. So we have European Drone Strategy 2.0 that says, okay, we have innovative air mobility that includes urban air mobility, and U-Space is the enabler for urban air mobility. And even before that, we all understood the concept of urban air mobility is not just limited to some corner of the city, but it also includes intercity, for example, communication, where we may assume more than one use space along the pathway and more than one use space service provider. So now these complicated scenarios, today we heard that, for example, and yes, we know by regulations that there may be more than one use space service provider within the use space. So today we heard that it might be that use space service provider doesn't cover the entire use space with the services, the company provisions. So there might be blind spots. Good. The question is this smooth transition from one use space to another use space, from one use space provider to the other use space provider. How much it is considered, we would like to hear if you could comment the progress. We know some work has been done before, but also the progress, how do you see it now? What is the current understanding? And also very important question that we hear that many people ask, those use space services, they are so great that even people from open category, they would like to consume them. For example, traffic information, for example, geo-awareness, for example, weather, whenever it is available service. And how do you see that? How you integrate this all, whether there is any document that will come, whether it will be considered in the future. So this is not the use space matter, but still somehow relevant to use space service provisioning outside of use space. So this way, can you please comment on that?
I can start a little bit for the urban air mobility, innovative air mobility, and then the colleagues, Stefan, Lina, and others, please complement. Just to clarify, U-Space obviously an enabler of innovative air mobility and urban air mobility, because you need to establish that to separate the drones of today from the future VTOLs, man-VTOLs taxis. So, but the man-VTOLs taxi, as we said in the AMCs and guidance material, considering that they have a pilot on board and they will start flying VFR, they follow under the traditional ATM. Traditional, I put it in like that because it's obviously it needs to be adapted. So it's a big enabler to enable drones operations to fly safely, efficiently in an urban environment, alongside with the man-VTOLs, provided that you have this framework. So this is to be specified. Then you have a scenario where you said, okay, you will have drones operations, BVLOS operations, and different bubbles of U-Space, one in cities, one in a logistic area, but in between they are outside, and how this all will work. It's definitively complex scenarios that you are putting, because what you are saying is that there will be very long BVLOS operations, which we need to be managed. As I said, when you have very long BVLOS operations, which going in different U.S.-based aerospace, this needs to be managed at the individual drone operator, and they will need to be a coordination of that operation across. So we need to apply SORA, we need to mitigate the risk outside the U.S.-based aerospaces, we need to have coordination for the flight authorization. So the operation center of the UAS operations, we need to have coordination for the flight authorization, entering in a new US-based aerospace, exiting for the other ones. So they will need to have multiple, let's say, service level agreements with different USSPs providing services in US-based aerospace. I want to clarify one thing. In a US-based aerospace, all USSPs need to provide services in the entirety of the aerospace. There are no spots where they will not provide services, otherwise they cannot be certified to provide service there. So this needs to be clarified. this notion doesn't exist. And if you have services outside U.S.-based aerospace, is individual credit. So each operator, we need to say, well, I'm using these services that they look alike U.S.-based, but it's not outside U.S.-based services. It's an individual credit to be taken for individual risk mitigation. I don't know if someone you want to complement, Stefan?
Yes, I will complete a bit. So those cases are sophisticated cases where I start outside, I operate in, I go outside. Are those things, or between two U.S.-based airspace, something that we need to discuss in the next phase of the MCGM? So this is at the agenda of the next discussion, because indeed we need to provide that flexibility, or at least recommendations what to do for such kind of operations. We know that the operators will not be, strictly speaking, operating the sole U.S.-based airspace or under the umbrella of the sole airspace, and those things will have to be discussed. And I hope to have also a coupling with the 947 in order to share properly the responsibilities. And I complete on your questions for an operator, if I properly understood, what about an operator which made change of service provider? That was correct, from one operator to move from one service provider to another one service provider? Yes. I have been given a nice analogy some weeks ago. It's like for you to choose between Waze or Google. The member state and so on, the cities will provide all the cartography and information. Us, as regulator and the competent authorities, will ensure that you will have the proper level of quality of services. Then, as your operator, you will have to choose between the two services. Some may be more interesting for a particular use case, in terms of coverage, efficiency, etc. But as a customer, you will be able to select the service you want to have for your operations. So really, it's like to choose between Google Maps or Waze for an operator perspective. That was the analogy. And I think it's great for an operator viewpoint.
Yes. Olivier Mourvicki from Eurocontrol Network Manager. As you are well aware, Eurocontrol is directly contributing visibly today to this work, and thank you for giving us the opportunity to participate. But also, we are the network manager, and that's what I want to express now, in charge of monitoring the impact of U-Space and new entrants on performance and safety of the existing ATM network. And in this context, in this approach, there was a kind of gap identified at two levels. First, a gap between the regulatory package that you are describing today and various visions of how it could be implemented, and a concept of operation and a concept that requires some building blocks, some elements which are still sometimes missing or subject to research, like the common altitude reference system or the separation values. Also, a gap between the regulatory framework on new space and the level of awareness at local level by people directly involved in operations. And it might bear the risk of different understanding and implementation at local level, which might be difficult to reconcile in the future. So my question is whether on these two aspects, you are intending to identify or promote a certain validated concept of operation or parts of the concept of operation in the future, and if yes, when? And further, if you are intending or considering possible guidance on the AMCGM themselves, because some of the AMCGM are very detailed with some technical specifications, and some others are very high level, leaving a lot of question marks and a lot of gray areas that the states themselves are facing when they address implementation. So is there an intention to conduct further work and provide deliverables on these identified gaps? Thank you.
Thank you very much, Olivier. I will start with the first part of the question. I will give the floor to the colleagues for the second part to complement, obviously. If there is any intention to validate existing CONOPS or CONOPS which have been in the research to further evolve the regulation. I guess you are referring Chorus and CONOPS or work on common reference altitude or subsequent work that is out there. Yes, so it's part of the continuous improvements of the first regulation. The first regulation, it was done in the setup and in the environment that it was the conduct at the time. But obviously, we need to improve many of these aspects, and we need to work on the validation of those CONOPS and let's say the maturity of those CONOPS, and trying to incorporate little by little in the regulation concepts can be then validated, mature, and standardized, such as a way to address the common reference altitude systems or separations. I mean, we have concepts and CESAR projects like Bubbles and many others working on concept of separation, which are based on CNS and different infrastructure. At the moment, they are in the exploratory research arena, and we hope that these concepts are being validated, mature, standardized, with performance of CNS that will be able to provide this, with assessments of networks that will be able to provide this level of accuracy that we are talking about in those CONOPS. So yes, I would say is in the pipeline. Now the timeline, so whether it is medium 10 or long 10, for this it would depend obviously of the level of maturity we can achieve. For the ANC and guidance material, and the evolution of closing the gaps and providing more guidance. Stefan, you want to?
That's at the agenda. We have plenty, indeed, of question marks. What is what we call geographic proximity, spacing? What is a good latency? All these kind of things which are indeed transferred to the airspace risk assessment on the member state in terms of definition. We need to find a way to complete that as much as we can. So this is also at the agenda of the next phase of the MCGM. I don't know to which extent we'll be able to complete, but that's something we want to try at a minimum and to consider. So we are collecting the gaps on all the domains, and there are plenty. But we, yes, we will try to find a harmonized way to tackle them.
To the colleagues, may I suggest to take the question? We will have another session like that, but we are a little bit behind the schedule. We're gonna break for lunch, and we take the questions in the next session. So we will have these sessions all along the workshop. Yeah, thank you. 1:30, please, back. Klaus? Sorry. But what was your question? That you have a nice lunch, whether here with the sandwich and whether online. And I hope that those who are here have a great opportunity to network and discuss a few more aspects during the lunch break. So we enter in the next block of the roles and responsibility in the U.S. space aerospace, and now we start addressing the Common Information Service, whether centralized or distributed. And we have in the slide two speakers, Angela Keys from DFS, the head of the Unmanned Aircraft System Department in DFS, and Antoine Martin from DGAC, the SAC, which is the Advanced ATM Officer, and he has been in US Space. I would say you are the DGAC, DSAC, US Space focal point since the beginning, actually. Unfortunately, Angela is not present, so you don't see her here sitting with us. It's not that Angela is Alberto. No, Alberto will be presented later. Angela, unfortunately, cannot be here. Well, fortunately, was a good, I would say, good thing. So, but yeah, cannot be here with us. Has more important things to do. But she has been involved and she has been leading this work package on common information services, and she has been definitively working on preparing this presentation. And I am absolutely sure that you have more detailed questions that I doubt you cannot answer, Antoine or Alberto, but if there are questions that cannot be answered, she will be happy to answer. So with this, I give the floor to Antoine.
Thank you, Maria. Good afternoon, everyone. I would like, I have a few slides to try to clarify what is common information service, or what are the common information services. I will go back to that contradiction between plural and singular. No worries. Don't worry. But first of all, I would like to go back to the basic questions. We have been discussing CIS, common information, since the beginning of this workshop. So we could assume that you all know what is common information and what are the common information services. But I will assume that you don't, and I will go back from the beginning. And first of all, common information is information. Yes, it's that easy. It's information, but not any information. It is the information that is required by the USSPs to operate in a safe and a fair manner in a given U-space airspace. Period. This is, I would say, a basic definition of common information. So basically, it's also about data. Information is something more than data. It's data with meaning, of course. But it is more precise in the regulation and now in the AMCGM. The common information is information or data, or at least information that is managed at the data level, which can be part of 4 categories of data of information. Obviously, there are the local requirements attached to each U-space airspace. As it has been explained earlier by Stefan, there can be local performance requirements set out for a given U-space airspace, as, for instance, as an outcome of the airspace risk assessment. You may have also many kinds of local requirements for environmental reasons, protection of the population, or whatever reasons. There could be local requirements for any U-space airspace. This information has to be made available to the USSPs so that they can process it. Of course, if you want to operate U-space services in a given U-space airspace, and as a USSP, you have to know who is active in that U-space airspace. Who are the USSPs that I should contact to get operational information, to interact, to cooperate? And if I am a US operator, I may be interested in knowing which USSPs are providing U-space services in this given airspace. This is also another category of common information, the USSP directory. Obviously, we need to provide geographical information about the airspace, about the U-space airspace, the state of the airspace, the adjacent airspace, the US geographical zones that are relevant for operations, for US operations within the US U-space airspace. Sorry. And this is another category of common information. the geographical information, but one geographical information, which is the geographical information pertaining to dynamic airspace reconfiguration, which is a geographical information that pertains to the last category of common information data, which is the ATM, ANS, Air Traffic Management, Air Navigation Services data. 4 categories. If we go into more details, here you can find examples of typical data that can be common information and provided as common information services. As regards local requirements, for instance, the state may or can prescribe density requirements or capacity requirements, equipment requirements, and things like that, because of the outcome of the airspace reassessment, for instance. Then this will be part of the common information in the local requirements category. Obviously, in the ATM ANS data, you can find the relevant operational traffic data that is necessary to operate within a U-space airspace, especially to provide the traffic information service, for instance. In the USSP directory, you may find all the necessary data to enable the cooperation between the U-space service providers. And that's pretty it. This is common information. Here we are at the data level. Then this data or this information has to be acquired by each USSP. And the way this information is acquired by the USSP is called a common information service or the common information services. You may use common information service or common information services. From a regulatory point of view, that's the same. It's just a matter of point of view, but it's kind of the same. So don't bother about that. The only moment when you must use the singular form of common information service is when you are talking about a CRSP, a common information service provider. But apart from that, you can use either a common information service or common information services. So the common information service or services are the services that allows USSPs to get the common information. And using that information, using that data, the USSP then are able to provide their use-based services. Of course, the common information comes from different sources of common information. I will come back to that later. And the diagram you can see here, it's important to be noted, is really irrespective of the technical solutions and of the architecture of the U-space and of the U-space airspace. Whether it is centralized or decentralized, it will be the same. You will have the common information services, and then the use-based services. And you also have exchange of non-common information data between the USSPs of data, which is not common information necessarily. So here we are at the service level. Then this service, the common information service or the common information services, are to be provided by some entity. Any common information that will be used by a USSP within a given use-based space has to be provided by a provider of common information services that we call a CISP, Common Information Service Provider. And this provider of common information service or common information services, of course, should be compliant with Annex 2 and Annex 3 of Regulation 664. Those annexes deal with fairness, openness, quality management, security of the data, and things like that. So, of course, the provider of common information services have to be compliant with the regulation, and the annexes. There are two types of CISP. You can have a non-single CISP, and you can have a single CISP. A single CISP is a provider, a CISP, which has been designated as the unique provider of common information services in a given U-space airspace, or in several U-space airspace, or in all U-space airspaces in a given country, and so on. But at a certain point, a single CISP has been designated by a member state to be the unique provider of CIS for U-space airspace. And it is a legal person, and it has to be certified under the basis of Regulation 2021-664. The certifying authority is either the agency, for instance, for third parties countries, and it can be a competent authority. It will be a competent authority of member state for others. And non-single CISPs are provider of common information services that are not designated as the unique provider of common information. And normally, the non-single CISP is also the source of the common information. And not anyone, not any entity can be a non-single CISP. It has to be a trusted source. And in most cases, it will be a certified source of information. So here is the service provision level of CIS. Here is an example. Please consider this illustration as purely indicative. It is not a recommendation. It is not a specification. It is not a requirement. It's just an explanation on how several U-space airspaces can be managed by several CISP. Here at the top of the diagram, we have a representation of common information for airspace, U-space airspace X, and in the bottom circle represents common information from U-space airspace Y. And for first example, the U-space airspace X, we see that a single CISP has been designated by the member state to be the unique provider of common information services for the whole U-space airspace, because maybe it's a national single CISP, whatever. In the second example, for U-space airspace Y, common information services are provided by 3 CISPs, and they can they all provide different parts of the common information. They are non-single CISP, and they are not single CISP then. And it has to be noted that, for instance, CISP2 here, it's a CISP for airspace Y. So it's a trusted source of common information for airspace Y, but it is not the source of common information for airspace X, because the single CISP remain the source of the CIS. But in some cases, the CISP will need to retrieve information from third parties, third aviation or U-space related third parties, to be able to provide the full picture, the whole common information. As regard requirements on the systems, on the procedures and things like that, within the EASA U-Space Task Force, we try to gather all the requirements, the known requirements, the known standards, and the recommended specification, and we came up with the list that is presented here on the screen. As I said, Annex 2 of Regulation 664 has to be implemented for common information services, and obviously the Eurocontrol specification for SWIM yellow profile is available as a technique that can be used to implement Annex 2 of the regulation. We also selected all the available and known standards at that point. This may evolve, of course, in the future. It goes from Eurocare ED 269, which is well known, through EAXM standards also, and we have listed also the Eurocontrol ASM handbook, because the AUP, UUP messages are mentioned in the AMCGM of USpace. So all those standards are coming from the AMCGM. They are available right now, and I know there are work ongoing, for instance, at Eurocare level, and so this may evolve in the future. I'm pretty sure that will be part of the coming works. As regards architecture, as already mentioned, you know there are two types of USpace airspace architectures. The first one is known as distributed architecture or decentralized architecture. Both terms can be found in the literature. In the distributed architecture, there is no single CISP, and all the common information is provided by CISPs, which are typically, for instance, the ATSP, which provide information related to dynamic airspace reconfiguration, for instance. You could have a local authority or military body who is also a CISP that can provide information related to the activity of certain US geographical zones and things like that. And the information is made available directly to the USSPs. Of course, it has to be done in a safe, secure manner, and this is the responsibility of a member state to ensure that when the member state appoints a CISP for when creating a USpace airspace, the source, the CISP, is trustable enough. In the centralized model architecture, there is a single CISP which is designated by the member state, responsible for the provision of all common information services within a given USpace airspace. The CISP will have to retrieve to get the information from sources. Maybe in some cases, the information will come directly from the single CISP itself because it manages already the data of information. But most of the time, they need to get the information from a source, a provider of common information, which has not necessarily to be certified, because only the single CISP is certified and becomes the single source of truth for information as designated by the member state. Of course, the single CISP is a monopoly for a given USpace airspace, whereas USpace services are part of a market. Obviously, US operations as well, apart from some states' operations and things like that. Within the EASA task force, we also addressed other practical problems for implementation of common information services. Of course, we identified the need to have some kind of governance, which is, in some cases, pretty much like the USpace airspace governance itself, but it could be also different. Of course, it is also very much interrelated with the coordination process as presented this morning by Vasilis. This is really interdependent, but we have identified a certain number of topics that can be addressed by the member states when establishing a USpace airspace and the governance of the common information services. Of course, the purpose of the governance of common information services is to provide the USpace airspace where the operations are sustainable, fair, privacy-friendly, environmentally friendly, secure, and most importantly, safe. Of course, we expect the member states to use the principles of legitimacy, competency, and transparency to build the governance of the common information services for the USpace airspaces. And We also worked within the task force on best practices. We have identified half a dozen of topics that are of interest in terms of best practices. Of course, it goes from technology. Although we don't have a list of best practices from a technological point of view at that point, this still a work to be done. We have identified best practices in the field of the designation of a CISP, of single CISP. We have identified best practices as regards the contractual arrangements between the member states and the providers of CISP. For instance, we have listed we have a checklist of what should be considered by the member state and by the CISP in their contractual arrangements. We also have identified best practices as regards financing for common information services. The fact, for instance, that air navigation services charges cannot be used to fund CIS or to provide use-based services. You must have a separate financing scheme. But at the same time, obviously, if you are an ANSP, you may use the air navigation charges to provide the data and the information that is required by the regulation 373, for instance, as regard the traffic data or the dynamic airspace reconfiguration. We also identified the needs to clarify how a single CISP with a European certificate could operate in another use-based airspace. And finally, we have identified best practices for the cases where you are a single CISP and also USSP. We know this is happening right now, but there are some obligations as regards separation between the two functions. And of course, as a CISP, you have to prove that you are able to provide CIS in a very fair and safe manner and in an independent way as a use-based service provider. And that's pretty it for my part. Thank you very much.
Thank you very much, Antoine. The suggestion is that we go on for the dynamic aerospace reconfiguration, and then we take again 20 minutes of question and answers, and we will address all the questions that they are popping up in the slide. Okay, thank you. So Alberto Iovino from ENAF is the head of operational support, and he has been working with us in the development of the dynamic aerospace reconfiguration. He was the working group leader for this aspect since basically 2020, actually. Yeah, so quite some time. So
I trust you.
Alberto, the floor is yours.
Yeah, those were weird times. We're all trying to, to pass it over. Good afternoon, everybody. Sorry for waking you up, in case I do. But actually, you're kind of an active, awake audience for an after-lunch session. So well done. It's Antoine's for sure. In the next 30 minutes, Antoine and myself are going to deal with dynamic airspace reconfiguration. You all know what it is, and also early in the morning, Stefan reminded us of what we're talking about. So what we're trying to do is to go into some specific basic elements, key features, key words. So hopefully at the end of this next half an hour, most probably we will not have cleared all your doubts, but hopefully we will be able to give you a better understanding of what the air is. You will see a lot of connections about the things that we're going to talk about. And this is very good in my opinion, because basically it works if it all bounces back from one item to the other, because that means that the overall system works. So you'll see what I mean by that.
Basically, what are the DR, what we may call the DR principles, what are the main features? So we have dynamic airspace reconfiguration. And basically, what is it by definition? It's a temporary adjustment of geographical limits of the U-space airspace. So the first thing we have to focus on this part is that what we are dealing with is an action which changes the airspace scenario. There is a volume of airspace which is designated to have certain characteristics, certain features, and from a point on, it changes these characteristics and features. It becomes something else. This is very important, first of all, and we'll go back to that from the perspective of ATC, because what ATC is dealing with is a volume of airspace. It has been mentioned before, we are not yet to the point that ATC is to take charge of tactical separation between manned and unmanned or the single unmanned operation. What they deal with is a volume of airspace, which makes things much easier under certain respects. The other thing we have to focus on here is probably that it's a temporary adjustment, and we will be back on that in a minute. Second thing we'd like to highlight is why we do it. We do it to accommodate short-term changes in crew traffic demand. We're using crude here because it's more politically correct, so I'll try to stick to that. No manned, unmanned, but crude, uncrewed. Basically, here the key is there is a change. There is a short-term change. And of course, the perspective is that of the crude traffic demand. We don't see it vice versa. In the regulation as it is right now, there is nothing like the dynamic airspace reconfiguration for changes in uncrewed traffic demand. Maybe in the future, this is something that is going to come. Maybe the thing, or actually, for sure, the thing is going to evolve. But right now, this is the perspective. Third item, it happens in controlled airspace only. There is a question which pops up every now and then about what do we do with dynamic airspace reconfiguration in uncontrolled airspace? You don't. There's no DAR in uncontrolled airspace. Maybe it's a tool that will be useful in uncontrolled airspace as well in the future, but right now it's only defined to be used in controlled airspace. One possible gray area here is ECO class airspace, because it's debated whether that is controlled or uncontrolled. Only AFR flights are controlled. So for sure, ATC would not apply dynamic airspace reconfiguration for a change in a VFR demand in ECO class, simply because ATC will not issue clearance to VFR. But would VFR be allowed to enter the airspace? It's debatable. I will leave it to EASA. But it's really a gray area, which I don't think it's currently statistically very significant in Europe. I don't know how much ECO airspace is actually present in your countries. In Italy, we don't have any at the moment, but it's an issue that is there. Any other airspace class, there's no doubt. Alpha, Bravo, Charlie, Delta, yes. Foxtrot, Golf, no. And that's no doubt about it. It's provided as common information. This is an important issue, and we will see a little more in detail in the next slides. It goes into common information, and this is very important to look at when we think of actually implementing. How do we arrange all the communication channels and procedures that we need for dynamic airspace reconfiguration? Well, common information service is where it goes. Of course, DR implies, has implications for US operators. They shall take action. They will have to possibly comply with revised flight authorization. They will have possibly to land, and we will talk about it in a minute. Interesting option, authorized flights outside U-space. This was mentioned before by Maria. Of course, while we are speaking, there's no U-space in Europe yet. Drones are flying. They are flying according to other rules. Some are European rules, some are national coordinated, internationally or not rules, but they do fly. So one option that could be on the table when dynamic airspace reconfiguration is applied that some US operations might be still allowed to take place under non-use space rules. Of course, this is easy to think about on paper. It's more difficult to think about in real life because this will become sort of a vicious circle. ATC needs to use the airspace, so they deactivate, and then they still have drones flying because they are covered by different authorizations, but it depends. There could be so many different possible scenarios. But anyway, this is an option. When we say leave US space airspace, one option is continue to fly according to different rules. Which are the enablers? This is a crucial one. That's one of my favorite because I do think that this is the most important part, and I'll tell you why. One issue is with use space airspace design. Why do we do it? We do it to ensure segregation. Segregation is where we are currently with having these new users in airspace in Europe. So the key word in uncontrolled airspace is awareness, traffic information service, network ID. In controlled airspace, the key word is segregation. Drones inside, crew traffic outside. Now, it has to be designed properly so that we are confident that who's inside is segregated from who's outside. It must be designed properly in order not to call for an excessive activation of the reconfiguration. This is one key figure. ATC has got the power. They can decide to reconfigure when they deem it appropriate. But if this happens continuously, something's wrong. If a volume of airspace is designated as use space and then is constantly deactivated through DAR, the design phase should be revised. Because on one hand, this is an additional task for ATC. They have to do something when they apply DAR, and we don't want unnecessary workload for ATC. On the other hand, this is disruptive for US operations. They cannot be flying there constantly fearing that a call is going to come and they have to stop and land and change path. So if a volume of airspace calls for repeatedly constant reconfiguration, most probably it's not suitable for use space designation. Second part of the enablers is work on predefined scenarios and precut portions. Dynamic airspace configuration on a pure tactical basis is hard to imagine because ATC doesn't have the tools. ATC must know in advance that deactivating a certain portions of airspace allows them to clear a certain approach procedure. They cannot just like apply a separation like 1,000 feet or stuff like that. This is tactical separation in ATC. They need clear information about what happens when they apply a specific reconfiguration. So if you can work on the horizontal or vertical, dividing sectors, corridors, subsections, whatever, anything that is done before will make things much easier when they happen in real life. Of course, the other side of the coin is minimize disturbance to the operations. If this fine-tuning work is not done in advance, the only tool that ATC will have is the full deactivation because they don't have tool to be more refined in their decision. This will imply that some US operations which could actually continue will be stopped. So if you construct well, if you do well your strategic job, then everything will be smooth and efficient and safe. So this is really a crucial part of for DAR. Now, some specific single features. What's the impact on UAS? Of course, they must comply. That's not much to say on this. Of course, we already mentioned that complying with this new scenario might imply a safe landing. That's, of course, first option, safe landing, or it could be vacating to an active piece of use space airspace. Forced landing should only be the last resort. This is quite obvious, but it comes to what we mentioned before. Again, ATC has got the power, but as for Spider-Man, power comes with responsibility. ATC shall not just take this tool as well. Well, whenever I need it, I'll put them down. It doesn't work this way. So forced landing is only a matter that will happen if there is a contingency. There's no way to coordinate anything. There's no way to wait for anything. Everybody out. That's all that ADC can do. The first part, so, is a matter of preparedness. Preparedness is crucial. Although we expect ATC to have to play fair, so to say, US operators in designated use space and control airspace must always be prepared to the eventuality of receiving an information that dynamic airspace reconfiguration is applied. So it's something that they shall always be prepared to comply with. Revised flight authorizations, safe landing, whatever. Forced landing, all in case of contingency. There is an issue of priority, of course, and this was already mentioned during the day. Some operations might have priority towards other operations, and not necessarily operations which are conducted by crew traffic. There could be drones which perform special operations. So this implies that sometime ADC will not be able to apply DAR because a drone special operation is taking place in the U-space airspace. This implies that shall be coordination, and we will spend a few words in what coordination means. This information must always be available to both parties because everybody must be aware of the existence of these special operations. Response shall be proportionate. GM says, try and start with vertical. If it doesn't work, try and move to lateral. In the end, fully deactivate. In order this to be possible, we are back to the strategic phase. This is possible if you designed U-space airspace in a way that you can apply this kind of line of thought. If not, all you will have is fully deactivate, and there will be no other options. So hopefully it could be a 3D multi-phased action. Coordination. Now, what do we mean? Coordination is a word that can have many various meanings. One thing that has to be clear here, once again, is not the well-known old ATC coordination. It's not like an agreement between two parties. ATC makes the decision. All U-space service providers have to do is to take necessary actions and give feedback to ATC when everybody's out, or if not everybody is out. So coordination here means information shall travel, because if information doesn't travel and if the thing is done abruptly, it's not efficient and it's in the end unsafe. Of course, it can be applied with a smooth start, good anticipation, or it could be just, an immediate implementation, which relates more to the contingency scenario. We know that an alert to the operation is supposed to be sent ahead, and we will go into the figures in the next slide. Anyway, the idea is that as far as practicable, sufficient time should be allowed to US operators to comply. And again, this is a matter of anticipation, and this is a matter of safety as well. If this doesn't happen, either ATC will not be able to apply it, or they will apply it. They would apply it. I don't think they will ever do it in an unsafe manner. What happens when everything ends? Okay, back to normal, and U-space service providers will issue revised flight authorization and or start again granting flight activations. So this is the main tool. When everything is ended, go back to normal, reinstate all the flight authorization scenario. It's a matter of data flow. It's a matter of information traveling, and that's all it is actually in U-space, and not only U-space. The picture here is depicting, I would say, one way to do it, which appears the most advisable, and I'll explain why. Basically, you have the air traffic service provider, ATC unit. They decide to apply the AR. This goes to a common information service. This goes to U-space service providers, which move the revised geo-awareness information and flight information and flight authorizations to the US operators. Everybody complies. Feedback the airspace is deactivated. When it's done, back to normal. Now, how does it work? Of course, if we have a distributed model, this data will flow directly from each stakeholder. If we have a centralized model, it is true that the regulation mentions some data exchange flows which are intendedly directly from ATSP to the USSPs. Not the common information, the dynamic airspace configuration itself, which is clearly part of common information service, but something which happens before, like exchanging of information about the presence of special operations, or the initial alert about the intention of reconfigure, they can be part of arrangements between the USSP and the ATSP directly. However, in a single common information service provider scenario, it does make a lot of sense to imagine this kind of arrangements to see the same data flow. Otherwise, you have to instead create two separate infrastructures, one for the data flow with common information and the one for direct exchange, which is not probably not the most efficient way of doing it. About timings, there is a GM which tries to give suggestions, directions on how in advance, what is the pre-advance notice that is suitable for the system. We try to refer to EuroCAE 269 geofencing. Of course, it is only guidance material. It could be different in different use spaces. It depends a lot on the airspace risk assessment. Anyway, the guidance material says at least 10 minutes advisory alert and at least 2 minutes caution alert. And of course, there is a need for a feedback. Last thing very briefly was because I think I'm a little out of my slot, or am I still there? No, okay. Okay, 1 minute and I'm done. You can see from the picture, and you can see in anything in the regulation, use space is a world which is imagined for a very, hardly automated environment. It's a huge, continuous real-time flow of data which travel in a distributed or a centralized model, but still, it's a whole bunch of information which travel constantly real-time, and everybody takes action accordingly. Now, to get there, you have to put in place big infrastructure and develop standards and everything. Now, one possibility, one question is there room for humans in this loop? Hard to answer. Of course, in the long run, it doesn't seem to be much, but it could be, it's an open question, it could be an interesting intermediate step. If some of the features of this information may travel as an intermediate step by all means, like phone calls or exchange of messages, which implies the presence of humans, this could be acceptable. And also this could be a good way of, helping the growth of the market, because it still allows for some degree of capacity. You can do things with this human in the loop way. Of course, again, it's an open question, and it's intendedly not the final goal. Last thing for me, and I'm leaving the floor to Antoine again. So basically, main guiding principles. Shared and actionable information, coordinated mitigation of resulting hazards. That's a matter of effectiveness. It has to be proportional, so commensurate, necessary, and sufficient. Gradual, we saw the 3D multidimensional approach. Crucial, precut designs, be strategic as far as you can. Timeliness, early notification, of course, as far as practicable. We don't expect the AR to be announced today for tomorrow, but as soon as ATC knows that they will tend to do it, let them know, because they will have more time to adjust. Anticipate, take timely action. So in the end, it's all a matter of a balanced approach. That's all on my side. So I'll leave the floor to Antoine again, and questions in a short while. Thank you.
Thank you, Alberto. I won't be very long. I would like to say a few words about what we are doing currently in the EASA task force on use space. we are being clarifying the dynamic airspace reconfiguration, for instance. And so I would like to explain that dynamic airspace reconfiguration sequence could be as simple as that. You have two steps, two stages, two phases, whatever the name you would like to use. First, the ATC decides to implement the dynamic airspace reconfiguration. Then it is the implementation of the dynamic airspace reconfiguration, full stop. And then there is a termination phase where everything is going back to normal in the use space airspace. This is as simple as that. Of course, the reality is more complex than that. But basically, that's what you need to consider when you implement a use space airspace. The implementation phase is about the ATS unit notifying, informing, telling, digitalizing, texting, whatever you want, but giving the information, which is common information, to the USSPs that are active in a certain use space airspace, in the concerned use space airspace. So the ATS unit convey the information that the dynamic airspace reconfiguration is being implemented in that use space airspace or in a portion of the use space airspace or a given scenario, predefined scenario, if any, are being implemented in terms of dynamic airspace reconfiguration. So the ATS unit has to pass over the message to the USSPs that the implementation is on. This diagram, again, is irrespective of the architecture of the technical solutions. There is no CISP here, despite the fact that, of course, the dynamic airspace reconfiguration information has to be conveyed as common information. So it has to be provided by a common information service provider at some point. But what's important here is that we have the ATS unit who decides the implementation and gives the information to the concerned USSPs. Then at some point, the AMC says that the USSPs concerned should acknowledge this implementation once the use space airspace is available to the crewed aviation. Like, this is the implementation phase. Of course, this is a nominal case. And the termination phase is just about informing the USSPs that everything is going back to normal and the dynamic airspace reconfiguration is ending. So the concerned portion of airspace is becoming back use space airspace, because before it was no longer use space airspace, but it is becoming back use space airspace at some point in time. And that's it. And of course, here again, there is no CISP, there is no US operators, but of course, there are US operators behind all that, because as it was presented by Alberto, the purpose of informing the USSPs, of giving the information to the USSPs, is to provide the US operators the information about the dynamic airspace reconfiguration, and then the necessity for them to react to that dynamic airspace reconfiguration in a timely manner. We have started developing some examples, some use cases of dynamic airspace reconfiguration. I will not go into details of all those examples. Please, these are only examples. These are no recommendations. And most importantly, the fictive airspace configuration that you can see here is not at all a recommendation. It's purely illustrative. I'm not even sure that there is any operational or business case for such a use space airspace. It's just an example. We wanted something as complex as possible in order to help explanations about dynamic airspace reconfiguration, but obviously a dynamic airspace reconfiguration also addresses more basic use space airspace, a cube or whatever geographical the description of use space airspace you need to design. But here we have on purpose a very complex example, which is not very likely to happen in the maybe at the first implementation. Anyhow, so we have developed examples as regards, for instance, the needs for a HAMS helicopter to land in across a U-space airspace. We also addressed the needs, for instance, for the ATS unit to deactivate a U-space airspace because there will be a drop in the airspace capacity, such as a drop in airspace capacity that could be induced by storm cells, for instance. Obviously, in some cases, ATC would have to deactivate the U-space airspace because of an emergency of an airliner, for instance, which have to execute an emergency landing. And of course, dynamic airspace reconfiguration could be used to manage unplanned specialized operation that could conflict with operations in a U-space airspace. But these are only examples. There are many, many other possibilities. We have also started developing best practices as regards use dynamic airspace reconfiguration, or DAR. It's simpler to say like that. Of course, we have identified best practices regarding the structure of the airspace, such as if you may have, for instance, a U-space airspace across two different ATS units. It's not a very likely scenario, but it could happen. Then you have to manage that situation properly in terms of design, airspace structure, design of your space airspace. Of course, there are relationships between the management of US flight authorizations and activations and the management of a DAR. Also, the governance of a DAR is a very important topic. It has to be taken care of. And most importantly, there are obviously issues as regards training, even for the USSP operators. And of course, for air traffic controllers, there are also potentially human factors issues as regards the provision of ATS, of air traffic services. And this has to be taken care of very carefully because this is a matter of safety. And for instance, we are talking about workload of air traffic controllers and things like that. So this is basically what we are now about the DAR. Thank you very much.
Thank you very much, Antoine and Alberto, for explaining, and Angela, who is not here but also has been involved in the presentation preparation. So thank you very much for having us explaining the Common Information Service and the dynamic aerospace reconfigurations basics, building blocks, and content of the ANC guidance material and best practice available at this point in time. We're gonna go, Alberto, through the slide. No?
So before the questions, the Q&A, I answer to the question of Alberto, and we have some questions on the chat as well with regard to class ECO. So actually, this is in the regulation. So there is no questions. You can go to the last appendix of the 664. You will see what is the scenario. So class ECO are controlled airspace, yes, but they are controlling only IFR. The VFR are not per se control. So that could be you may have a transponder monitoring zone, but they are not controlled by the traffic controllers. So if you look on the regulation, you have these mixed cases where the IFR, in class ECO again, the IFR will be authorized to enter the U-space airspace based on the DAR, and for VFR, based on the inconspicuity information that will be shared with USSP. So class ECO, we have two cases, either IFR or VFR, and on CAT Golf, we have the same mechanism, so inconspicuity for VFR traffic then. So I hope it clarifies. All the cases are already there in the regulation, so you can have a look.
Thank you very much, Stefan. So my suggestion at the moment is to go through the comments related to the CIS first, and then we address the comments related to the DAR. So For instance, there is a comment saying sharings of drones operation plans. Or that one.
Yeah. Okay, so start with the last question received. So can single CISP be certified without providing information about DAR if the country doesn't want to establish use space in controlled airspace?
Yes. I think yes, good, because there will be no operational needs. So the opposite would be really annoying. But in that case, yes, potentially a limitation can be put. The single CISP is not able to provide that information or to support information, but it is acceptable because there is no operational need, so there is no threat for safety. I will put a limitation to indicate the status of the certification, and I will accept the certification.
About the information on the SIS, so sharing of drone operations plans and drones tracks plus ATM tracks. So should we consider SIS information in order to ease the communications interface between NSPs and USSPs?
Sorry, I was reading there. So
that's for you.
So which one? Sorry.
I think it is. It must be. So this information is part of the common information. So tracks, I mean, information about the track. The operations plans, no, but the actual...
no, the drone tracks, they are not.
Well, the traffic information, yeah.
Yeah, they are part of traffic information.
Mm-hmm. So the operations plans, no. The traffic information, yes. Is part of the SIS.
No, the traffic, sorry. Which traffic information?
Yeah, could you read the question?
Yeah.
Sharing, you don't have it there? Okay. Sharing of drones operations plans and drones tracks plus ATM tracks should be considered common information in order to ease the communication interface between NSPs and USSPs. The language used is obviously not something that is...
So the answer is the ATM tracks, yes, the rest, no.
No. With Mike.
Because we want to provide information about accepted flight plans and okay, thank you. My question is similar about providing information about accepted flight plans and maybe tracks in CISP, because when we are thinking about USSP and CISP, everything works when we have, for example, 1 or 2 or 3 USSP in one use-space airspace. If we have 20 USSP in one use-space airspace, it's possible, it's commercial, yes. You have to sign 380 agreements between them to share the information. And this centralized model, as you showed on the basis of dynamic airspace reconfiguration, and the information goes to the CISP and then to the USSP, don't you think it's good also for sharing information about accepted flight plans, that each USSP gives the flight plan to the CISP and CISP then distributes it into the other USSPs?
Well, if you find it convenient and it has an interest, you can do it, but it is not a regulated service of the CISP. It's something else. It could be the interaction between the USSPs, between the operational actor, can be supported by some kind of centralized platform or services that could be provided by the CISP. But it's not part of the common information services, and it is then not part of a regulated services from this part. It's part of the regulated use-space services, and it is part of the certified services managed by the USSPs. And that's the difference. The regulatory basis is not the same exactly.
It's not the same. It's not addressed as a regulation today. So going that way, it's a need fragmentation of the UX. This is something we would like to avoid more, because then on the index go by the USSPs certified with a so it would be technically possible. This is not
Okay, but in this scenario, the question is about the single source of truth, yes? Because there are two ways, yes? The exchange of the information between USSPs, as we have in our regulations, and we are obliged to do it, and the other stream that goes to the SISP and is distributed by SISP. I think it's a matter of further discussion, because the regulation works when there are few USSPs, but when we think about many USSPs and we cannot deny it, it can be hard. Thank
you. I'll pretend to be Angela Keys for a moment. Yeah, no, I'll just steal a minute of your time just to share a burden which anyone who was part of a rulemaking group will understand. When you're chosen to be part of a rulemaking group, generally your life becomes quite miserable for a while, because normally your organization doesn't, relieve you from other tasks. They expect you to keep on doing your job, but at the same time, to work for the rulemaking group. And of course, what you're doing in the rulemaking group is a quite serious thing, because in the end, the result of your work will be EU rules. So it's not like a piece of cake. And so while we're doing this, we also had these discussions about, I was the team leader for DAR, and I was also in the group for net traffic information. But we had plenaries when we had discussions with all the team leaders, with all the subjects. And one thing that was always around is centralized versus distributed model. What is supposed to be done in one scenario and one in the other. And of course, we were trying to also getting, inputs from outside the groups. And there was concern about those who were already intending to apply the centralized model, because they were scared about, having problems. And basically, the result that you can see in the regulation, it's a whole bunch of instances when you read via single SIS, one established. You can see it so many times in the regulation. So in all these instances, it is clear there that it could be done through there. When it's not there, of course, my understanding is nothing prevents from, unless it is contrary to the rule. So what should guide you in making the decision is asking yourself this question: is it forbidden? Is it clearly stated it should be done some way else? If it's not the case, in principle, if it complies with all the other rules, it's an acceptable option. It has to be efficient, it has to be rule compliant, but that's how we worked. So I would suggest use this as a guidance, and this could help. Thank you.
So if I made, yes, that's obviously a good principle, a good practice, but considering interactions within the single common information service that belongs to USSP's responsibilities, we need to be clear that sort of implementation is not in the spirit of the regulation. So we need to be clear. Obviously, perhaps you said, okay, tell me the paragraph or the article that actually forbid it, and then, okay, maybe it's not forbid, it is allowed, but it's not in the spirit. And as said by Stefan, this will create, obviously, a disharmonized approach of implementations across the EU, which at the beginning may not create problems, but then it may be then later on. So obviously, each US space is unique on its own, on its aerospace, is very local. And okay, we need to see how it works. So there are more forces. Yes, there is one actually which disappeared, which was addressed to you, Antoine, but disappeared already. Yeah, but okay. Okay, this one. Who can answer?
Maybe Antoine can start, and I will.
Yeah.
The first one.
Yeah, criteria for.
Well, I will answer the question in a very easy way. In some cases, you know that you can trust the provider of the common information. For instance, when it's a certified ANSP, then you are likely to trust the data because it is already compliant with a bunch of safety, security, and whatever requirements prescribed. So in some cases, it's easy. In other cases, you will have to develop your own criteria, but the task force, and maybe Stefan will have a chat on it, is thinking about developing more material on that matter.
So I can only confirm. So the assumptions on the regulation or behind this regulation is that the CISP will be somehow so state entities already certified or already trusted, like weather information, like ANSP, etc., etc. So they will have extend on the provision of service to encompass the new data to be provided to USpace, but they are already trusted and certified organization. So it's why it's not required to recertify them because they are already. The case we may have, and today we don't have concrete case, so it's pure speculation. A new organization, not state already organization, a brand new organization, may provide the service as a CISP, not a single CISP, but a CISP. In that case, what do we do? So we have some proposal in the task force in order to create a kind of a HADOP process in order to get a similar level of quality and integrity of the data than the others. That's the spirit. We cannot accept any new organization providing data without any control, and especially common information, which are absolutely mandatory to ensure safety in the space. So we need to control them. So that's something, yes, I have some proposal in the frame of this task force. You may see that when we release the documentation.
Okay, so there is one question about dynamic aerospace reconfiguration, which is very interesting, and is which tool is envisioning for to be in place in order to replace the DART in aerospace classes where it is not intended to be available, considering that some flights may need to enter those aerospace portions, so like police and hands.
So it's not really on dynamic specific function. It's on non-dynamic. I mean, yeah.
It's a non-controlled aerospace.
When we don't have it. Okay. Well, I don't know. I can give you my point of view, but it's really personal. Of course, in that scenario, there's nothing like, again, segregation. It's all based on awareness. Uncrewed traffic will be made aware to traffic information service about the presence of manned traffic and they'll give way. Now, question I understand is if this uncrewed traffic is special operations priority, how does it work? First of all, we have to deal with the subject among drones, because of course this is going to be part of the dynamic flight authorization system as well. The first come, first served criteria might not always work. Sometimes who comes late will have priority. Of course, we are also dealing with people that sometimes will not like to be part of the information system. They will not want to tell you why they're here, what they're doing, where they're going. So this is something that we face in legacy aviation as well. So I do believe that the system should definitely get prepared to have this information available at least to the service providers to the extent that the authority performing these operations will deem appropriate, because sometimes they will simply not, they will fly. They do with manned aircraft, so they will do it with drones as well. Once this operation is in the system, it should be identified and keep, classified as far as practicable, but it should be shared in principle with the other stakeholders. Of course, these kind of operations, unless they are able to generate an reservation, which will make sure the crew traffic will not interfere, we will have to develop some form of self, due regard, however you want to call it, capability of self-separating and self-assuring safety, because once again, they will not likely desire to be 100% part of the system. So the system will not be able to 100% handle them. And that's what I can think of.
In addition to do that, also we have the GeoAwareness service, which is actually there is also a guidance material, which is what we suggest to use, but obviously it needs to be an implementation on the EU Space Aerospace that there is a digitalized access of those police specialized operators and being authorized a priori to issue aerospace restrictions. And through the GeoAwareness service, it could be then a dynamic aerospace restrictions, which become a no-fly zone to be avoided and managed by the USSP flight authorization or GeoAwareness information during flight. But of course, it requires the implementation of digital access. Plus, we now on the aerospace matters, they need to have the authority to be able to issue those aerospace restrictions. Alternatively, from the hands, and this is something has been explained by Alberto, is not to be used as a hands because they are not per se an emergency, but there is the electronic conspicuity. And there is this emergency status that could still be applied if ultimately it seems to be necessary. But obviously, it was more for the emergency of the aircraft itself rather than for this type of operations. But I will say the tool to be used there is more the GeoAwareness service with a dynamic airspace restriction properly managed, obviously, at the state level that they have the authority to issue those aerospace restrictions. I would say this for state operations. And there is some colleagues asking the hand. We have plenty of very good questions, colleagues. Okay, let's take a couple of questions from the floor, but you want to take another?
Yeah, I take this one.
And then we come back to...
Sorry, yes, just to take this one. So indeed, today we are missing a set of defined information. So that could be, for instance, one outcome of the task force paper managed by Antoine to help us to draft kind of GM. MC, I don't believe, but a GM at least to ensure that we have a common understanding of what should be provided from the system. Yeah.
Yeah.
And
let's take a couple of questions from the floor, and then we go for a short coffee break before we enter in the last approach for the land of today. So, okay. Sure.
Yes, I have a JB from Skyglobal Belgium. I have a question for Alberto related to dynamic airspace reconfiguration. I think in the beginning you made it perfectly clear that the concept of dynamic airspace reconfiguration is kind of to be applied exceptionally, in the sense that if you would do it too frequently, making room for crewed traffic, you probably haven't done your design very well in terms of creating new space airspace in the first place. And I think we can all endorse that idea.
And you specifically mentioned to the fact that it's not really designed to make extra room for uncrewed traffic, because that could be one of the consequences. But on the other hand, from a commercial demand, I think in Europe and specifically in Belgium, a lot of airports are close to cities, are close to industrial areas. So there's quite some demand out there too. So of course, next to the safety aspect, when designing U-Space airspace, the commercial demand is yet another very important parameter to be taken into account by the member states. So that's why in Belgium we try to, and I'm not speaking for Skies, by the way, which is the ANSP, but the idea of using dynamic airspace reconfiguration, for example, in places close to the airport, around the center of the runway center line, for example, and have U-Space airspace kind of by default deactivated, and only when sufficient demand is there, you kind of undeactivate it, make it more active again. But that's kind of in contradiction with the not doing it very frequently. Would that be, in your mind, the next step of the legislation, and you would recommend of not doing it now? Because there's plenty of reasons, as I said, from a commercial point of view to do it. There's some safety concerns that would need to be addressed, but I think that can be addressed by using DART.
Yeah, thank you very much. Yeah, of course, I'm not in a position to either recommend or not recommend anything to any state or authority that would like to. Of course, what I tried to explain, and you very well recalled, is a basic principle in the current state of the art of the hard and soft rules. Says in uncontrolled airspace we could go all the way to, if we don't want to say integrating, at least mixing crewed and uncrewed through awareness, information, and flight authorization. In controlled airspace, currently, so far, the best that we could do is segregation. Segregation is a rigid system. That's not much to do with it. Dynamic airspace reconfiguration was introduced to get some degree of flexibility, but of course, this flexibility is not unlimited. Now, in principle, nothing prevents from having DAR applied 500 times a day. As far as it is done properly, I mean, it's within the rules. It's more a matter of deciding whether it's efficient and, good for the system. For example, a volume which is designated, even if it's conflicting with crew traffic at the airport, if the airport is a low-density airport, could perfectly work. Anytime they have a landing or a takeoff, they deactivate. But if this happens 10, 20 times a day, it could work. If you want to do it in the vicinity of Frankfurt or Heathrow or any other very high-density airport, it would be a different story. Now, I do think that is going to be a next step, but this goes a lot together with the increasing trust in performance of US operations, meaning once you have to establish what is the volume of airspace that you have to segregate, if you don't trust drone operators inside, you will apply big buffers. You will have a huge volume of airspace for small things happening inside. While operations, technology, procedures, the whole system gets better, and we develop systems for monitoring, we develop systems for exchanging information, trust will increase. And we will be able to say, well, if there is a drone flying at 100 feet, we don't have to consider it interfering with crewed aircraft at 1,000 feet, which is sometimes the case nowadays, because you apply such big buffers that they don't see each other, but they are considered interfering with each other. Going to this, we will definitely lower the volume of airspace that we need to segregate, and this will allow a smooth coexistence. The final step might be that of tactical separation, but in the end, I don't know, this is a little far away. Maybe if we really succeed in having enough confidence in both of them to consider them, not interfering with each other, in the end, tactical separations will not really be needed. We could concentrate on something else.
If I may complement your answer, I fully agree, Alberto. Thank you very much. The dynamic, in the current regulation, the dynamic airspace reconfiguration is not the only tool to manage dynamically the airspace. You also have US geographical zones that could be used to manage in a dynamic way your space airspace. And then it's not dynamic airspace reconfiguration, it is something else, but it can be used also to activate your space airspace for a certain period of time in day when needed. It's another way to support that operational case.
I will confirm and conclude on this point. Yes, Antoine is absolutely correct. This is what we call dynamic restriction. It can be set up along the flight. It's why the GeoAwareness is also a tactical service, because it will provide this information. And I would thank you all for the very good comments that we have on the Slido. We are going to see how we can manage them, because plenty of them are very, very interesting. And we would like to provide answers. So as I said this morning, maybe a webinar on this topic will be interesting, and we'll gather the comments. I will thank you, our two presenters, and again, for the very good information presentation provided today, and propose to break for a bit less than 15 minutes at 10 o'clock, and we will continue with our colleague who will be online, Jonas Stenberg, about USSP role. Please take a seat. And Maria, I pass you the ball.
Thank you very much, Stefan, and good afternoon. Hope you enjoy your quick break. Please take again your seats. And we need to start. We have now 3 very important topics. We take 1.5 hours, and we need also to go through some questions, and we don't want to finish very late, because otherwise tomorrow you will be very tired. So let's keep the pace that we are having. So the next presenter is online, Jonas.
Hello, everyone.
Hello.
Good afternoon.
Good afternoon. Jonas Steinberg is from Robot Expert and is the Senior Vice President and partner of Robot Expert. Is consultancy technical company based in Finland. Jonas has been involved also in the US space development, like Alberto and like the other work package leaders since the very beginning of the AMC and GATTEX material development. And he will continue on roles and responsibilities, but now for USSP. So Jonas, the floor is yours. I don't know if you want only to present verbally, or you want to put your camera. I don't know if this is possible, but otherwise.
My camera is on and I'm driving the presentation from here, so right. I'm good to go if the technology just works. So good afternoon, everyone, and greetings from Finland. It's extremely hot. We had 30 degrees yesterday, so I'm sitting here in shorts while you are in air conditioning there on site, and all hi to everyone online as well. So the work package focused on the USSP, foremost Article 7 and also Annex 5. I was joined by a good mix of people there. Axel from Avinor, Benoit from Focan, Tom Lutz from Frequentis, Mateusz from Panza, Kuhn from Unifly, and Matt from Wing. So we had USSPs, we had ANSPs, we had regulator on board, so it was a very well-balanced team. Now, fasten your seatbelts to keep your feet on the ground. There's a lot of details to go through as well. I hope that we can also come back to unclarities in the questions and answers. So the interface standards where USSPs should connect to other USSPs and also to air traffic service providers. If you go through the articles, you will see here in the middle, network remote identification, the ASTM 3411 standard is what we have today. Flight authorization 3548 ASTM standard to exchange that information, including a DSS mechanism. Then geo-awareness and this geospatial information is the same as used in the drone regulation for geospatial elements, the ED269 today. But as you will see in the footnote, the ED269 will be updated to another Eurocard standard during this year. Still, work is ongoing. So in the earlier sessions we had this, is this information flowing directly between USSPs or is it going via some central? That's more of a, a local setup. The format of the information is the really important one. The expectation in the regulation is that this is communication directly between the USSPs, but of course there is some local flexibility. The important thing is also from international scalability in Europe that we are using as much the same interface standards throughout Europe as we can so that we get this ease of migrating businesses and drone operations from one country to another. There are, as you say, the orange arrows here are things that are still to be standardized: conformance monitoring, weather information, alerts, degradation of services. This is work that needs to be happening through dialogue between industry and regulator and local authorities to see how we implement. On the left-hand side, in uncontrolled airspace, you see that manned aircraft conspicuity, where they can use ADS-B or they can use ADS-L as the new one, the ADS-L for SRD 860, which was published beginning of this year. This is these old FLARM type or SkyMaster, other systems that are using this 860 megahertz band for conspicuity. This will be made, to my understanding, through firmware upgrades that these entities can see each other, and the USSP should be able to pick it up with ground infrastructure, either their own or something that they purchase. The cellular part, which is the third part of the manned aircraft conspicuity, will be covered in later sessions, but that's not yet ready. It's something that's in the works. So we'll add a little bit to this one. You see the dotted line here, SWIM yellow profile technical infrastructure. That's why the YPTI says on the right. So we expect all of these transactions to use this SWIM technical infrastructure. We come back to it a little bit later in the presentation. Boom. SIS. We are looking at SIS on the right-hand side with sort of the member state information, the airspace information, service register, meaning who is serving what. That could be an Excel list, it could be some fancy online system. UAS performance requirements have been presented, electronic registration. And when the ATS is involved, the air traffic services, the manned traffic information is then flowing down to the USSPs, directly to USSPs or via ideally do the SIS, because this is SIS information. What the format is orange here. It's not clear. Asterisk, something else. This needs to be, again, a dialogue. What is the standard for sending manned traffic information to USSPs as the SIS information? There could be a single SIS provider could provide protocol conversion as long as the information is not altered in any way. Between it is a dotted line for network remote ID. It's not SIS information, but ATSPs are an authorized user of network remote ID information. So it may be that in some use-based airspaces, the local conditions say that USSPs have to send this kind of network remote ID to the air traffic service provider. And again, whether it goes through a SIS, organization or not isn't in the regulation. It's not SIS information, but the organization could, of course, handle it as a network gateway. Dynamic airspace reconfiguration, both ways, the request and the acknowledgement, we saw that earlier. Now, one more on the same. On the bottom, you see US operators. There is no standardized interfaces between the USSPs and the US operators. That could be proprietary. What is, however, the dotted line around everything, let's look at what said the SWIM yellow profile technical infrastructure, taking one step back. It says in the Article 7 that between USSPs, you should use the yellow profile technical infrastructure. In Annex 5, it says that between ATSPs, the blue boxes, and the green boxes, you should use yellow profile technical infrastructure. The regulation doesn't say that the SIS information should use yellow profile technical infrastructure. However, in Annex 3 and Annex 2, you will see that the same requirements for secure and standardized open protocol information also applies to SIS. So the strong recommendation is that because this ecosystem is starting to be built on yellow profile technical infrastructure, why reinvent the wheel and instead use the same approach throughout this upper part? The US operator, we will come to the two ways US operators can connect to USSPs shortly. If you connect through an API, and this is my personal strong point, it's not standardized, but I strongly recommend USSPs to consider endorsing the yellow profile technical infrastructure also for API integration with US operators to keep the data secure and to keep the service descriptions as easy as possible. I will not go through this slide. I'll leave it up. Anyone who wants to take a screen grab of this one, it will be in the web recording. It is a listing of the different services, the data models and formats, the latency requirements, and the standards that it relies to. I will count down from 5, and then I'll go to the next slide. 5, 4, 3, 2, 1, go. So, coordination between USSPs and ATS providers. We talked about earlier that there are some activities that should be coordinated directly with ATSPs and USSPs. And that's related to emergency management, mostly aircrafts, US emergencies, and system degradation. These are the principal sources of some non-normal behavior. Now, there needs to be this coordination of activities. I would be very surprised if different USSPs in the same airspace, same U-space airspace, were subject to different coordination procedures with the same ATSP. I don't think it's rocket science to realize that if there's an emergency, everybody needs to use the same procedures as long as possible. So an air traffic service provider could very well expect all USSPs to sign up to the same procedures. There might be some performance differences in the USSPs or some other local conditions that one size does not fit all, but I'm sure that can be locally clarified. But then the relevant operational data and information that should be exchanged between USSPs and ATSPs is from the ATSP side towards USSP, the relevant man traffic information, that's SIS information, dynamic airspace reconfiguration request, SIS information, contingency, emergency, or manned aircraft in U-space airspace. And what do they get back? They get acknowledgement for DAR. They get information about US special operations in U-space airspace, and also, if relevant, non-conformance detected in U-space airspace. Now, what is relevant? That could depend, but if we have a non-conformance somewhere inside, well inside the U-space airspace, and there is no imminent risk of it going outside of U-space airspace, as an ATSP, you don't really need to care. It would be maybe nice to know, but it's not need to know. However, if there's a risk of a drone slipping outside U-space airspace and causing a safety hazard, then it probably is very relevant for the USSPs to push this information out to our ATSPs. Of course, if there is an announced contingency in emergency of US, same logic here. And as I talked earlier, network identification is optional, but ATSPs may want to have this information. And both ways, of course, system and service outages, shortages, degradation, or inability to contact USSPs and alerts need to go both ways. Between the USSPs, apart from the block diagram we looked at earlier, all USSPs need to use the same interfaces and procedures in a single use-space airspace. So if you go to a use-space airspace as a USSP, you need to play by the local rules. That's natural. But this is a double-edged sword. Again, to ensure that we are not having different implementations and huge barrier entries in different countries, there's an immediate need for different member states to align and agree on what are the interfaces. And here there are the standardization bodies really call to action to make sure that we get standards to support this as soon as possible where there are gaps. So we need to work both industry regulators across Europe to make sure that we have publicly available service descriptions how to do it. So let's move down in the block diagram to how the USSPs connect to US operators. There's two ways. The classical where we started a lot of discussion, a lot of public perception is that you will get an application, a use-based app, and you will, look at your mobile phone, your tablet, or your laptop, have the app, and you will enter your flight authorization request. You will submit it, you will receive it, and you will get permission to fly. That's all good and well. That makes it easy to certify the service provision because USSPs are certified, and also their app is therefore certified. You don't have any gaps in data integrity. And a lot of visual line of sight flights where you typically have low complexity flight plans. You can put a cylinder or simple polygon into it, fly a short range flight. It's a no-brainer. However, if you have more advanced flights, let's say you have drone logistics, let's say that you have multi-hour flights staying up for 1, 2, 3, 4 hours, it's not really meaningful to start to draw segmented, time differentiated, whatever operation plans on a screen that is different from your fleet management solution or drone control stations. There we expect that a lot of advanced flights and BVLOS operations will want to directly integrate with use-based service providers so that when they create their mission, they automatically can file a flight authorization for that mission. If there are dynamic changes, they get automatic alerts on their main screen. And over time, also expect that drone manufacturers, the big market leaders and other ones will want to integrate with USSPs so that users are guided to comply in the right way, also in the open category, which will be the majority of the users in use-based airspace early on, to work in the right way. More details. Service level agreements with US operators. It's in the regulation, but a few questions have come up in comments earlier. So we really expect one-stop shop. A drone operator can reasonably expect to have all use-based services from one entity. That entity can subcontract service provision to other ones, but the use-based service provider is still legally responsible for providing the so-called bundle. If the local use-based airspace requires 4 services, then it's 4. If they require 5, then it's 5. And if it requires 6, then the USSP will have to provide all 6 services. The USSPs will have to provide all information in machine-readable form. That doesn't mean that a scanned PDF is not machine-readable. It needs to be information in a form that a machine can unambiguously interpret. A typical NOTAM, as they are today, may or may not be machine readable, even if it's electronically available. If it's not following the exact standard of the NOTAM, and you have a comma instead of a point, then it is not machine readable. And this is something that will probably require discussion in member states, how to ensure that for use-based airspace, for instance, NOTAMs that activate airspace are adhering to the exact format of the NOTAM standard. They need to have instructions how to use use-based services. They need to know that degradation of use-based services and what are the contingency procedures. They will need, use-based service providers will need to provide operating instructions for the CONOPS, which was talked about earlier, so that how do you act in use-based airspace? What are the flight procedures in normal, in contingency, and in emergency conditions? Then safety critical information alerts. And in additional, in the service level agreement, you need to have how do you stay connected to the USSP when required. Not all use-based services are required at all times. Before and after the flight, you don't need network ID, for instance. And you also, depending on if it's a human-machine interface application, API integration, or both, that needs to be in an agreement. And also, if you connect via an API, you need to have in the SLA, how does the US operator inform the USSP about service degradation? From Article 6, we get, what is the performance of the US? How do you maintain sufficient level of performance of the use-based services throughout the flight, including connectivity? And then the US operator contingency measures and procedures need all to be settled in the SLA. And of course, in uncontrolled airspace, the USSPs will acquire this e-conspicuity information about manned aircraft from ADS-B, from ADS-L, and from cellular. This is not necessarily a service that comes for free for the USSP. They might either invest their own money and build ground infrastructure or source this information on the free market so that they can provide the traffic information about manned aircraft to US operators. A mouthful. And then swim. Swim or sink? Well, I say swim. It's a lot of confusion. The swim yellow profile, it's a 78-page document, and you need to conform to the requirements in Annex A, which is a 3-page document inside of the 78-page document. The swim technical infrastructure yellow profile, it's sufficient performance for use-based airspace. We don't need hard real-time as in the purple profile. Yellow profile is quite enough. It's flexible and it's interoperable. It supports HTTP, it supports AQMP and other popular protocols, which we look at on the next slide. So if you think that, this feels scary, it's not. The ANSPs are adopting it throughout Europe. It is it takes care of a lot of the cybersecurity aspects that we have requirements for in the different annexes. So it really is in the sense of making an interoperable European market. This is low-hanging fruit. You go in there, you look at the requirements. Are they mandatory? Are they optional? Are they not required at all for your chosen bindings? And then you just go with that one. So if you open it, you can look at, for instance, VS Lite or MAQP messaging here, popular ones. You open up the Annex A, and in the Annex A, if you're using VS Lite, what are the requirements? The same for all of these other ones. So when we've been faced with questions, we don't like swim yellow profile, we think it's scary, we don't want to do it our own way. Every time people sit down with it, digest it, go through it, discussions very quickly end up with, okay, I can work with this. So I urge you, take a look. Yellow profile has nothing to do with service descriptions. There are 2 words of swim here in the requirements, and one is the yellow profile, the other one is about service description. It just happened that the swim ecosystem had a convenient document for doing service descriptions. And what is a service description? A service description will tell, for instance, the interfaces, what is the payload, what are the data types, what are the enumerations, so that we can agree on how is, for instance, altitude encoded. How is a position? So is it VGS 84? Okay, do we use a decimal? Do we use decimal degrees, decimal minutes? What is the format? If we don't have this called semantical compatibility, we are not understanding each other when we try to integrate. And a service description will also tell the operational and business context. So it will need to tell how do we process the different data. If I, in a flight authorization, do this, then it will lead to another state in the flight authorizations. The standards that we have, they really go a long way of covering being a service description. So a service description, when you are using one of the prescribed standards, then you really can only make a wrapper and fill up any gaps that are around that one. And the first time you do it, it's a little pain and a learning curve. But if we as an industry and as Europe, if we are not making how to connect to other entities well documented, if we are not making that information publicly available, we are in the long run going to end up in dead ends where it's not possible for latecomers to integrate anymore. So this is not about the service that you do, how do you process a deconfliction scheme in your algorithm. This is about the information exchange. How do you connect your flight authorization service to another USSP or to SIS or to whatever it is, network identification to ATSP. So this is about the information exchange that needs to be documented with the service descriptions. And we don't need to post them in the SWIM registry. The requirement is only to make them public. If you make them public on your homepage, just as you would like an API listing, that's enough. So with that, I pass the mic back to Colin, and we can have some discussion or go to the next.
Thank you very much, Jonas, for the very detailed presentations, and thank you very much for being available remotely. This suggestion I have, Jonas, if you are able to stay with us, is that we have the three presentations, the one from Stefan on the UIS operators and the one from Vladimir on electronic conspicuity, so demand traffic responsibilities. And then the little, so a couple of slides more on the data quality and continuity, and we address all the questions together. So we have half an hour question and answer. So is it still okay for you in Finland to stay?
I'm here both days. This is super stuff. Thank you.
Okay, thank you very much, Jonas. So just stay in tune, no? So Stefan, now back to you.
Yes, I am reading the floor, synchronizing the presentation, so I hope that, yes, seems to be okay. So after the USSPs, we would like then to discuss about the operators. What needs to do the operators? What are the principles driving the activities of the operators inside use-based airspace? We're going to try to clarify what are the main responsibilities. So as I said this morning, the operators are responsible for the safety of their operations. And big clarification for that, they are not relief of SORA. The SORA and the 947 remains applicable, and they will still to have to seek an agreement and authorization with their competent authority, especially with regard to the ground risk. So in use space, the air risk class should be determined by the airspace risk assessment. So I will come back to that in a second. But the ARC should be already processed through the airspace assessment, meaning that all the evaluation of the air risk that an operator still need to do today outside use space should be managed at a higher level. The operator should apply the SORA, but with a kind of shortcut in his analysis when he operates in a use space with regard to the air risk. However, all the evaluation of the ground risk, do I need to have a fence, do I need to call or have the support of the fire brigade with regard to my kind of operations, etc., are still under the responsibility, the direct responsibility of the operator. And accordingly, all the satisfaction of the related TNPR are the responsibility of the operators. So once again, it may take credit of some services coming from the use-space airspace, the use-space airspace and service use-space services, but the demonstration is still the responsibility of the operator. Meanwhile, all the operators, I think it's quite obvious, must subscribe to the use space services and properly use them. So for instance, don't take off without flight activation. You know, when you prepare your flight, ask for a flight authorization. So this subscription to the service will allow two things. First, obviously, to get access to the use space airspace. So that's the condition to get access to the airspace. But why? What do we want to mitigate for the operators? We want to mitigate the risk of mid-air collision. That's all what it's about, between drones and between manned aircraft. So the subscription to the service, which may not be free of charge, indeed, will support two enablers for the operators. I can fly and I can safely fly. Something which is quite important is the mid-air collisions, the reduction of the mid-air collision. Here I put the sentence or the words coming from the 947 are mitigated by common structures and rules. And with that regard, the operator SORA may be facilitated because that's something we are discussing in the frame of the task force. That's the recommendation we are doing. If an operator has operation in a use space airspace, we believe that we can somehow reduce the level of risk and to reduce the arc. In that case, if, for instance, we are able to target an RB, immediately the sail will drop because we have only RB, and then the SORA of the operators will be somehow simplified. If you have a small aircraft, a small drone, you may easily target a sail 2, which will relieve the operator to a certain requirements and definitely will ease the overall process of authorization. So that's the kind of waiver or bonus for the operations inside use space to compensate indeed the subscription to the service or to take benefits of the service and that must be subscribed to reduce the risk class. The operators will have to prepare their flight, meaning that as per the SORA today, they will have to define the flight geography. They will have accordingly or alternatively to define the drones or unmanned aircraft trajectory. They will have to consider the geozone, which could be set up inside the use space to avoid or to ensure that they have the proper authorization. And they will have to prepare their contingency plans. So for instance, we discussed about the DAR. For sure that if you have BVLOS operations and suddenly you have a dynamic airspace reconfiguration and you are far from home, you need to anticipate that kind of scenario and to, before the flight, to anticipate what could be the alternative, when, where to land, etc., etc. So this aspect of contingency to not say emergency are really important in the planification of the flight inside the use space because the operations may be subject to plenty of external events, a drone escaping this area, a DAR, etc., etc., and an inconspicuous aircraft incoming. So for the safety of the operation, that's something extremely important for the operators to be prepared. When the preparation will be performed, the operators will have to submit and obtain a flight authorization through the flight authorization service. They will have to select and use the proper UAS. Remember that we have 3 sets of performance requirements or operational constraints. The strategic one for the airspace designation and the definition of the airspace design and operation constraints. We have the set of performances applying to the USSPs, latencies, etc., etc., but also on the drone itself. So the operators will know what are the set of requirements and performances which are expected from the drone, and they will have to select the appropriate one. Along the flight, they will have to ensure, prior the flight, they will have to ensure that they are able to meet what we call the deviation threshold. So more or less to be able to stay, to anticipate that they will be able to stay inside the authorized volume. For instance, the wind conditions are sufficiently low to not be pushed and unduly pushed outside the authorized volume. And I repeat, if there are some areas where a specific authorization needs to be requested, the use space will not be there to complete this aspect, and that's the responsibility of operators to be sure that they have all the operations agreed and granted for them to operate in any place which could be restricted. And the USSPs and flight standardization will not be able to help the operator except to warn them that they have to get something. Along the flight execution, the responsibility of the operator will be to stay within the authorized flight. I forgot to say that prior or at takeoff, the operator needs to activate the flight, and that will start the delivery of the services and information and make this flight active for the other users. They will have then to safely conduct the flight within the authorized volume and taking attention to the operational constraint that it may be subject to. It must be, that's the particular part of the use space, must be able to answer to the dynamic changes to the ESS space. So it could be a DAR, as we discussed today. It could be temporary restriction because suddenly one piece of the airspace will be excluded. For instance, to cope with police operations or rescues or this kind of situation. So it not be a DAR, but just a portion of the airspace where the operations will not be longer allowed. A non-conformance, so if it triggers, if the service is required and there is a non-conformance, there is the responsibility of the operator to come back where it should be and to cope with any changes to the flight authorization, because that's really the mean to ensure that his operation, his drone will be deconflicted from the others. And maybe it was not obvious in the first or in the regulation on the first MCGM, but for sure he will have to deactivate the flight after landing. So to clearly confirm that the flight is end up and totally completed with the craft, the drone on ground. With regard to the situational awareness and the installation of the operator's installation, and then what is really important to ensure, and today we miss a bit of consideration with regard to the data aspects. You see that you may have dynamic information coming from various sources from the airspace, again, a DAR. So that's quite clear that the operators must ensure that he has the accessibility and the visibility of all this dynamic information. Why? Because we are expecting a timely reaction of the operators based on situation. If he's not able to get the information in time, he will miss. He will miss the DAR, he will miss the presence of inconspicuous aircraft, and that may represent an unsafe condition or safety issue. So the operator must ensure that the installation is able to maintain the situational awareness all along the flight. And here I I repeat a bit what is been expected by, explained by Jonas in the previous slide. So we have different ways to ensure that. The services can be provided either through an HMI or an API. So the big difference is that in frame of API, so it's simply digital information. The operator may continue to develop his own software based on that and to seek for complete integration of flight parameter of the drone, flight planning, etc., etc. This is a gray area in the regulation. Why? Because initially it has been thought as we will give an app to the operators and the information will go up to the eyes of the operator in order to help him to take decision on that. This intermediate way of dealing with the services, so purely digital, has not been thought. So we have kind of gray area in terms of regulation. But what we want to ensure is that the part of the software which will be developed by the operators, so what you have yellow here in the screen, will continue to meet, if it comes, the security, safety, and the performance requirement of the system. For instance, if you have very stringent latency in terms of display of information, we want to be sure that the part of the software developed by the operators themselves will not lead to an undue latency, which will prevent the safety of the operation. Same thing for the security. If the operators develop in software, we want to make it totally prone to cybersecurity attacks. And if we have some specific safety requirements, make sure that you have to do that information in that way at that moment. They are also complying with that. So what we are looking for the future is to complete this aspect. So you already have an AMC for that on in the set of AMC-GM. We may require in the future more information from the USSPs to the operators explaining how to integrate those requirements inside their own software. So in terms of performances, for instance, we have a latency budget. this latency budget has been consumed by the USSP. The remaining time for the latency will be allocated to the drones operators, for instance. The services may be used in a certain way and not the other. So in software, we call that a domain usage. So all these criteria and performance requirements allocated down to the operators will have to be specified by the USSP to make sure that the operators knows what we have to do, and as put in the picture, to limit the defects or the improper development of the installation. It's a bit complex, but just to say that some technical requirements may be fall down to the operators when they are developing their own piece of software for the integration. And that's it on my part.
Thank you very much, Stefan. There are questions obviously popping up in the Slido, but as we said, we will deal with them all in a block after the presentation of Vladimir Foltin, who is the project manager in the certification directorate. So he's a PCM, but he's also the project manager for general aviation, in particular for the electronic conspicuity implementation in the general aviation world, and part of the GA roadmap since already a long time, has been in the ATM expert and contributor to the general aviation roadmap of EASA. So the floor is yours.
Thank you very much, Maria. Hello, everyone. Good afternoon. I hope this presentation will be entertaining a little bit. We are GA. We are different. I've heard some complaints, seen some complaints about the GA in Slido, so I'll try to clarify those in the upcoming slides. So we will be talking about this single requirement from USpace set of regulation about manned aircraft, which is reflected in SERA 6005 Charlie. And that's to be inconspicuous, to be seen, to be visible to drone operators using USSPs, of course, as a middle players. And we were faced back in 2021 with a single regulatory requirement, but there was no clarity how to comply with that requirement. And that was our task. And our task was we were given 10 months to come up with an acceptable means of compliance. So as you can imagine, the diversity of users up there, ranging from paragliding community, paramotors, up until some light GA business operators operating in the same area, and also in the future eVTOLs and similar devices. So really wide range of area. And although the requirement is not applicable to militaries have to be considered and have been part of the development process. So that was our task, 10 months to develop AMCGM. We looked at the requirement from 3 perspectives. Before drafting the text, we had to agree on the main principles we will be using for drafting that acceptable means of compliance. So first perspective, obviously, was perspective of aircraft operator, because the standardized European rules of the air said the requirement operator of the aircraft, you have to be continuously electronically conspicuous to USpace service provider. So from perspective of operators, and there are many and diverse users, it was the affordability of the devices, technical means to achieve the compliance with this requirement. And when they were talking affordability, there were different perspectives of affordability within that spectrum of users. So what was affordable to one group was too expensive or not possible technically to implement for the other group. So whenever we talk affordable devices, we have to take it from the perspective of the user group, considering the most vulnerable, because those will not need to comply with the requirements as well. We couldn't rely on any future ACAS 12, whatever developments. We had to deal with technology that is available now, be it aviation, but we were open-minded in terms of looking at the technologies that are well established and also used outside of aviation segment. We have clarified with users that single device policy is sufficient as a basic requirement. Of course, we may see some users for their own benefit, they will come up with devices complying and this transmitting on several links. So that's possible, that's not rejected, but the single device policy was clarified. And of course, in case the device needs to be installed, especially for EASA, we had to make rules possible so that they can install into the aircraft fairly easily. So there is no burdensome process, so they can comply with the requirements to keep affordability at the top of our agenda. Last but not least, but I underline in this community, this is the requirement there. The group said, okay, we can comply with these requirements, but as we identified in the strategy for airborne collision risk, we want to benefit as airspace users for our own safety so we can avoid mid-air collisions with other manned aircraft. So there was a desire of this community to develop solutions that will save lives of manned community even outside U-Space. And that was a must requirement from their perspective, and it was acknowledged, obviously, on our side. Moving forward, the second player in the group, USSPs, what their thoughts were. Mostly, okay, we just need minimum position information available. We don't need fancy stuff, minimum layer, so that we can make sure that we do not collide with manned aircraft when they are operating in the vicinity of drone operations. We will ensure all the rest. They, however, called for affordable infrastructure. Entities, small operators, all of these would need to be paid by the customers of drone operators. So therefore, there was a strong desire to have affordable infrastructure to be used. Not any costly, no big investments, lean, suitable for the means, affordable infrastructure. Ideally, if it can be compatible with the needs of UAS, if it can be reused for additional functionalities that are required for their operations. And of course, meeting the performance requirements and objectives of U-Space regulation. And then finally, we had to think what will be the meeting point between the two, aircraft operator and USSP. So what are the resources we could use to transmit this information from the aircraft to the ground, because the drone operators will be most of the time on the ground. And we obviously considered existing international standards, and here I underline again aviation and non-aviation. We confirmed that this needs to be applicable in pan-European scale. The reason being that we cannot afford, from safety perspective, that manned aviation, which is in uncontrolled airspace, and nowadays you can imagine within Schengen you can fly across the border fairly easily. You will be pushed as operator of your aircraft due to weather into uncontrolled airspace of another state. And guess what? There will be U-Space implemented. Can you imagine your device is not compatible with the U-Space of the other state? We could not afford this complacency, so we have to confirm that whatever the device you are using and it's compatible with U-Space requirements, it will be compatible with each and every U-Space everywhere in Europe. We concluded that we need to use ITU regulated spectrum. Of course, there will be no cable between the plane and ground, so radio spectrum. But I note here, and I point out, it's a ITU regulated spectrum, not necessarily certified, and not necessarily spectrum that is protected, aviation protected spectrum. There are two reasons. First of all, we have saturation on 1090 in some places in Europe. So we have to be very mindful to put any additional transmissions on those channels. And secondly, as you can imagine, many of the GA community participants, they are not necessarily having radio license. They are not necessarily having a license to operate devices on certified spectrum. And paying the annual cost for operating a transponder radio, it's a burden, it's an unnecessary cost for them. So we had to offer these users also opportunity to use some additional spectrums for this use. Machine readable, open standards, non-proprietary, and saturation of frequency I've mentioned. So these are just obvious things. Last but not least, all of these need to be suitable for urban and low-level environment. And that's one of the reasons we could not enlist Mode S basic surveillance as one of the means of compliance, as you will see later. So because Mode S basic surveillance requires interrogations, and it's very difficult to ensure interrogation at very low level in urban environment, for example. So that's about the starting. This was a starting discussion, a lot of brainstorming, a lot of discussion. Then we came up with the idea. We looked, of course, in the international standard, and there was one very good out there in aviation, ADS-B out. All of us know very well. We were looking at it and said, oh, that would be great to have something like this, but it's a little bit heavy. It requires, there is a parameter to indicate that you are landed, so it requires sensor. It also has a pressure altitude, which in this specific case, we concluded is maybe not necessary. And also it would induce additional complexity into the device and thus increase the price, which would be against the affordability. So what we said, and also all the issues with pressure sensors, you know, temperatures in the cities, you know, you have different temperature and the pressure indicates up and down. So what we said, okay, we will we will discount this kind of unnecessary parameters, and we will try to develop something new. And this is where I will be linking my words with what Stefan was saying in the beginning. We were calling for the industry to come up with standards. Please come up, because we can consider and we can implement it. This was one of the very few and unique opportunities for EASA to come forward towards the industry and said, okay, we think if we will have something like that, it could work. So we came proactively to solve this problem. Because there was two hands full of manufacturers, various devices, various channels, various resources used. So we came up with ADSL, which means automated dependent surveillance. So we are basing e-conspicuity on ADS concept, but with this little L at the end, which means light. So it's lighter than ADS-B out. So it's any unnecessary parameters were removed. In general, the concept is that we have a position report based on GNSS parameters only. We have optional pilot's input. So, for example, pilots will be able to indicate any state of emergency, as we know them from ICAO. And that is, of course, obvious configuration to indicate I'm a glider, I'm a paraglider. Very quickly, you indicate who you are, and basically very simple setup once per year or whatever. This all fused creates the message. So we generate a message, and that message is transmitted over the transmission layer to the ground. I will talk about it on the next slide. We also designed the specification so that it could support future applications, as I've mentioned earlier. So what are the means of transmission proposed? And again, keeping the affordability and interoperability at the center. So we wanted to have as little means as possible, but still satisfying full range of users and relying on the standards and specifications. So this is the outcome. That's the starting point where we were at the time we defined. Before that, there was ADS-B out. I do not need to talk too much about this one. Advantage of ADSL over ADS-B out is that we have a unique identifier. So there is a specific email address, which is very good for data fusion in that sense. But ADS-B out is fully reliable source. In Europe 1090, we also enlist UAT technology in AMC, however, on condition that it will be implemented for this purpose by all member states. Remember the pan-European applicability. That's not the case. So technically speaking, UAT is feasible, but unfortunately requires further steps which are outside of EASA competence. So today we can rely on 1090 ADS-B out certified solutions. If you are like IFR flights are required to have this, so you are perfectly compatible with USpace. I think that's good. So far, so good. Then we had to look at the SRD 860 spectrum, which reads short-range devices. I think there are many of those short-range devices probably in this room as well. This could be garage door openers, your TV stuff. Don't be scared. There are 3 frequencies in this frequency band, regulated frequency band at European scale, that are suitable for the use case and that are used today by various devices for traffic awareness and they have been implemented for quite some years by the community to address the collision risk. So what we have done and what we've said, if you are ADSL compatible, so you will be compliant with specification, you will be transmitting on SRD frequency band, you will be fine. This means that existing devices could be easily converted by software update to be compatible with USpace. We have close to 80,000 plus devices operating in Europe on this spectrum. So that's immediately we have all ADSB community in the group. We have all ADSL on 860 in the group. So no need to wait for mandates implementation for decades. Moving forward, and this is one of the largest novelties. When we were developing ADSL, we have had always mobile telephony at the back of our mind. We knew that there is a great potential of this technology, but there was a lot of uncertainties. I'll talk about them later. But we concluded eventually, after all those evaluations, that if you are ADSL compliant and you will be transmitting in a standardized way using mobile network operators services, you will be compatible with USpace. So you'll be conspicuous in USpace, and still talking about manned aviation here. This is for the most vulnerable groups. Many paragliders use many devices, but there is a large amount of them. They are not using devices like mobile phones, and they always fly with one for their own personal security. They always have a mobile phone with them, because if they land out, how they connect people, how the car finds them. So they want to have a mobile phone. So it's not a burden for them to have an app and run a 40, 50 euro subscription per year and to be conspicuous, not only in USpace, but maybe also beyond. So that's about this. What's new is that first time aviation regulator offers solutions, safety-related solutions, not safety critical, safety-related. We talk here about remain well clear situation or kind of separation. We use non-specific aviation spectrums, and we are using non-aviation specification to transmit message. So this is this very first time we are offering this solution. We call it nominal solution. This is a baseline. This is the foundation of the future connectivities. For the SRD spectrum, there is one deliverable already out there as of December. The community, with the great help of community, some of them are in the room, we have developed the specification how to transmit ADSL over SRD 860, called ADSL for SRD 60. It's on the EASA website, and it's now being implemented. There are some manufacturers in the room who have that already implemented in their devices. We expect all manufacturers that are operational on the market today in the spectrum to convert to ADSL. So that we have commitment verbal from them that they will convert the devices, they will be ADSL compatible. So all FLARMs will be ADSL compatible. They will be open, visible to everyone, and all other devices, I will not name them. Just to highlight how difficult process this was, these are the stakeholders who are supporting to large or small extent. Those who are in rectangles there, those were the pen holders, and I would like to pay special credit to those three entities, Open Glider Network, FLAM, and Skytrax, for spending time, putting the efforts and putting the specification forward and agreeing all manufacturers on one single way of transmitting ADSL messages for USpace purposes. So what about mobile telephony? A lot of questions, it's becoming buzzwords nowadays. So back in 2021, if we wanted to include it in our proposal, we had to have a proof that it makes sense. So we've conducted and commissioned a feasibility study. Basically, the question was this, but on 10 pages, as you can imagine. The answer to the question, no surprise, you get, yes, it's possible, but, and there were 3 buts at the time, and I will just summarize them because this is history. So first of all, at that point in time, there was no legal certainty for use of aerial mobile network in the air. So aerial mobile was a gray zone. It was not forbidden. It was forbidden in some contracts, but not regulatory provision to forbid it. But it was not allowed. But for Europe to put it in EU regulation, especially aviation safety regulation, we need to have it allowed. So we need clarity. Secondly, of course, it's not allowed. There are no frequencies coordinated properly. There are no standards how to do it. And guess what? We need roaming. Roaming always needs and refers to standardized services and standardized frequencies. So we need to resolve these two in order to have a roaming, this reflected in roaming agreements. So that was work to be done at the time. And of course, there was a big question whether we can use dedicated devices or smartphones. Can we use the existing networks for manned aviation, not drones, manned aviation, or can we use smartphones? And of course, our desire was that we could use the smartphones. So what's the outcome? Thanks to work at the CEPT, which is the Electronic Communication Committee of the Telecommunication Regulators of Europe, and that's not EU, it's wider Europe, they have agreed with the coordinated decision, which specify conditions under which mobile telephony could be used in the air today. Of course, there is no enforcement for EU on this one. It's the telecom regulators who need to take it from this point further. So what is our timeline for e-conspicuity of manned aviation, which is flying as uncontrolled traffic in USPay? So we are about to put together an expert group. We will be calling on expertise of GUTMA, GSMA. They have a joint initiative called ACGA, Aerial Connectivity Joint Activity. Thank you. And they have a right expertise in the field. They are targeting C2 link for drones, of course, but they have an in-eye. We have been in touch with them for quite some time, also on this e-conspicuity. So they will help us to put together right specification for ADSL over the mobile telephony. We will be reviewing and relying solely on existing standards and existing work. We will be not developing things and trying to research for years. We will put together something lean and mean and very simple for complying with this requirement. The aim is to create as a specification for ADSL for mobile. Ideally, if we can combine or update the existing document which is out there to merge the information to clearly specify in one document both ADSL over mobile telephony and ADSL over SRDS60. That's our ambition, that to be seen. And we should hopefully have ADSL for mobile later this year available on the EASA website. What does it mean? As soon as we publish it, and we will publish it only when we are confident that the community has seen, has reviewed, and USSPs have understood the consequences. As soon as we publish it, 6 months after publication period, each and every use space in Europe would need to support mobile telephony for e-conspicuity purposes. Not talking drones, but of course, this unlocks the potential for use of mobile networks for drones. As you know, mobile telecommunication networks are everywhere in Europe. This is the outline, how it looks like today. It's actually 1.5 months old picture. This is industry source, but it indicates where area mobile services are already commercialized. That's the green spots. Yellow states, this is in advanced state of preparation, and mobile telephony will be offered for aerial use in those countries pretty soon. Gray countries, we have no information, but there may be progressing as well there. Mobile telecommunication network, new area, new experience. They are not behaving all the time all the same, as you know. It's like breathing organism, living organism. In the morning they could be performed very well because all of us are working and connected to fixed networks, but as soon as there is a concert, the mobile networks could be under pressure. So all of the information would need to be considered for using the mobile SIM network, but there is a great potential, not for only for manned aviation. We hope to benefit from that, but also for the drones. So in summary, we have ADS-B out certified as a solution, as one mean of compliance. The second mean is ADSL over SRDS60. The work is finalized and now being implemented by the industry. And there is still some work to be completed on mobile telephony. We are working on the specification. It will be relying on existing things as much as possible, but it will also need some implementation in the member states so that it is available in new space as space is established by the member states. I would like to conclude my presentation by one or two sentences. there is a lot of criticism, or maybe there is a lot of fear from GA community about drones, and they are pushing hard. But bear in mind, all of you guys, GA community, they have done their piece of work. They are ready. They have unlocked the potential. This is all work by the GA. They are open-minded and they are embracing ADSL. Everywhere I come, everybody is talking ADSL in GA. Everybody is interested because they see far more potential for GA on safety in ADSL. So please respect the GA community for this work and work with us and with them on implementation. We are looking forward to embrace on this journey. Thank you very much.
Thank you very much, Vladimir, for the presentation and the nice words at the end. So again, a lot of questions popping up, but still we have a few slides by Stefan on the last part of this block this afternoon, so data quality and continuity of services. And then we go to the so much style workshop, question and answers, and also Mike for those here present. Thank you very much, Stefan. Back to you.
Yes, so I promise to be quick because I have only 2 slides, so it should be fast. And after that, we'll have the questions. So there is something that you may have seen in the MCGM, which are repeatedly created or implemented, integrated in MCGM, about data quality and continuity of service. So there are transverse responsibilities which applies to all the stakeholders, starting from the SIS down to the operators. Very first thing, maybe quite obvious, but about data quality and integrity, the quality of the data, the completeness of the data must be ensured all along the processes, starting from the SIS. It delivers a set of data which has been already ensured to be at a good level of quality, complete, etc. And it's processed all along the flow down to the operators. So then the information arrives to the operators. We must be ensured that it's not been altered or corrupted along the way. So at each stage or layer of processing, could be at the SIS itself, could be the single SIS, could be the USSPs, could be the interfaces between all the stakeholders down to the operators, we must ensure the integrity of the data and its completeness. So no alteration, no corruption. That's a generic responsibility. And if there are some issues, they must be reported. If the, whatever, I don't know, the geo-awareness does not provide the proper boundaries of the use-space space, if there is an information which obviously is altered, if the quality is not there, if the data is frozen, etc., etc., and even between USSPs, we need to implement a way to report the quality issues. So to say to the aeronautical information service, your geozone is not the right one. That the information has been corrupted between the USSP and the operators. So we must establish this kind of mechanism. Could be digital, could be by other means. There are some provision, for instance, in Article 5. And that needs to be set up to make sure that any defect or deviation from quality will be reported. Sorry for the title, there is a mistake. It's about continuity of services. The interfaces and provisions of the services should be continuously monitored. So again, between all the actors. Why? Because as soon as you start to be disconnected from the use space, from the infrastructure, you have safety issues. The safety is ensured by the provision of service, the real-time information that are acquired and transmitted between the stakeholders, from the air traffic management with the traffic information, conspicuity, as we have said, between USSPs, etc., etc. So if one leg of the system does not work properly, it's the complete system which may become unsafe. So that's the reason why all the degradation of service, and in particular the loss of connectivity, should not remain unnoticed. Because if you are disconnected from use space, if you are out of use space, you continue to operate with a service which is degraded, clearly you are taking a risk for safety. If the operator is not properly connected, he will not be made aware of a DAR. He will not be made aware of inconspicuous traffic that he must avoid. If the USSP is not connected to the sys or the single sys, they will not receive all the other information. For instance, a dynamic restriction. If, reversely, the ATM is not aware that he's disconnected from the USSPs, he may trigger DAR, but without any effect. So all the system will be in danger if we are not monitoring and checking the continuous life of the system and to trigger alerts if there is a disconnection of a degradation of service. So that's the thing you will see all along the MCs to order this continuity or to notify this discontinuity or degradation of service. So that's the only thing I wanted to pass. I may have provided another slide just to say that for all the actors, they have to provide their operationals, manuals, the procedures, etc. But I think it's obvious. All the interfaces must need to be specified and properly applied, integrated, etc. So that's it for this part. In terms of technical content, that closes the discussion of today. And we are going to discuss about your questions.
Thank you very much, Stefan. And now we are going to the so much awaited question and answer session. But before that, because we have not done that since the very beginning of the day, I think all the speakers, so Elina, David, so we have also Alberto, we have Antoine, we have Jonas, and we have Vladimir, but in particular Stefan for the huge amount of work done in integrating everything, in providing the slides, in ensuring the integration. I think they all deserve a very big applause, isn't it? Vasilis, I keep forgetting you. You also deserve a big applause. A big applause for Vasilis. And Jonas, yes. So now we go to the question and answer. No, Vladimir, where are you going?
To drink.
You have half of the questions for you.
So do we start from the beginning of this morning? Or?
I suggest we tackle the ones probably first from this afternoon session. So the ones for USSPs, UIS operators, and the one for ADSL. And then we go back again to the answer questions, and we try to tackle as much as possible. And then we go to the mic. We're saying, where are you going? Good.
Yes. Radio check with Jonas. Are you here? Because I think some will go to you.
Yeah. So
yes,
here we go.
Here.
Back to yellow profile. For you, Jonas. Maybe you read the question.
Sure. So these are the ones related to the USSPs. So I start from the first one. Regarding SWIM yellow profile, a lot of ATS systems are not supporting it. Should be mandated to exchange data with ATM when it is not supported by one of the legs?
That's a good question. Of course, it is, it is the requirement. So I would see it as an accelerator of the adoption of yellow profile in Europe, also for ATMs. But for these transactions, we need also the ATS side needs to implement yellow profile technical infrastructure if it's not already done so. But as I said, many of those pieces are already in place by anybody who is communicated. So you just need to make sure you tick all the boxes. This is not rocket science, so not something to be scared of.
If I may complement here, SWIM Yellow Profile is part of Common Project 1. So it's one of the common projects, which is obviously, I don't know all the exact dates, but by 2025, I think all the ATS units we need to be SWIM Yellow Profile compatible. So it will obviously anticipate. We are still in 2023, but I think this will not take that long that they will need to. unless we are talking really about very remote flight information services and these sort of ATS units, which are not really connected to the ATN network, but the majority of them, we need to be SWIN yellow profile compliance.
Thank you. So I'll go to the next one. What kind of alerts are supposed to be exchanged using SWIM yellow profile? It should be taken into account that SWIM yellow profile is not suitable for real-time critical information exchanges.
In the assessment that we made, just briefly, we have assessed that the yellow profile is indeed suitable for the type of delays and latencies we are looking at in the current version of the U-Space and probably future versions of the U-Space airspace services also. And it's the technical infrastructure, the protocols we are using for connecting. So any alert between ATSP, USSP, and also as much as, but those are the requirements there. The alerts need to be carried on the technical infrastructure.
And I complete. Thank you, Jonas, for this clarification. So indeed, that's something we'll have to evaluate, but we trust that it's good enough to support this kind of information. And with regard to the alerts, I recommend to have a look on the MCs and GM, which are related to this kind of information, and especially a GM3 to Article 7.2. You have a list of information that we called, which required immediate awareness, starting with degradation of service, change in the configuration of the U-Space airspace, so dynamic airspace restriction or reconfiguration, change in the flight authorization, new in emergency, etc. You have a list of things that need to be considered with regard to this alerting scheme, this part of the MCGM today.
Okay, I keep reading. So this is regarding the UAS connection to USSP. Is it not possible through an external remote ID device on board the UAS so that the remote ID is sent to the USSP?
This is a question that we could keep for tomorrow morning with Amanda from FOCA. But the answer is, if it's built in and it works and the interface is the one we want, yes, fine. Otherwise, we need to have a kind of hookup device or an add-on which will transmit the parameters. But there is nothing preventing that the onboard mechanism, transmitting mechanism, wouldn't be notification. Yeah. So it's not mandatory to have a remote ID. Excuse me, an external remote ID device, yes.
Okay, so the next one is, how should contingency procedures be shared? There is no real specification, and is a non-standardized document good enough?
If I start, Stefan, you can continue if you want. Yes, you're correct. There's no real specifications for exactly how to do the contingency procedure. So, but this follows normal aviation methodology with normal, non-normal, and emergency conditions. So just need to agree on what it is. And I think we will see experience sharing amongst the different countries and use-based implementations of what is good practice. But over to you, Stefan.
No, nothing to add. Thank you, Jonas.
Thank you. So next one is, it is suggested that in a centralized architecture, it could be the CISP, the one converting main traffic from asterisk to a USSP readable format. How would it work in a distributed architecture? Is it the USSP or ANSP's responsibility? And the same would apply to network ID data.
So if I take that one, I don't think there's a clear answer for that one. It's not exactly specified how the traffic information from ATSPs, in what format it should be transmitted. There's left open to different member states to specify, and again, urge collaboration on this one. My guesstimate on this one is because ATSPs are using Asterix as one of the industry standards, that Asterix do either USSPs are receiving directly Asterix formats, or then there is a conversion service somewhere along the line that transmits it to or translates it without loss and without altering the information to another format. I think it's a it is something, again, coming back, I think we will see best practices emerge on how this is being done. If a CIS entity is taking the translation burden on itself, I think we will hear about it in this ecosystem and learn about the good and the bad with that approach.
Anything to complement here?
Not really. Well, they were coming to my mind that if I would say if there is no obviously translation of the format, so it's something that at the moment is not really specified, but anyway, the USSPs needs to be able to read and translate and merge with their own data. So there's no other way around to provide the traffic information to the UIS operator. I'm just thinking. So obviously these are data, but I'm just thinking, okay, we are in the case of dark where this will happen because in uncontrolled aerospace you will not have to have this information in a static format. So obviously we need to specify in which cases this will be needed and how to do it.
Okay, then the next one is more of a comment. So it says one should not use network remote ID when referring to the data associated with the network identification service. Network remote ID is just one of the means. Other technologies such as direct connection with GCS can also be used.
I take this one, Jonas. So this is exactly right. And we try to make this difference. So network information service is the capability to acquire information coming from the drone, period. Then indeed, we have different ways to acquire information, either by an external device or internal information. And this is right that if there is direct connection that works, you may have Bluetooth or Wi-Fi. So provided you are able to transmit the parameters which are expected by the regulation in a standardized manner as per the standard we are proposing and with a sufficient level of performance. For instance, forget about Bluetooth when you do VLOS. There is nothing preventing a VLOS operation that could work. So we are not prescribing or dogmatic in that way. We need to have the set of information per the regulation. And after that, if it's performant enough with a good level of quality and accuracy, that will be acceptable. I hope it relieves the concern.
Next one is in Holland, UAV operators get one operator ID, which must be used on all his UAV. How can USSPs make a difference between his UAV because he will use then the same ID?
I recommend to save this one for tomorrow's session on network remote ID.
Yes, Amanda, take it. You may provide an answer tomorrow.
And I go to the last one. And the last one is how the UAS in new space must act on rogue drones in the same new space.
So here we need to make a difference between cooperative rogue or non-cooperative rogue. For the cooperative rogue, maybe having their remote ID or these kind of things that may be detected by the USSPs and an alert then must be sent because they know them, they see them. For all the rest, unfortunately, we don't have technical solutions. I know that some implementation, for instance, in Germany, we have been told that even non-cooperative drones could be able to be detected, and then an alert can be transmitted to the operators. But basically, I see difficult to ensure that the operators will be made aware of any rogue drone which will not be not cooperative, but as today for any stealth drones flying in the airspace. Unfortunately, we don't have a technical solution there.
I mean, this is very much linked to the Contra UAS action plan and the implementation. US space and per regulation is safety, okay, security as well. but is a solution that is mainly answering a safety concern. Here, when we are about those drones which are not cooperative because they don't want, the ones that they don't now, obviously, is something we need to tackle, but the ones that they don't want, this needs to be implemented and along with the counter-UAS measures that can support the implementation of U.S.-based, but it's obviously not, let's say, it's not part of the regulation. It's a totally different set of activities and actions and authorities and policies. So I would say this is to be done in a different workshop. There were questions in the slide, though. Another question about counter-UAS, why it's not part of the solution? Well, it's not the problem. As I said, what problems are we trying to resolve with U.S.-based? It's not part of the problems that were to be solved with U.S.-based. And it goes, obviously, in many cases, outside even what we can regulate here. I think this is all for the questions for Jonas. Okay.
Carsten Kretschmann, DFS. Just a brief comment to this question. As in the drone detection business, there are a lot of stakeholders, and there must be a way to exchange information on rogue detected drones. And the vision could be that the common information service provider could be one of the sources to exchange those drone or the information about those drones as well, so that it's available. It's just the vision. If still technically feasible, it could be when we discuss about traffic information service on we identify virtual sources and products. If there is a possibility for sure to choose more information on destination to operators, whether the enhance set of information, higher is the safety, which takes so it could be possible if it's technically achievable.
Now we take 50 questions.
One more remark than question, I guess.
Here we go. Super good.
Yes, but I was the one making a remark on network remote ID being replaced by, or as a replacement for network identification service. On Jonas's slides, I saw that in the list of all the services, network identification service was actually always replaced by network remote ID.
Okay.
Did that have a specific reason, or is it something that should simply be rectified? Is a question to Jonas. Jonas, would you like to answer?
I could not hear the question. If you could please repeat it.
It seems that you have identified network remote ID instead of network information service. Yes.
I don't know. The sound went very bad. Could you please?
I propose to take the question and we look back on the slides and discuss the question.
So, Jonas, maybe from here you listen better in the WebEx than with the mics who are not connected to the WebEx. So the question.
I hear now. Yes.
Okay.
This is perfect.
Okay, so that's always the issue. The question is, it was previously displayed. The question is, in the slides, you are replace the network identification service by the network ID, which is obviously following a specific standard. Is down on purpose, is down. So if you could explain if there could be other solutions to provide network identification service as far as you respect the requirements.
Yes, so thank you. Now I got the question. So the slide that I showed you is how is the information exchange. What standard is that following? And in the AMC and GM, we can discuss it more tomorrow, but the 3411 is mentioned as this is the way to exchange network identification information using. And that's the picture just tries to reflect that.
So it's a means of compliance, and which is referring to a standard, and obviously alternative means we need to demonstrate that they are equally safe, and obviously doesn't jeopardize interoperability in this particular case. But I think we can have the subsequent discussion tomorrow.
Yes, and I'm just bringing it up. So it is indeed AMC4 to Article 8.1 on network identification. We can come back tomorrow, but it says simply that USSP should use the interface defined in Annex 4 to ASTM 3411 standard specification for remote ID and tracking. So that's the interface that's coming from the AMC. But more on that tomorrow.
Okay, and now we go to the huge amount of questions that we have on ADSL. So I think I pass the mic to you, Vladimir.
I'm not sure the first one is for me. Have public ADSB and MLAT providers like FlightRadar24, FlightAware, or AirNav have been analyzed against the traffic information performance requirements? Would this also be suitable? I'm not aware they have been analyzed, but certainly the information used in U-Space from manned aircraft would need to be analyzed for the performance requirements, and also the performance would need to be known so that drone operators would know that what are their safety margins to take into account the manned aviation. But I can mention here that our AMCGM opens the door for third parties to provide inputs to USSPs for traffic information. So to federate more sources of information, to have more redundancies, and so to provide a better service to drone operators. That's on the first one. The second one, given ADSL is on an unprotected frequency band, how will operators write a safety case using non-protected data? This has parallel with 5G and airline operators in the USA. Yes, the SRDA 60 is not protected, but it is regulated spectrum, and there are quite stringent requirements how to transmit. And if someone wants to disturb a channel, 1090 is easy to disturb too. So if there is a activity that is willing, someone wants to really interfere, they can interfere with any spectrum, including GNSS spectrum, as we know. So, and this is for USSPs, not drone operators. So these kind of cases, we hope this will be really extreme, will need to be considered in the contingencies of UAS operations. So contingency procedures of US operators would need to account for this kind of situation. So there would need to be established process how to react if a certain service becomes unavailable or degraded. That on that one. Question from Doe Lambers from DFS. With the range of SUR technologies is with different performance characteristics, each USSP providing its own traffic information service, potentially using a different sort of sensors and data fusion, there won't be a common traffic situation picture in U-Space. How are the safety risks addressed? That's a very good question here. And it allows me to distinguish between the two things. In the U-Space, we do not need to have a common traffic picture. The requirement is to have that each and every drone operator has a traffic picture in the vicinity of his drone. So any relevant traffic to your drone needs to be available to drone operator. He doesn't need to have a full picture in all U-Space. Try to look at it also from the perspective of a pilot of aircraft. You need to see what you need to see, and you don't need to see everything because otherwise you are overloaded. So there will be ways how to do data fusion and also data selection for each and every drone operator for the performed flight, which will be accepted and set in advance. So I'm not surprised at this question. It's typical because we are looking at the airspace like from the traditional way. We are looking at the full, complete overview of the airspace situation in a given airspace. Here we are talking about the traffic information relevant to drone operator.
And I would like to complete with regard to the performance, etc. That's something which may also come from the airspace risk assessment in terms of latency, for instance. We need to make sure that all the people all the actors or users of the airspace will have the information at the same time, that no data will be audited. The same for the accuracy, so why you have performance requirement on the drones to ensure certain level of accuracy of the information, etc. So the technical consistency should be ensured by two means. First, the airspace risk assessment. Second, the standards again. Because if we are applying the same standards with the same level of performances already built in for the standard, for sure, we ensure this consistency.
Very much. Just one more with regard to the limitation of the availability of the traffic information regarding the vicinity of specific operations, there I think further discussion is required as to what the operators will require. Because I can understand there is something looked at from, let's say, user speaker perspective, etc., but also from an operator perspective, we need to look at what is the scope of the data that we need to see. Also, to be able to work more strategically, for example, because when that vicinity is too small, then it's more difficult to work strategically.
That's a good question, and we will address the concept of what is vicinity tomorrow. And you are absolutely right. There may be obviously different ways of doing, and yeah, you could still even ask for more if that is for your operation. So it's a question that will be addressed during the traffic information tomorrow in the definition of the service by Kai.
In terms of time, in 4 dimensions.
Yeah, absolutely.
Yeah,
that's
absolutely.
That will be presented in that way tomorrow morning. Yes, we know the slide, so we can know that. Yeah. Yes.
Power from the Austrian Association. Valentin, I think you see the question coming. It's about VDSL for mobile and the network coverage, the satellite coverage. We know that not everywhere in Europe, in every country, we have the same quality of network coverage, and you have to take this into account. Not only when writing the standard and finishing the standard, but also going back to the morning today, making the risk assessment in the member state. So is there any thought of EASA to write into the AUC for the risk assessment of the member state a requirement to consider the quality of the cellular network in a dedicated place for use space? And if it's not sufficient, to take countermeasures like requiring a short-range device or anything else. So they have to think before they make a use case, if the mobile network there is sufficient for use case with ADSL for mobiles. And the next question goes to the other way. For short-range devices, and it's up there also the question, you need some ground infrastructure. There is currently liberal free infrastructure, but it is not maintained to aeronautical standards. So in this case, also the member state dedicating a use space has to take into account, is there enough quality of the data from this network? So in both cases, it should be part of the risk assessment from the use space officially in the AMCO.
Very good question, thank you. And on mobile networks, we need to distinguish between the two use cases. Of course, the drone community is interested mostly in sea tooling and ground risk determination based on information from mobile network operators, and that's a different case, and I will not speak about that. When it comes to e-conspicuity, the way how general aviation or manned aviation operates in a given airspace is not big unknown. It's pretty predictable. It's not fully predictable, but it's pretty predictable. And of course, the performance of the network in a given time, in a given place, would need to be assessed against the traditional patterns of GA in a given airspace. And since GA flies usually a little bit higher, there is typically, and there won't be a big issue with the direct visibility of the mobile network infrastructure, because there is plenty of infrastructure available, but there could be gaps. How the gaps would be resolved could be in many ways. One way could be if there is a hole in a use space where there is typically not enough mobile network signal, but it's small enough, and it's certain that from inside there will be no traffic taking off, and you have very good coverage around, so you know that there is no one coming in. You can assume in the airspace risk assessment that despite this gap, you may have drone operations in the vicinity of this gap. But when there will be downgraded network operation or network performance, mobile network performance, then of course there is a possibility for adapting the route of the drone in a way to be in the area where the performance of the network is good enough, or potentially delay the network, so delay the flight until, if possible, until the time where the network performance is sufficient enough. Normally, the network performance for this should be sufficient in general, but there could be things where there is a lot of people in one place, and of course, then the network performance may go down, and this would need to be taken into account. Yes, and there is also an interesting consideration that you may. It's not absolutely impossible to have in the future sensor in the air. So that's this is happening already on SRD-860. That's your second question. There are devices now out there which are acting as a receiver in the air. So the GA is maybe a sensor in the air for you. For example, if you combine the app, very famous app the pilots are using, and that app is connected to the SRD-860 device, which is usual setup today for many pilots, you are benefiting, not only benefiting from both, but you are also collecting the information in your vicinity from both sensors and transmitting it to the ground using mobile networks or SRD channels. So we are probably will be seeing some kind of network solutions being implemented by member states. When it comes to certified, not certified, developed in accordance with aviation standard, developed in accordance with telecommunication standard, we may learn from these first implementations that actual performance of this system is very similar, and that will be a good learning point, but that's to be confirmed, I will underline.
But if I may also to complement Vladimir, still this is also needs to be assessed as a part of the aerospace risk assessment. So if the solution of mobile network when it's there available and is suitable, we need to be assessed as a part of the aerospace risk assessment and make it then, because you are right, there may be a thing, then we need to have alternative ways of acquiring this information.
Okay, the next. Yeah, I take the next one, please.
Yes, sure. So this is always regarding eConspicuity. Is there a requirement for USSP to receive data from manned aviation from all the 3 identified devices, ADS-B, ADSL, and mobile? What if a member state decides that manned aircraft should only be conspicuous through one single device?
So with the decision of the member state, potentially they could. I don't know. But anyway, it does not change the approach that we have for USSP. The answer is yes, they have to address the 3 identified devices. Why? Because we wanted to foster a seamless approach for the manned aviation, and as said by Vladimir, a single device policy. So any aircraft already equipped with ADS-B out, for instance, should not be mandated to add another device, etc., etc. So there is a lot of flexibility for the manned aviation. There is none for the USSP. So the manned aviation could be equipped with ADS-B out, ADSL, mobile, etc. But the USSP need to be prepared to acquire the 3 kind of sources. That's the idea. And then when the manned aviation transit from one use space to the other, is totally transparent for him. If you want to complete, yeah. So that's it. Yes, USSP will have to acquire the 3 sources.
So the last one for eConspicuity, is the loss erroneous eConspicuity system classification of failure condition available?
It's the top one. I'm reading the second. Sorry, is the loss of inconspicuous. Is it the second one from Raquel we're talking about?
No, the one in light blue.
Okay.
The first one.
Is the loss errors inconspicuous system classification of the failure condition? Okay, so the pilots, they know they have to be conspicuous, GA pilots, and the devices, the minimum requirement for them will be that they will be subject to product rules of the European Union. So if they will be sold on the purpose to be IDSL and also serving use space, they would need to be providing pilots with some feedback necessary to understand if the device is operating properly. That's the feedback to pilots. Of course, when the device is not transmitting and things will not work well, that's still possible. That's a possibility, but the risk then is for the pilot. What we have seen already, and I've mentioned it in my previous intervention, is that pilots are already trying to implement multi-link devices for their own benefit and for their own reasons. This will also provide additional redundancy in case one of the devices is becoming weaker in operation or maybe not having the ideal performance. So that's about this, but it's not defined as a failure condition. Of course, if the device is required, you are in the breach of law if you intentionally know that your device is not operational.
So let's go back to other questions that were still unanswered, probably. And if there are specific questions for UIS operators related to the ARC, probably we can take them because they were addressed by the presentation of Stefan. And
there were a couple regarding operators, so I can.
Okay. And then we can then go back to the mic if you still have questions. If not, we go up to. We can continue until 5:15, and then we will start closing the conference of today. But we continue tomorrow. So let's go. Okay.
These are regarding the operator. So the first one is all the US flight authorization data should be shared with other USSPs or only the data required to support the confliction, for example, volume and priority. If we share all data, will this not be a problem in terms of privacy, business operation, or even GDPR?
So the idea is not to provide all the informations, but the one supporting the deconfliction. So which is more or less the volume or the trajectory and the time. So we need to ensure separation in space and time. So that's the thing we need to exchange to make sure that the operations will be deconflicted. After that, we have standards, which could be cool or not, but that's the idea. Not any information are necessary to ensure the matter, which is deconfliction. Yes.
Okay, and the other one is asking if the USSP or the CISP have an issue, how should the drone operator act?
That's a good question. Certainly as a contingency, because he's not in a position to continually safely do operations. So he should be prepared for that and act per the procedure already planned. So not in a rush, not in emergency, not in a panic mode, but in a planned way through a contingency procedure.
Okay. Yeah, I'll take the last question. How about this responsibilities in VLOS flying? It's very clear that the drone pilot has the responsibility if something happens. But if you have a case that there is the use space and VLOS mission and there is the accident happening, so what are the responsibilities of the use space and this? Is there less kind of responsibility? Or if there is wrong information coming from the use space to the pilot somehow, and that's impacting the accident. So is there any difference in responsibilities?
So first we need to differentiate between responsibility and liability. Liability will not answer because it depends of each scheme between member states. But actually, we don't have nothing different than what we have today in man aviation. If you are a pilot, you are not properly trained, you take off and you crash yourself, that's your responsibility. If the maintenance has not been performed, that will be the responsibility of the maintenance organization. If there is a defect in the structure of the aircraft, that will be the aircraft manufacturer. So similarly here, if in BVLOS you have a matter, but the USSP gave you wrong information, quite likely the responsibility of the USSP will be engaged. If everything is okay, but you don't properly react, you don't follow your procedure and the authorization you got, that's for you, operator, that will have the responsibility. So again, there is no single answer. That really depends on what went wrong, how, and what is the masterpieces which show some deficiencies in the system. We will take primarily certainly the responsibility. We are not here lawyers or anything, but certainly that will be the framework today. So I don't know if it answers to your questions, but we cannot say yes, that will be the operator or that will be the USP, because that will depend who will be the contributor to the event. And it's why we have occurrence reporting, it's why we have a safety analysis in order to discriminate who has been the contributor, what were the conditions which triggered the event, etc. It's why we have all those mechanisms in order to maintain safety. And it's why also we are requiring the member state to maintain that scrutiny in terms of safety in order to proactively react to the event. If you're an operator who systematically deviates from the flight authorization, maybe there is a matter either in the environmental conditions, there is too much wind, for instance, at some place, or there is something wrong with the operators, etc. So it's why we need this proactive way to manage the safety event, because there is not a single responsibility involved. We need data, and that will be also a responsibility operator the member state, to look at what's going on and to define the responsibilities in that case.
Is there, for example, requirement for the use-based operator to have certain kind of insurance, liability insurance, something like that?
Yes, and we are looking at the same for the USSPs. Through the certification of USSPs, we are looking about the insurance and the coverage that they must have with regard to the operations they are covering. So yes, all the parties need to be covered for the things they do, and then the responsibility they are taken.
But this requirement is not in the US-based regulations, it's in the 947. So the operators need to have a liability and insurance cover, but the regulation is 947. So you will not find this in the article in 664, but still they need to comply with 947. So yeah.
Now, if you let me, because we are touching these important moments, in case if there is a crash in legacy aviation, so they assign the investigation board, and there has to be a kind of inspection or investigation of the case. Is there anything like that planned for USpace? Therefore, these specific operations, or maybe licensed operations, there will be a need for investigation where all these matters that was conversation with you, Stefan and Timo, would be cleared and identified who is the guilty one.
For investigation, again, I don't know, maybe Maria have more information, but it's generally managed by the state and ICAO on top. But for occurrence reporting, yes, that will be regulated. And we are working on update of the regulation with regard to occurrence reporting and to put some requirements on the USSPs and single seats, for instance, to report safety events. So before to go to the crash, the scheme that you have today for all the other aviation organizations will be translated and implemented for the USSPs. The operators, it's already done, and NCARES has been updated, but we need to update the regulation for USSPs and single seats. That will come first. For the investigation, I have to admit that I am not knowledgeable.
For the investigation, so as Stefan said, the accident investigation, so the famous Annex 13 and how to activate it will be obviously depending on how this is then implemented in the member states. But what we can say and what it was. The discussion with the basic regulation is that when there is a drone event that is classified as an accident, in the sense that there is damage to people or damage to properties, and if the drone is damaged and is in the certified category, so it's also classified as an accident, obviously there will be the activation of an accident investigation board. And in that case, it will be then investigated like any other accident. We are aware that as in some states, they are also activating the accident investigation board, even for drones events, which the drones has crashed, has not damaged someone and has not damaged property, but it was because of a question of luck, but it could have. And therefore, they classify it as an accident, and the whole investigation was down, and with recommendations, including recommendations to EASA, like any other thing. So I could imagine in the US space, aerospace, if there is something that is going to be classified as an accident, and this is going along with the application of existing regulations for accuracy reportings, then it will be an activation of the accident investigation. And we will have, like any other accident investigations.
Yeah, 2 questions about the operators. First, maybe a little technical one. It's in slide 97, where it describes the authorized fault volumes, the contingency volume, and the operational error risk buffer. So if you can clarify, is this the operator responsibility to ask for this? If you can specify a little bit, how is it technically achieved? And the second one, the second question is about the responsibility of the operators to avoid traffic within the use space. If we're looking at VLOS, then VLOS was originally not designed for an operator to see another Phantom 4, to see an aircraft. So it's kind of hard for an operator to do that, again, inside the use space. The same goes if I'm a BVLOS operator. I'm relying very heavily on my USSP. I will have a very hard time to maneuver myself, and it seems like the balance here is a little bit tilted.
So I tried to answer, and I think we will need to the need of Vladimir on the other questions. So for the operational risk buffer and the geography as mentioned, so forget the operational risk buffer. This is not the responsibility of the operators to define what is the buffer between two drones operation. That should come from the airspace risk assessment for the deviation reducing. What is the spacing between two operations? And then you can imagine that we drive some requirements of flexibility on the accuracy on the sensors on board. If you want to have little buffers, you need to have high accuracy. If you have low accuracy, you put big buffers. So all those characteristics should come from the airspace risk assessment, which will define how to manage the volumes. And the responsibility of the operators is simply to plan his operations per the SORA today with this flight geography and contingency volume to define. We may have some models where the contingency volume may be also defined by the member state. But today we have a bit of disconnection between flight authorization and what is expected from the operators in terms of SORA. That's something we'll have to reconcile to make sure that we are totally aligned between the two. Today, the authorized for the volume from the U-Space airspace is the operational volume, so including the contingency for the operator. So it's something it should not be there in the contingency, but anyway, we deconflict it in case it goes. So that's how the services and flight authorization today works. Yeah, it encompasses the contingency. And for the rest, that's a matter of airspace structure and buffers, etc. So it's not the operator itself. Second question, please repeat.
Other operators'
responsibility.
VLOS within the use space.
Yeah. Yeah. So that's a matter of inconspicuity. You should get the information sufficiently in advance to take decisions. So it will come from, we will discuss about that tomorrow morning, because indeed it's not at the last minute that you need to undertake a maneuver. That will not work. It will be totally unsafe. So there is a discussion about what is a sufficient time time than in distance in terms of acquisition before to provide the information to the operator to let him, in transparency and in a very safe manner, manage the operations. But yes, that will be the responsibility of the operators to plan, to anticipate that kind of maneuvers all along the operations. In BVLOS, that could be complex, but maybe conspicuity will be sufficient to provide that. What is your view, Vladimir?
Yes, there are three means, and as you can imagine, there will be unlikely that faster as certified planes will be utilizing SRDH60 channel. They will be going for ADS-B out most likely, or solely for that device. But there is also opportunity to mention here that military operation or state operations, which are not subject to use space requirements, so they can do other things. For that purpose, we have provided in a guidance material not only into Regulation 664, but also to Regulation 666 on this SERA requirement, some considerations. And I'm also glad to inform that the European Defense Agency is finalizing the text of the military views on e-conspicuity and how that should be taken forward. Because they have full right not to be conspicuous for obvious reasons. So there will be other methods how to integrate this and consider this traffic in use space. And I will just remind everyone that this all would need to be considered also in airspace risk assessment mentioned by Stefan.
Can we proceed to the next one? Oh, sorry, no.
Sorry, very official my name. So we got permission to operate drones with BVLOS in medical logistics. Two questions. The first one is, I spoke with some potential use case providers, and we checked the business plan, and we tried to compare with our business plan and their business plan. So all the regulation from the process is perfect. But behind every process, in my head, I have numbers, with a euro sign behind. So currently, we have a gap of 200 times between what I can pay and what the USP provider need to cover the cost. So that is a big challenge. Currently, we are discussing a perfect process, but not how the operator can use the service without dying in this. This is part one. This is more of a statement. The second part is, in the medical logistics, we are handling dangerous goods. Dangerous goods in S2, S3, we have a very complex ERP. So that means if we enter in use space and we face into an emergency situation, so how we can handle it? Normally, I would say I have to take over the use space in operation because we have the people that know, we have the ERPs how to handle dangerous goods in a dangerous situation. So for my liability here, from the ERP, for me it's difficult to understand how to interact and how to communicate with a use space provider in such a special case. Thank you.
For the first remarks, yes, we are aware, and obviously the implementation and the business case for implementing US space is something that everybody is looking for. And at the moment, you have been authorized to operate BVLOS, and probably at the moment there are not so many drone operators, so who can probably share that part of the price. But and then the question is it then the US space the solution? So obviously, but as soon as you will have many other operators, then it's the solution conducting the same BBLOS operations in the same area. And therefore, obviously, the prices will be shared. But this is, again, my personal opinion, is really not the responsibility we have discussed this morning of EASA. And yes, we are talking about the implementation, the technical implementation, the bits and pieces, but we are not really in the business deployment in this workshop. The second, you are carrying dangerous good, and this is have two things. So again, per SORA, you will need to comply with certain already OSOs when you carry dangerous goods, because you quickly end up, if you are in an environment where you cannot mitigate certain risks in certifying things. So already this has some connotations. But when you are in the US-based aerospace, in the flight authorization, you will need obviously to consider when you request a flight authorization, the contingency that may happen for your specific carriage of dangerous goods, and the US-based aerospace service providers need to provide you flight authorizations proposals based on what your contingency measures are. So it needs to be part of your flight authorization request. Obviously, it requires more planning and more process, but yeah, so it's dangerous goods. So depending on what you are carrying, as you said, so collision can be catastrophic immediately. So it depends what you are carrying, but yeah, so that's obviously has higher consequences, and this needs to be provided in the flight authorization request. And see if this can be supported with the flight authorization there.
And I would like to complete something, because for your intervention, understand that you consider, maybe for very good reason, that your operations have priority on the others. This is not something we are regulating. That's right. We have regulated special operations over drones operation. But inside the drones operation, you may have safety critical or time critical operations, like yours, and delivery of coffee. And indeed, we have not proposed a scheme of priority for services, but customer services in that case, because who are we to decide that, okay, we may perceive the very high social value of your service compared to others, but we don't have scheme. We are not able to define a prioritization between operations which will satisfy all the community. Because, for instance, if you give your priority, for sure, we will impair the activities of a drones delivery or something like that. So if there is a need, we are really welcome. And the same thing we wanted to discuss 6 months ago, but we had no time. If there is a consensus about a scheme of prioritization between operations, that could be part of one AMC or GM. But first, also, the member state may take some responsibilities, believing that for themselves in a given member state, they want to give more access to you on some others. I don't know. But it could be also a discussion directly with your member state to ensure that you will have the access to the airspace, because for sure you have much more value than other services. So I recognize that we don't have. If there is a proposal and a consensus, we may revise, and I would welcome any idea on that, yes.
Okay, colleagues, I think we are approaching the landing phase of today's workshop.